A powerful burst of gamma radiation lasted a mere half second, but it released an enormous amount of energy. It was more than our sun would produce in 10 billion years. This brief flash lit up the whole sky. Afterward, a much softer and more long-lasting glow replaced it. Astronomers examined the phenomenon with X-ray, radio, optical, and infrared waves. It turned out that people had finally seen a newborn magnetar for the first time ever. It was likely formed after two neutron stars had merged. It resulted in a kilonova, one of the brightest and largest stellar blasts. Its light finally reached our planet on May 22, 2020. Imagine a massive star, at least 5 times the mass of our sun, reaching the end of its life. It might be because it's run out of its nuclear fuel. If it happens, the star starts to cool off. The pressure inside drops, and the gravity starts to squeeze inward. And then, more than 1 million times the mass of our planet collapses within 15 seconds. It happens so fast that an enormous shock wave causes the outer part of the star to blow up. It produces a blinding burst of light. This powerful blast is called a supernova. What's left behind is an incredibly dense core with a huge cloud of hot gas, called a nebula, expanding around it. If the star has been massive enough, more than 10 times the size of the sun, it's likely to turn into a black hole. If not, it turns into a neutron star. It's basically a giant nucleus, the central part of an atom. These stars are mostly made up of neutrons and are rarely larger than 20 miles across. For comparison, our sun is almost 865,000 miles across, which is 109 Earths put side by side. But don't let this relatively tiny size fool you. Any neutron star is at least 1.5 times heavier than our sun and has an intense magnetic field. If you scooped just a teaspoon of this star's insides, this matter would weigh more than 1 billion tons. It's so dense that it makes neutron stars some of the most extreme objects people know about. The next stop is the black hole itself. When two neutron stars merge, they most often create a new, much heavier one. Within milliseconds, or even less, this star collapses into a black hole. But the astronomers who examined the flash of light recorded in March think there might be another outcome. They're almost sure they saw something never observed before: the birth of a magnetar. That's a rare form of a neutron star with an ultra-strong magnetic field. It's 1,000 trillion times stronger than our planet's. This field is also so powerful, it heats the star's surface up to 18 million degrees Fahrenheit. To put it simply, magnetars are the most powerful magnets in the universe. Their magnetic fields can seriously mess with the neighborhood. Atoms, unlucky enough to get close to such a star, get stretched into pencil-thin lines. If you somehow found yourself several hundred miles away from a magnetar, it would end badly for you. The magnetic field would first disrupt your bioelectricity. It means that your nerve impulses wouldn't work anymore. Even your molecules would change under the influence of the star's field. In the end, you'd pretty much vanish. If a magnetar flew within 100,000 miles from our planet, it would wipe out all the data on every single credit card in the world.
The protective shield of our planet decays and eventually fails. So do our satellites. First, communication satellites in the highest orbits go down. Next, astronauts in low Earth orbit can no longer contact their mission control center. And finally, hazardous, relentless cosmic rays start bombarding everything on Earth, causing havoc and devastation. Are these the terrifying consequences of the planet's magnetic field reversal we're going to face? Right now, as you're watching this video, Earth's north magnetic pole is extremely out of whack. It's so serious that scientists will have to update the global magnetic field model released a mere 4 years ago. Does it all mean that the magnetic pole of our planet will flip soon? Well, be patient, we'll figure it out a bit later. You see, the magnetic pole is moving quite erratically from the Canadian Arctic towards Siberia, and these movements are very unpredictable. But it's normal for the pole to be moving. There are long-term records from London and Paris that prove that the North Magnetic Pole moves randomly around the rotational North Pole over periods of several hundred years. But the most astonishing thing about its movement is that it's speeding up. Around the mid-1990s, the magnetic pole unexpectedly accelerated from a bit over 9 miles to 34 miles a year. And recently, the pole crossed the international date line, moving toward the eastern hemisphere. The European Space Agency launched extremely accurate magnetic field satellites in 2013. Thanks to them, researchers have superb data they can use not only to make magnetic field maps, but also to update them every 6 to 12 months. That's how they were able to notice that the core field was weakening too. It might be a sign that the planet's magnetic field is about to flip. To understand this process better, we need to figure out how the core field works. Let's say we've got a bar magnet that runs through the center of our planet and has a north and a south pole. This magnet is incredibly strong, representing about 75% of the intensity of our planet's magnetic field at the surface. Our bar magnet is not only moving, but is also getting weaker, by about 7% every century. Admittedly, this bar isn't the perfect representation of the core field. It's more like electric currents generating Earth's magnetic field. Still, this model makes it easier to see what's happening to our planet now. The magnetic field of our planet plays an important role in protecting us from dangerous radiation and geomagnetic activity, which is the product of the interaction between the solar wind and Earth's magnetosphere. Earth's magnetic field also moves. Scientists have been studying and tracking the movement of the magnetic poles for hundreds of years. The historical motions of these poles indicates changes in the global geometry of the magnetic field of our planet, and they may point to the beginning of the field reversal too. That's what the flip between the north and south magnetic poles is sometimes called. You see, if the north magnetic pole moves a bit, it isn't a big deal. But a complete reversal might have a serious impact on the climate of our planet, as well as modern technology. Luckily, such flips don't happen overnight. The entire process stretches over thousands of years. Plus, even though the magnetic pole weakens during a pole reversal, it doesn't disappear completely. So those scary events from the beginning of the video aren't likely to happen to us. The magnetosphere will continue protecting the planet from cosmic rays and charged solar particles, even though there might be some amount of particulate radiation that will make it to Earth's surface. Magnetic fields are generated by moving electric charges. If some material allows these charges to easily move in it, it's called a conductor. Metal is a great conductor, and we often use it to transfer electric currents from one place to another. In this case, the electric current is negative charges called electrons moving through the metal. The current is what generates a magnetic field. Earth has a liquid iron core. In other words, there are layers and layers of conducting material inside our planet. Currents of charges are constantly moving through the core, and the liquid metal is also moving and circulating there, generating the magnetic field. This magnetic field, in turn, produces something resembling a bubble around the planet. It's called the magnetosphere, and it's located above the uppermost part of the atmosphere. This layer shields and deflects high-energy cosmic radiation, which otherwise would be extremely dangerous to people and other forms of life on Earth. The magnetosphere also interacts with the ionosphere, the layer of our planet's atmosphere containing loads of ions and free electrons and capable of reflecting radio waves. The interaction between these two layers and the magnetized solar winds is what scientists call space weather. The solar wind is normally mild, and there's no space weather whatsoever. But sometimes, the sun starts shedding gargantuan magnetized clouds of gas that can accelerate to incredible speeds. They're called coronal mass ejections, or CMEs. They're ejected from the sun over the course of several hours. CMEs usually look like giant twisted ropes and can occur spontaneously. Their frequency varies according to the 11-year-long solar cycle. For example, at a solar minimum, you can observe one ejection per day, and when the sun is in its most active phase, there might be 3 CMAs per day. Coronal mass ejections disrupt the calm flow of the solar wind and cause serious disturbances that can damage stuff both in space near Earth, like satellites, and on the planet's surface. If coronal mass ejections make it to Earth, their interaction with the magnetosphere generates geomagnetic storms. Those can trigger auroras, happening when a stream of energized particles hits the atmosphere and lights up. And then there are also solar flares. They develop more rapidly and with much more energy than coronal mass ejections. Solar flares often occur soon after coronal mass ejections. The most powerful volcanic eruptions pale in comparison to solar flares that release 10 million times more energy. Within a few minutes, one solar flare can give out billions of tons of charged particles. Solar flares are also insanely hot, with temperatures reaching several million degrees Fahrenheit. Astronomers believe that such bursts of solar radiation happen when the sun's magnetic field gets twisted in some regions. At one moment, all the pent-up energy is released. The star sends out light and particles, mostly electrons and protons. Most solar flares last for minutes, but some continue for hours. A powerful solar storm can potentially cause a devastating global blackout on Earth. If not for the Earth's magnetosphere, the effects of the sun's activity would be much more devastating. Luckily, the magnetosphere deflects most of the solar material hurtling towards our planet from our star at a speed of over 1 million miles per hour. But even so, during space weather events, there's a lot of hazardous radiation near Earth. It can potentially harm astronauts and spacecraft. Plus, space weather can damage large conducting systems, for example, pipelines and power grids, by overloading currents running inside them. Scientists regularly map and track the overall orientation and shape of our planet's magnetic field. To do it, they use local measurements of the field's orientation and magnitude. That's why they've been able to conclude that the location of the North Magnetic Pole has moved by almost 600 miles since the first measurements were taken in 1831. The magnetic field of our planet reverses on a timescale varying between 100,000 to 1 million years. One can tell how often it happens by looking at volcanic rocks at the bottom of the ocean. They capture the orientation and strength of Earth's magnetic field at the time of their creation. So, dating those rocks gives us a good picture of how our planet's magnetic field has evolved over time. From a geological point of view, field reversals happen quite fast, but they are extremely slow from a human perspective. A complete reversal normally takes a couple of thousand years, but during this time, the orientation of the magnetosphere may shift, exposing more of Earth to cosmic radiation. Such events tend to change the concentration of ozone in the atmosphere. In any case, scientists can't say for sure when the next field reversal will happen, but they keep mapping and tracking the movement of our planet's magnetic north. By the way, the Earth isn't the only planet with a magnetic field. Gas giants, like Jupiter, also have a conducting metallic hydrogen layer that generates their magnetic fields. Jupiter's internal magnetic field prevents the solar wind from interacting directly with the planet's atmosphere.
Have you ever thought about sphere? Now imagine all the living things on Earth, like plants, animals, and microbes, as a giant team working together. They have different jobs, but they all do their thing to make the planet a better place to live. That's where the idea of planetary intelligence comes in. Just like individuals and groups can be intelligent, so can an entire planet. Researchers believe we should measure the planet's intelligence by its ability to keep itself going forever. And just like how humans need to work together to survive, a planet's collective intelligence is measured by the capacity of all the life on it to work together towards this same goal. It's like the planet is a complex system that knows how to take care of itself. Like forests. They can share nutrients through their secret underground networks of fungi. This helps all the trees stay healthy. We can obviously learn a lot from forests. If we jump into the fantasy universe while looking for intelligent, conscious planets, we'd definitely choose Mogo from Green Lantern. It's a specific planetary entity that can do things like changing its weather and altering gravity, plant growth, or some other surface conditions. Or how about the stunning Pandora from Avatar? Do you remember the fascinating scenes of flora and fauna there? With organs that might remind you of tentacles. They enable creatures to interlink with each other on a neural level. It's like the entire planet is like one giant brain, with many smaller trees, creatures, and its other pieces as its cells. We're far from that, but it's still nice to imagine. At the moment, our civilization is in the stage scientists named an immature technosphere. That means we're still too focused on using technology that doesn't always do good for our planet. We don't have a planetary intelligence or a collective understanding of what needs to be done to do better for our planet. Instead, we're all just doing our own thing. I mean, we're not at the worst stage. Researchers have come up with 4 stages of Earth's past and future to explain how planetary intelligence could impact the long-term future of humanity. The first stage is what we call the immature biosphere. It's when life first started on Earth, billions of years ago. Only microbes were there on the bare land without any vegetation. There wasn't any global feedback, which means these microbes couldn't yet affect Earth, its atmosphere, or other systems in any way. The second stage is the mature biosphere, which was 2.5 billion to 540 million years ago, when stable continents formed and the biosphere started to have a strong influence on the Earth. The third stage, known as immature technosphere, is where we are now, with interlinked systems of communication, technology, transportation, electricity, and computers that draw resources from Earth's systems and affect the biosphere. The fourth stage, also known as the mature technosphere, is where Earth should aim to be in the future. It means technology will benefit the entire planet. We'll use sustainable forms of energy, like solar power. Planetary intelligence is the sign of a mature planet, and researchers are trying to figure out how we can move towards it. So, things we do on an individual level do matter. The collective activity of life, like microbes or plants, can change a planet and make it more than just a lifeless rock floating in space. Through the biosphere, our home planet kind of figured out how to host life by itself billions of years ago, and it's still going. Now we need to figure out how to have a similar kind of self-maintaining system, but this time with the technosphere. It's hard to imagine planets could generally become sentient, like Pandora, or some other imaginary conscious world out there. There are a few reasons for that. First, planets form based on how different materials, like rocks, gases, and liquids gather around a new star. It's like you have a big family gathering, where everyone brings different ingredients to make a delicious dish. And just like how these ingredients won't suddenly turn into a living being, the materials that make up a planet won't just turn into self-aware creatures. On Earth, after billions of years of complex chemical reactions, some molecules started to replicate themselves and carry information. That's how life on our planet began. And Earth is the only such example we have. Here's the second reason. Imagine you have a big garden where you plant a lot of mushrooms or bacteria, hoping they'll become really smart and help you take care of the garden. But mushrooms and bacteria don't have brains like we do. It's not like they need it anyway. Having a big brain is really expensive for animals too. It takes a lot of energy to keep it running. So, animals only become as smart as they need to be to survive and thrive in their environment. Dogs and cats are pretty smart because they need to be able to avoid danger and find food. They don't need human kind of intelligence for things like building houses, creating art, or inventing new technologies. So, it would be hard to bring all living beings and plants to the same level of intelligence. The third reason why it would be difficult for a planet to become sentient is the main rule of the animal kingdom. Life is all about survival of the fittest. Every creature is competing for resources like water, food, and space. But not only do different species compete against each other, but individuals within the same species also fight. Just think of how fiddler crabs fight for territory on the beach, or how wolf packs fight over prey. Or me, when I see an empty spot on a crowded beach. This kind of competition is not a good base for global cooperation. There are a couple of exceptions to this rule. For example, ants. They may not be the brightest creatures on the planet, but when they come together in colonies, they can achieve amazing things, like gathering food that's way bigger than them, building nests, raising young, and even farming. In fact, they act like a superorganism called a hive mind, where every ant works together towards a common goal. Insects like bees and ants are very altruistic and work together to ensure their queen reproduces. If one large ant colony took over our whole planet, it could act as a single mind and work towards the colony's and planet's interests until they run out of resources. But in reality, it's hard to imagine any organism, even a superorganism, could reach such a level of self-awareness and consciousness. Number 5. How could we keep in contact? When it comes to communication, ants use pheromones and humans use nerves. Both of these methods work well for small organisms, but when it comes to a giant planet-sized entity, it would be hard to make such communication fast and efficient. So, communication within a planet-sized entity would be much slower than what we have in our homes, like our computers or smartphones. Oh well, we'll just continue dreaming about Pandora.
Just recently, our sun unleashed a supermassive solar flare. And it was the most intense one in 7 years. Solar flares are powerful explosions happening within the sun's atmosphere, intense bursts of radiation rising from the surface of our star. How dangerous are they for us? Let's figure it out. Solar flares can indeed affect life on Earth, disrupting everything from power grids to GPS. They can have an impact on spacecraft and astronauts. They produce auroras, painting the sky with vibrant colors near our planet's poles, which is actually not a drawback but a very beautiful view. The most recent flare, part of a series of flares, was classified as an X6.3 event. This classification is based on the X-ray brightness of solar flares. There are 5 classes of solar flares, with A being the weakest and X the most powerful. Each class also has 9 subdivisions, from 1 to 9. The flare in question wasn't as monumental as the flares of September 2017. Those included an X9.3 and an X8.2. And still, it was an awe-inspiring display of energy. The flare stood out as the largest of its kind during the current solar cycle. A solar cycle is a period during which the sun's magnetic field undergoes a complete reversal. One cycle usually lasts for about 11 years. At the moment, we're in cycle 25. It started in 2019 and is likely to last till 2030. The progression of the cycle has an impact on the star's activity levels. The sun is quite tranquil when the activity is minimal, and at solar maximum, this activity reaches its peak. During this period, we can observe lots of solar flares and sunspots, areas where the magnetic field is around 2,500 times stronger than that on Earth and higher than anywhere else on the sun. The particles ejected by solar flares take roughly 2 days to reach our planet. They often ignite auroras, During the most extreme solar events, these auroras can be seen not only close to the poles but also further away. Solar flares and related coronal mass ejections can pose a threat to our world that heavily depends on technology. The problem is that high-speed solar winds emanate from coronal holes. Those are openings in the sun's magnetic field where streams of solar winds rush out of the atmosphere of our star. The plasma in these regions, with coronal holes, is cooler and denser than in other parts of the sun's corona. Insanely fast, solar winds can worsen the situation, impacting our technology and leading to greater disruptions on Earth. You've probably seen headlines like, "Solar storms of 2025, Earth's doomsday is coming." They cause anxiety and panic. Totally unnecessary. It's true that the Sun is entering a period of increased activity, which will culminate in July 2025. But these claims about doomsdays, apocalypses, and absolute destruction are not based on scientific facts. Solar storms are just a natural phenomenon, and while they do affect our planet, experts don't expect any catastrophic events to occur even in 2025. Our power grids, communications, and GPS navigation may end up somewhat disrupted. However, the severity of the situation will depend on the direction and strength of the storm. That's what you need to know about the upcoming events. Since solar cycle 25 will most likely peak during that period, there will be more chance of observing solar flares and coronal mass ejections, CMEs. Earth might witness disruptions at different levels. Solar flares will likely interfere with radio communications and GPS navigation. And CMEs, which impact Earth's magnetic field, may trigger geomagnetic storms, potentially leading to power outages and satellite damage. We should be aware of the potential consequences of these cosmic events and take precautions like having backup power sources. But it's crucial to avoid panic. NASA and NOAA, National Oceanic and Atmospheric Administration, regularly provide updates on space weather. They actively monitor the sun, and you can stay informed through reliable sources.
Electronic satellites suddenly go out of control. There are voltage surges across the globe. In some places, there's a complete blackout. Scientists have little data on this incredible solar behavior, so we're still unable to accurately predict how or when exactly the next geomagnetic storm will happen. One such event took place back in July 2012, but thankfully it missed us. Not by far, though, by a mere 9 days. Just to give you a glimpse of what nearly happened, I need to explain some astronomical basics. A solar storm is a series of effects we feel here on Earth after certain events occur on the Sun. Our star is nothing more than a huge ball of molten gases that are constantly moving around, so these events happen more often than you'd think. For a solar storm to begin, our Sun needs to emit bursts of energy. They're in the form of solar flares and coronal mass ejections. These two phenomena send electrical charges and waves of magnetic fields toward the Earth at an astonishing speed of about 3 million miles per hour. When these solar storms reach our planet, we can see northern lights display in locations close to the Arctic Circle. But they can also mess up satellites or other types of electronic communications. Some of these solar storms can be dangerous, and back in 2012, we came close to experiencing a very powerful one that could have had a serious outcome. The most powerful in as much as 150-plus years, based on research done by astronomers. But how did we manage to escape it? Did we have something to do with it, or was it just a pure coincidence? What we do know is that one of those coronal mass ejections did hit the Earth's orbit in late July 2012. Our planet had already left that specific location as it was on its scheduled trajectory around the Sun. So you might be asking yourself at this point, what if it didn't miss us? Turns out these intense solar storms are dangerous to all sorts of technological objects. Given we are now literally surrounded by electric objects, from our phones to our cars, try to imagine what would happen if they all stopped working all of a sudden And here's how they work. Solar storms start with an explosion, or a solar flare. Then X-rays and UV radiation travel to our Earth at the speed of light. Some of the side effects? Well, they can include radio blackouts and GPS navigation errors. The effects can continue as minutes, or at times hours later, energetic particles reach our atmosphere. They move only a bit slower than the speed of light, but they can electrically shock the Earth's satellites and damage their components. Lastly, about a day later, clouds of magnetized plasma reach us as well. They can cause huge power blackouts, more or less paralyzing everything with an electrical plug. We might not even be able to flush our toilets, since most water supplies in cities use electric pumps these days. The effects of these geomagnetic storms would be different around the world, though. Solar storms are curious by themselves, but why do they affect some locations on Earth more than others? Based on recent research, geology has a lot to do with it. But I need to take you back a bit to paint you the bigger picture. Buckle up, because we're taking a trip in the time machine to a time when the moon didn't even exist yet. 4.6 billion years ago, our solar system looked a lot different than it does now, and that's putting it lightly. Hundreds of new planets began to form around the new sun. Planets like our own Earth, Venus, or Mars were still hurtling around the cosmos. Back in the 1970s, an astronomer named Donald R. Davis developed a theory that said the moon was born when another planet hit a newly formed Earth about 4.5 billion years ago. He also indicated that it might have been the size of Mars and later named this planet Theia. It's difficult to imagine what that impact might have looked like, even with the equipment we have these days. The astronomers suggested the giant impact hypothesis, trying to piece together this mystery. After running into our planet, the outer rocky layers of both Earth and Theia were projected into a circle of cosmic matter. Out of this debris, what we now know as the Moon was born. The Earth's core has apparently consumed Theia's iron core, that is, if it had any. Our planet also got into the position it occupies today. This way, it became more susceptible to geomagnetic storms. Back then, there was little to no information as to what might have happened to Theia, apart from giving us our only natural satellite. It took several years for a series of scientists to come up with an exciting new idea that revolutionized what we knew about our planet. What was left out of Theia is hiding under two continent-sized layers of rock deep within our planet. This theory is also one of the only explanations for why the Moon is so dry and doesn't have much of an iron core. But why is geology so important when it comes to geomagnetic storms? Well, that's because recent data revealed that the type of rocks below your feet can affect how well your city adapts after powerful geomagnetic storms. Some types of rock, like sedimentary rocks for example, generally have more space filled with water, which makes them electrically conductive. Other types of rocks are denser and have more resistance when it comes to electricity. Whenever such a storm happens, people living in the New England Highlands may have a higher risk of experiencing major disruptions. At the same time, those in the mid-Atlantic coastal plain have less to worry about, simply due to what's hidden beneath their cities. How did we know how scary these storms are? Well, this wasn't the first time it happened. Solar storms have dazzled the astronomer community for many years now. The most iconic event of this magnitude was the Carrington event, which happened way back in September 1859. It gave us a sneak peek of what the power of the sun is, to say the least. They named it after an English astronomer, Richard Carrington, who witnessed the solar flares himself. The power of that solar storm was something humans had never experienced before. The strong geomagnetic storm caused northern lights as far down south as the territory of Hawaii. On the morning of September 1, 1859, Richard Carrington made his way into his private observatory, located outside of London. He opened the observatory dome to have a complete view of the sky and directed his telescope to the location of the sun. He saw a bunch of huge dark spots that gleamed on the surface of our star. Shortly enough, Carrington noticed two enigmatic areas, intensely bright and full of white light bursting out from the sunspots. They disappeared 5 minutes later, but the effects carried on all across the Earth's surface. At first, later in the night, telegraph communications all around the world started to malfunction. Flashes of light started to burst from telegraph machines, disturbing the operators and even setting papers on fire. Brightly colored auroras started to appear in the nighttime skies all over the world, making confused birds chirp at night. Some people even began their daily activities, since they mistakenly thought the day had already begun. These days, our planet is laced with a mega information web, so the impact of such a solar storm would be even messier. Back in the 1800s, the telegraph system was just starting out, but this Victorian internet was an important way of sending news and private messages. Even in the United States, telegraph operators had noticed local interruptions because of thunderstorms and northern lights before. But the Carrington event and its effects were something they had never seen before. A lot of telegraph lines in North America became useless. One telegraph manager based in Pittsburgh even recalled that the currents flowing through the wires were so strong their platinum contacts were in danger of melting. Another example was that of a telegraph operator located in Washington, D.C., named Frederick W. Royce, who was hurt as his forehead touched a ground wire. Samples taken from the Earth's icy locations tell us that the Carrington effect was twice as big as any other solar storm experienced in the last 500 years. It's very difficult to imagine what the impact of a storm of that magnitude might be today. But based on a 2008 report drafted by the National Academy of Sciences, it might cost us between $1 trillion and $2 trillion in damages. There are things we can do individually to help reduce the amount of damage, though, like buying a generator or installing a backup energy supply. This can be either a solar panel or a wind turbine. More so, we can equip our houses with surge protectors that connect to our electrical panels and can save us from lightning and other power surges. The simplest solution of them all? Just unplug all the devices you're not using at any particular moment. If they aren't connected to a power source, they can't be affected by any surges. Ah, beautiful! You're walking with your friend and look up at the sky. The sun looks a bit different today, like it has some kind of ring around it, a rainbow type thing. Huh? Hey, look at that! Your friend pulls his head up out of his phone. You shouldn't look directly into the… Stop everything, he says. It's a sun halo. We need to find shelter now, unless you have the world's biggest umbrella on you. A sun's halo is nature's sign that there's a snow or rainstorm on its way. It's caused by clouds that are made of bazillions of small ice crystals, flying around 20,000 feet. Sunlight goes through those crystals, which causes the light to split and refract, like when there's a rainbow. Now, don't look at the sun halo directly. It's going to be tempting because it's not something you see every day. Plus, it's really beautiful. But ultraviolet light can burn the exposed tissue of your retina and cause serious damage. So, not worth it. Grab some sunglasses and you're good to go. This phenomenon lasts about 40 minutes. These clouds are the same ones that can cause a spooky ring around the moon at night sometimes. Nature sends early signs of disasters in many ways. J-shaped trees means there's a landslide coming. Since the ground is moving slowly, the trees grow into the super selfieable shape. Try to find a flat area and avoid going near any trees, unless you have superhuman strength. You're on a nice walk on the beach. Sand, sun, not a cloud in the sky. Then, out of nowhere, you see the ocean going back away from the shore. Suddenly, you can even see bits of coral, small fish, and other random small sea animals. That's a good sign to leave. There might be a tsunami on the way. A tsunami is formed when there's an earthquake underwater, and it can hit the coast at 500 miles per hour. It's mostly a Pacific Ocean thing, but why risk it? If there's a channel of choppy water on the beach, stay away. There might be a rip current under the surface that can be extremely dangerous. Sometimes waves hit the shore in a weird way, which forms these rip currents. You might see a strange gap in the waves, or you might notice random bits of seaweed going in all different directions. If you don't ever find yourself caught in a rip current, try to stay afloat and don't waste your energy swimming against the current. Yell out for help and try to float your way along the beach. Once you break out of the channel, swim diagonally to the shore. If you find yourself in the ocean and see a group of sharks swimming, okay, this scenario doesn't sound good either way. Well, the good news is they're not necessarily coming for you. The bad news? The sharks might be trying to escape from a huge tropical storm or even a hurricane. Sharks can sense these things, so when nature gets angry, they group together and swim deep under the surface to get to safety. You probably shouldn't follow them. Good luck! The golden rule since ancient times: follow the animals. Insects, rats, and snakes leave their homes a couple of days before really big earthquakes. Scientists can't track or really explain how they know it's coming. It seems animals really can sense earthquakes, maybe because they feel those smaller initial shock waves that we don't even notice. What if you see animals running towards you? Well, that could mean you're about to get eaten for breakfast. Or it means there's a wildfire behind them. Amphibians like frogs, toads, and salamanders try to protect themselves by burrowing down into the ground. Others just run. Before you start running alongside them, check to see if you can see smoke. You don't want to sprint flat out for nothing. Well, it's not just animals. We can spot warning signs too. For example, if you notice your hair suddenly starts to stand on end and your jewelry starts to buzz, take shelter right away. Lightning might be about to strike somewhere nearby. If you're outside and can't run into a house, make sure not to stand near any tall structures. Lie flat on the ground. Be near water. Seek shelter under an isolated tree or stand in an open space. And don't stand on top of the Empire State Building. That thing gets zapped hundreds of times a year. Do you like skiing? It's all fun and games until all you can see is white. Avalanches can move up to 80 miles an hour, so watch for some warning signs. Does it feel hollow when you walk in the snow? Are there cracks around your feet? Can you see a huge avalanche coming? Time to go! Sometimes a storm mixes its blue light with the red light from the sun, and you get a pretty impressive green. Enjoy it from a safe distance, preferably indoors. This super tall thundercloud usually means you're about to get smashed by hail, or worse, a tornado. Find cover somewhere, like in an underground parking lot or a basement. It might be a bit embarrassing if you're wrong, though. Okay, we know volcanoes can be dangerous, but the lakes near them? Is anything not a sign of danger? Lakes that are near something boiling hot that never cools, so volcanoes, are like wildly shaken soda cans, just about to burst. The magma that's underground actually pushes carbon dioxide into the bottom of the lake, and that gas stays there, waiting. Then, even something boring like rain can disturb the lake a little too much and bam, or boom! You get the picture. Diving, swimming, snorkeling, the sea can be amazing, but it's pretty unpredictable. When two wave currents run into each other, they can create a cross sea. It looks pretty cool from far away, but it can be really dangerous for swimmers, surfers, or even ships. There's a strong current roaming around under the surface. You're walking on the beach, apparently every good story starts like this, and all of a sudden, ooh, a cave. How cool is this? You should probably go in there, explore a bit, and no. If there's a full moon out, you might not be able to get out of that cave. A full moon affects the tide and makes it lower than usual. That cave might be more accessible, but instead of an exciting adventure, you could end up trapped in there until the next full moon. Bring a big lunch. A wall cloud is one of those things you're both excited and scared to see. Scared because you don't know what it is. Excited because, well, how often do you see something like that? Whatever you feel, tell your legs to start running. During a thunderstorm, these wall clouds sit lower than anything else and can be up to 5 miles long. And if they start spinning, well, Dorothy ended up in Oz. Who knows where you'll end up? It's 2009 in Italy. A man was hanging out in his kitchen. Then he saw some flickering lights. He knew just what to do. He moved his family to a safe place. A couple of seconds later, a massive earthquake hit the whole region. His family survived thanks to his quick reaction. He knew these flickering lights were actually a sign of an upcoming earthquake. People have been seeing these mysterious lights for ages. Some thought it was some kind of sign coming from space. Scientists never used to take them seriously, but after the invention of photography, more and more evidence of these strange lights appeared. Soon, they realized the connection. The lights appear, and pretty soon, the earthquake hits. After a bit of digging around, they actually found some records of these earthquake lights from hundreds of years ago. There were bluish flames coming out of the ground right before an earthquake. Ooh, creepy. Oh, ocean, come on, not you again. Okay, but just one more. If you see the oceans turned all reddish-brown, don't go in the water or anywhere near it. This red tide is caused by toxic algae and is something you can find all over the world. That toxic algae can be there even if the ocean's a normal color. Getting that stuff all over you can cause some health issues. Rinse yourself off in fresh water as fast as you can. You know, they even wrote a holiday song about it. Algae home for Christmas. No, really. The only life that we are certain about so far in the entire universe is on planet Earth. Whether that life is intelligent is, let's say, arguable. But anyway, it's not surprising that we're tirelessly searching for life on other planets. So far, they've discovered more than 4,000 of them. But what's even cooler? NASA has compiled a new list of 24 planets that aren't just Earth-like, they're better. The conditions on them are so good that they're more comfortable than on our planet. So let's examine some of them. KOI 5715.01. Let's be coy, shall we? This wonderful planet is in the constellation Cygnus. And why is it so wonderful? Well, our sun is a yellow dwarf. And sorry, sun, even though you're not bad at supporting life, there are some stars that can do it better. Nothing personal. The planet KOI 5715.01 orbits near an orange dwarf. Orange dwarfs are stars slightly smaller than our sun and have a little lower luminosity. Did you like the alliteration there? Anyway, don't worry, it doesn't mean we're going to live in complete darkness. In fact, if the planet is found closer to the sun and it has a thicker atmosphere, it may even be lighter and more colorful than on Earth. Now, our sun has a very short lifespan. Right now, it has 7 to 8 billion years left to live, a little longer than Earth's age. But orange dwarfs can live from 45 to 70 billion years. This is great not only because we'll be able to hang out on this planet longer, but also because the planets around these stars have more time to form life. Now, ideally, we would need to find a planet next to an orange dwarf that is about 7 billion years old. It's very likely there will be at least some organisms there. KOI 5715.01 is about 5.5 billion years old. Yeah, it may not seem mature enough, but that's okay, neither do I. Our Earth is a billion years younger, and that didn't stop us. The planet is quite close to its star and is in a habitable zone. 1 year there lasts 190 days. Imagine going to elementary school and already getting a driver's license. It's almost 2 times larger than the Earth. The average temperature there is 52 degrees Fahrenheit, which is slightly less than ours, 57. But it mostly feels warmer there because strong gravity helps it hold on to heat in the atmosphere longer. It's a little too far away though, like 3,000 light-years from Earth, which is about 18 quadrillion miles. Yep, better bring a really big lunch with you. KOI 3010.01. This planet is found next to the star KOI 2010. This planet sounds like a very pleasant world. The average temperature on this planet is 67 degrees, so a little warmer than ours. But that's a good thing. Scientists believe that on a perfect planet, The temperature should be just about 10 degrees hotter than on Earth. The more heat there is on the planet, the more comfortable it is to live there. Also, the higher chances of developing life. The radius of this planet is nearly 1.5 times larger than Earth. There's some atmosphere, although we're not yet sure about its composition, but it's probably like the Earth's. Scientists think that we'll find an ocean there, and it can cover up to 60% of the surface, which is also cool. In a perfect world, water and land should be distributed more evenly than on our planet. A little more land means a little more territory and resources, right? But listen, this planet is actually very similar to the Earth. The semblance is so striking that scientists believe we have an 84% chance to find life there. Of course, not necessarily an intelligent life, but at least some animals. Wouldn't that be cool? Now, what do you think they could look like? Very Earth-like planet, but with stronger gravity. Well, if someone lives there, they're probably big but have a small height and strong little legs. Sounds adorable and scary. But we won't be able to find out the truth anytime soon. So far, for us, these planets are microscopic dots in space. We only have some dry, boring data about them and don't even know what they look like. We'll have to wait until we can find a way to get closer to these planets. Kepler 186f. This is also one of the best candidates for having life. This rather cute planet was nicknamed the Earth's cousin because it does have a strong resemblance. Anyway, these two planets are like sisters, not twins. Kepler 186f rotates near a red dwarf. Red dwarfs are stars even dimmer and smaller than orange dwarfs. Yeah, they'll also live for a very, very long time, but their luminosity is also quite low. However, Kepler 186f is closer to its star than we're to our Sun, so it shouldn't be too dark there. Well, at least not night-like dark. The sky on this planet is sure to be an unusual shade of red, like sunsets on Earth. What do you think? Would you like to live on a planet with an eternal sunset? The size of this planet is about the same as Earth. Not bad, not perfect. Why so? Because the coolest planets are those that are bigger than Earth and have stronger gravity. Now you'll probably say, but wouldn't it be harder to walk there and even harder to get out of bed on Monday? Of course. But on the other hand, this planet will pull the atmosphere better. The atmosphere will be thicker and denser. This means more protection from the scary space stuff, more oxygen, and more heat. Not to mention the fact that the bigger planets have more space to settle. Awesome, right? But of course, the Earth's size is also an excellent choice. Another cool fact is that the tilt of Kepler 186f is about the same as ours. It means that there should be stable seasons and a normal day-night cycle. Do you know how important the tilt of the planet is? Let's look at Mars. Mars is also, in fact, found in the habitable zone of our Sun, but its tilt is very unstable, and as a result, the entire ocean that could have been on it once now completely dried up. Today, it's just a red desert, and there's no life there. At least not as far as we know, but you see how important these tiny details are? This planet is also quite far away from us, 490 light-years. That's about 3 quadrillion miles. So yeah, we're just going to keep waiting for intergalactic travel. Kepler 62e and 62f. These planets were called the most Earth-like before we discovered Kepler 186f. They're very comparable to our home. Kepler 62e is about 1.5 times larger than Earth, and Kepler 62f is just slightly smaller than that. They're located in the constellation Lyra, which is about 1,200 light-years away from us. They both also orbit a red dwarf. 1 year on Kepler 62e lasts about 122 days, even less than on that first planet we talked about. Scientists believe that both 62e and 62f are sort of water worlds, warm places mostly, or even completely covered with water. If there is land there, it's probably just some islands. A world consisting entirely of islands. A fantasy dream for some, think Hawaii, and a nightmare for others, think Megalodon. But if you're a fan of ancient marine animals, just imagine how gigantic they could be there. Still, there are many things we don't know about this planet. Does it have a surface? What about its composition? density? One day, maybe we'll be able to answer these questions. And so, that's it for the super Earths. Of course, the original list is much longer, and you can go check it out on the internet. Now, the best thing about all this is that these are planets that are better than the Earth. But we also know thousands of other exoplanets that are just close enough to ours. And the odds are, a few of them have at least some form of life. But they're very, very far away, so we have no way to check it out right now. Perhaps, down the road, we'll find some cool creatures on many of them. The planet races through space. Its orbit is unstable, like a pool ball gliding across the table looking for a target to collide into. Only this ball is the size of Mars, and it's going 9,000 miles per hour. Boom! It crashes into another planet. This Mars-sized object was called Theia, and what it smashed into was Earth. The impact released 100 million times more energy than the asteroid that wiped out the dinosaurs. The planetary collision threw tons of solid material from both objects out into space. But only one of the bodies survived. Theia was obliterated and then swallowed entirely by early Earth. But that debris didn't go flying endlessly into the cosmic void. No, something crucial happened. All those solid chunks gathered into a cloud. Gravity squished it together, pressing more and more. And in the end, our moon was born. So goes the theory. At the time of the impact, the solar system was just forming, and this rendezvous of epic proportions probably wouldn't have happened if it weren't for a newly formed Jupiter throwing Theia off its orbit and straight into Earth. Our young planet withstood the blow. Time passed, Earth evolved. Its surface will become unrecognizable over the next 4.5 billion years. It's hard for the human mind to understand this vast amount of time, so we'll squeeze it all into one day. If midnight is when Earth first formed from gas and dust that remained after the Sun's creation, the next 4 hours show a lifeless planet. Red hot, covered in lava, constantly bombarded by asteroids and, as you know by now, even a whole other planet. Yet life finds a way. The first cells appear. It's 4 a.m. on the clock. At 2:08 p.m., we see the first single-celled organisms form. It's not until 8:28 p.m. that sea plants appear. 20 minutes later, what's this? Jellyfish. After them, the planet flourishes with different fish, reptiles, insects. The forests grow at 10:30 p.m. Between 10:56 and 11:40, dinosaurs roamed the Earth. The giant lizards ruled our planet for less than 1 hour. A minute before the dinosaurs' extinction at 11:39 p.m., the first mammals begin to run around the planet. At 11:58 and 43 seconds, humans appear. In the cosmic scale of things, we've only ruled this planet for 1 minute and 17 seconds. So here's the main question baffling scientists. Why didn't life on Earth ever stop? It had every chance to cease. Why didn't our planet become like Venus or Mars? They both once had an atmosphere and oceans. Today, they're lifeless deserts. Forget about complex scientific concepts and theories of the universe's structure. Our little rock and all its inhabitants are just incredibly lucky. Professor Toby Tyrrell at the University of Southampton used computer programs and climate simulations to solve the puzzle of why asteroid collisions and ice ages didn't turn our little rock into a lifeless wasteland. The research team took not 10, 100, or 1,000 virtual planets similar to Earth. They used 100,000 for the experiment. And every single one of those 100,000 were simulated 100 times. They exposed these virtual planets to different phenomena. They were bombarded by asteroids, frozen, exposed to epic eruptions of supervolcanoes that blacken the skies and block the surface from the sun's rays. Just 9%, or 8,700 of them, were successful one time in 100 simulations. Of that group, 4,500 planets remain inhabited 10 times. Only on one planet out of 100,000, life didn't stop all 100 times. If life is a lottery, Earth got extremely lucky. In 2009, the unique Kepler telescope was launched into space. Its task? Search one patch of the night sky, or 150,000 stars, for rocky Earth-like planets. Over 9 years in service, it ended up surveying more than 500,000 stars. In all that time, with all those observations over nearly a decade, Kepler discovered 2,600 possible Earth-like planets. The weird thing is, most of them are a type you can't find in our own solar system. They're something between the size of Earth and Neptune. But back to the real Earth. If you go far from the city and look up at the sky, you'll see an ocean of stars. If you're lucky and it's a clear night, with an unaided eye, you could count a maximum of 2,500 points of light. Yet, there are at least 100 billion stars in the Milky Way. Some estimates put the numbers of stars in the Milky Way up to 400 billion. So, where's this giant range coming from? Well, counting stars isn't exactly an easy job. Scientists obviously don't number each one individually, 1, 2, 3, and so on. You know how long it takes to count just 1 billion? Over 100 years. Now, multiply that by 400. Instead, they look at small patches of space and use some complex scientific formulas to make educated guesses of how many stars there are in total. You can do a similar experiment yourself. Imagine a bucket filled with 10 pounds of rock, sand, soil, and other items. Your job? Understand how many rocks are in that mix. We'll count only those rocks that are visible to us from above. Get a rough estimate of their volume and weight, what percentage of the total we can see, and with some calculation, you can get a number. Is it exact? Nah. Why? Because you can't know if the rocks in the bucket are spread evenly throughout, or if they're all about the same size throughout. What if the ones at the bottom, if there are any, are bigger or smaller than your sample view? They could have completely different weights and volumes. That bucket is our Milky Way galaxy, and the rocks you are counting are stars. The point? Scientists can't know for sure how many stars there really are. Maybe 100 billion, or perhaps 4 times that. Of those, 4 billion are like our Sun. With our own galaxy, the most accepted estimate for planets that could potentially support life is 300 million. Though, as the tradition of scientific inexactness goes, that number could be up to 5 billion or more. Either way, lots of real estate to choose from. And that's just the Milky Way. But get this, it's just one of 200 billion galaxies in the observable universe. The most recent research puts that number 10 times higher, something like trillions of galaxies in space. And we've only studied less than 10% of them. As for how many stars there are in the universe, scientists put it at 1 septillion. That's 1 followed by 24 zeros. Again, it's all estimates because we can't know for sure. So far, one thing is clear. Our Earth is the only place in the universe that we know of where there's life. And this planet has done everything it can to change that. Over the past 540 million years, more than 20 major extinction events have occurred. The last one was 66 million years ago. Yep, it was the one that took out the dinosaurs, and 75% of all life on this planet for that matter. An object 7 miles across in diameter smashed into our planet. It was going 120 times faster than the fastest car today. Over 900,000 miles all around the impact site, everything caught fire. A huge tsunami swept across the world's oceans. Billions of tons of dust and sulfur rose into the sky and blocked the sun's warm rays. A global cooling came to Earth. A little over 200 million years ago, there was a lesser-known extinction event that wiped out half of all life on the planet. Most likely volcanoes or an asteroid strike are to blame. Other theories say the movement of tectonic plates triggered another ice age. At that time, huge crocodiles ruled the Earth. They disappeared, and new animals entered the arena of history – dinosaurs. But the worst this planet has ever seen was the Permian-Triassic event about 250 million years ago. 80% of marine life, 70% of land animals and plants, all gone. Volcanoes spewed out a colossal amount of lava where modern-day Siberia is, but it affected the entire planet. Around 445 million years ago, the dominant life form on our planet was marine invertebrates. There was only one continent, Gondwana, and plants were just starting to flourish on land. But something happened that took out 75 to 85% of all living organisms. It could have been an ice age, rising temperatures, or a more daring theory. Some think it could have been a huge star exploding 6,000 light-years from Earth. It launched a jet-like gamma-ray burst that ripped across space, and poor little Earth happened to be in its path. It burned off the ozone layer instantly. Yeah, we kinda need that thing to protect us. Case in point, no matter how much this planet, or even the universe, tries to wipe out life on Earth, which is here in the first place from unbelievable odds, life always finds a way.
For decades now, scientists have been discovering new planets outside our solar system. By 2023, we've found more than 5,000 of them, and many of these exoplanets could potentially even have life. Now, if you're ready for a wild ride through space, let's find out what potentially habitable planets we've discovered in the last few years. LP 890-9b and LP 890-9c. Buckle up because we're heading to LP 890-9, a red dwarf star located a whopping 105 light-years away from Earth. This star is quite cool compared to our Sun, in terms of temperature, of course. It has a temperature of about 4,700 degrees Fahrenheit. Now, this little guy may be small, but it's packed with surprises. For example, 2 exoplanets orbiting around it. Moreover, both of these planets are likely terrestrial, meaning they are rocky, just like Earth. First up, we have LP 90-9b, which was discovered in 2022 using the TESS telescope and later confirmed by the Speculoos telescope. This planet is a super-Earth, weighing in at about 13 times the mass of our own planet. It's also slightly bigger than Earth, with a radius about 1.3 times larger. And if you thought Mercury's orbit around the Sun was quick, just wait until you hear about LP 890-9b. It takes about 3 days to complete one lap around its star. Imagine falling asleep in freezing winter and waking up in hot summer. But the real showstopper here is LP 890-9c. This one was discovered by the Speculoos telescope. It's a bit further out from the star and takes a leisurely 2.5 times longer to orbit than LP 890-9b. It's also a bit larger than Earth. But its real claim to fame is its location within the habitable zone of its star. That means it could potentially have liquid water on its surface and a climate suitable for life. Now this planet becomes a prime candidate for studying its atmosphere using the James Webb Space Telescope. But hold on. It's not all sunshine and rainbows for LP 890-9c. It's also really close to its star, meaning it's full of radiation that could potentially make it less habitable. And to top it off, it's tidally locked, just like our moon. That means one side of the planet is always facing the star and is incredibly hot, while the other is always in the dark and really cold. Scientific models suggest that this planet could be more like Venus in terms of its atmosphere and climate. And Venus isn't known for being human-friendly. But despite these challenges, LP 890-9c is still a fascinating exoplanet worth studying further. Who knows what secrets it may hold? Let's move on to the next candidates. GJ1002b and GJ1002c. An international team of scientists, led by researchers at the Instituto de Astrofísica de Canarias,
has found two Earth-like planets just 16 light-years away from our solar system. They both orbit a red dwarf star called GJ1002. Our Sun is a yellow dwarf, which means that GJ1002 is much cooler and fainter than our own Sun. But that's okay. Both planets are very close to its star, so it shouldn't be too cold or dark on them. These planets, called GJ1002b and GJ1002c, are both in the habitability zone of their star, meaning they could potentially support life. Also, both of them have masses similar to that of Earth. GJ1002b is the inner planet and takes about 10 days to orbit its star, while GJ1002c takes a little over 21 days. These planets are great candidates for studying their atmospheres and could even be targets for future missions to search for signs of life. The most important thing is that these two planets could potentially support life, and that's pretty cool. Plus, the fact that they're located so close to us means that we might be able to visit them someday. Well, maybe not us personally, but you know. And maybe one day, we'll even find some extraterrestrial life on one of these planets. Now that would be out of this world. But moving on to the next one. Kepler 1649c. Kepler 1649c, also known as the Lost Exoplanet, was rediscovered in 2022 by scientists using data from NASA's Kepler spacecraft. This exoplanet is located about 300 light-years away from Earth and orbits a small, cool star called Kepler 1649. It's about the same size as Earth, and just like the previous ones, it's located in the habitable zone of its star. Initially, the data about this planet was discarded. A special computer program called RoboVetter, written to automatically sift through the volumes of Kepler data, labeled this candidate as a false positive. In other words, the program thought it was just some kind of an error or interference. Fortunately, the researchers double-checked such things, and when rechecking the data, they managed to rescue poor Kepler 1649c. Now we know that this is a terrestrial planet just like Earth, and if it really does contain water, there could even be life there. But don't pack your bags just yet. There are still many unknowns about Kepler 1649c. For example, we don't know what its atmosphere is like or what kind of surface it has. It's also possible that the planet is tidally locked, just like LP 890-9c. That would be, unpleasant. That's why Kepler 1649c is definitely worth further study. Maybe it turns out to be a perfect place for us to set up a vacation home in the future. Just make sure to bring plenty of sunscreen since the planet is pretty close to its star and things could get pretty toasty. Kepler 1638b. This exoplanet is located about 5,000 light-years from Earth in the constellation Cygnus. It's also located in the habitable zone of its star. It was discovered in 2020 by the Kepler spacecraft through the process called transiting. They basically take a bunch of photos of the star at different times. After that, the programs analyze these photos and look for small spots and dots on them. These tiny dips in brightness may mean that a planet was passing by the star. Kepler 1638b is a bit of an oddball compared to most exoplanets we've found so far. It's about 4 times the mass of Earth and has a radius about 2 times that of Earth, making it a super-Earth exoplanet. Its orbital period is about 260 days, which is quite close to our Earth, and that's great. Finally, at least somewhere, winter and summer will flow normally. Kepler 1638b could have some liquid water there. That's why it's also a good candidate for further study, to see if it could potentially support life. Let's hope that we'll find out more about this planet in the future. And finally, the last one. Kepler 438b. Kepler 438b is an exoplanet located approximately 640 light-years away from Earth in the constellation Lyra. It was discovered in 2015 by the Kepler Space Telescope. One of the most interesting things about Kepler 438b is its size and location. It's about the same size as Earth and also orbits within the habitable zone of its star. But there are a few catches. For one, Kepler 438b orbits around a red dwarf star, which are known for their high levels of solar radiation and flare-ups. This could make the surface of the planet too hostile for life as we know it. In addition, Kepler 438b has a much shorter year, only around 35 Earth days long. This could lead to extreme temperature fluctuations on the planet's surface, but maybe it's home to some hardy extraterrestrial life forms that have adapted to its unique conditions. Or maybe not. Either way, it's definitely worth keeping an eye on. This is a small list of exoplanets that we've discovered in recent years. Now, with the use of new technologies, we'll be able to find new exoplanets much more often. Let's hope that at least a few of them will really be inhabited. Have you ever wondered how the world will go down in flames? Will it be due to zombies, extraterrestrial civilizations, or AI taking over? Nah, turns out it might actually be mosquitoes and scientists causing the chaos. It's funny how things created by nature aren't as threatening as the stuff that doesn't exist naturally. And you know what's on that list? Editing the DNA genome. Experiments with the genetic structure of living organisms can produce completely new species, and no one knows how nature will react to them. Let's look at an example of gene drive. So it all started with malaria mosquitoes. To somehow stop the growth of their population and prevent the spread of malaria, scientists created a gene that magically made mosquitoes only have male offspring. Several insects with this gene transmitted it to others during the mating season, and thus spread infertility. Scientists were able to stop malaria and destroy almost the entire mosquito population. But imagine if something went wrong in the mosquito genome and their population began to increase exponentially. Malaria could spread across all continents and create huge problems for all of us. Now, let's move from the little mosquito problem to a planetary disaster that can be caused by the desire for knowledge, which is deeply embedded in our nature. British cosmologist Martin Rees once said that we lived in the 1st century when human beings could determine the planet's future. It seems that it's so easy not to destroy yourself, but our nature is quite complicated. In pursuit of solving the mysteries of the universe, we have built a giant machine that, according to some people, may destroy our planet. And this device is the Large Hadron Collider. The main task of this giant machine is to accelerate particles and make them collide with one another. Scientists expect that the collider will help better understand the structure of our universe. In simple words, this is a miniature simulator of the universe. Using it may also shed light on the mystery of dark matter. During operation, the machine compresses atoms and makes them crash into one another at great speed. Perhaps this is how our universe appeared. Some people fear that a small black hole may form because of this collision. A tiny particle with a huge weight will pull all objects inside itself. Its mass will grow, but its size won't change much. As a result, it will compress the entire Earth and turn it into a ball measuring a little more than 300 feet across. At the same time, our planet will still have the same weight. A powerful gravitational pull on such a small area of matter can form a black hole that might later swallow up our entire solar system. There are also theories that the Hadron Collider could open a portal to a parallel universe with creepy monsters that would enter our world. But of course, such theories have little to do with science. Scientists have already launched the collider several times, and as you can see, nothing terrible has happened. But there is a small nuance. With each launch, scientists increase the speed of particles. Who knows what will happen when they accelerate them too much? According to Martin Rees, the probability that Earth will become a black hole is very, very small. Particles with a much larger energy charge fly in space faster than in the Hadron Collider, and nothing catastrophic happens. Okay, now let's go back to our genomic games to see what else can happen if we continue experimenting with nature. The main problem might be an imbalance in ecosystems. In the 19th century, sailors accidentally brought mice to Gough Island in the South Atlantic Ocean. Rodents had no dangerous enemies there, so their population began to grow. Mice began to displace dozens of birds from their home. The rodents attack the chicks and reduce the population of entire species. Trying to save the birds, scientists decided to get rid of the mice, but these little creatures still managed to survive. As a result, the balance of the whole ecosystem was disrupted. Using gene drive to get rid of one species can lead to uncontrolled population growth of another. Imagine that malaria mosquitoes controlled the population of some flies. And what would happen if these flies lost their main natural enemy? The population of these flies would start destroying other species, and it would begin a chain of destructive events. All this suggests that playing with things that don't exist in nature is very dangerous. We worry a lot about how artificial intelligence can take over the world and eliminate us. Still, at the same time, we don't pay attention to our actions. Genome editing can lead to positive consequences, such as the appearance of healthier people, and destructive ones, like the creation of artificial bacteria that can cause serious health problems. In general, destroying other species is a trait inherent in humans. Because of our actions, many animals have disappeared from the face of the earth. Moreover, we even destroy each other. Such aggressive behavior is our nature. And artificial intelligence doesn't have anthropomorphic properties. Its logic may be completely different from ours, and instead of destroying people, it might strive to save them. And we have something to save us from. Remember the giant asteroid that erased more than half of the living creatures on Earth? The fall of the space rock caused a massive blast wave, a tsunami, earthquakes, and dust clouds that covered the sun. Dinosaurs and other animals couldn't survive in such conditions. But what if something similar happens these days? Fortunately, we're better prepared than dinosaurs. Firstly, we have the technology to track giant meteorites and calculate their trajectory. And artificial intelligence can also help us with this. Secondly, we can destroy an asteroid before it reaches us. Several powerful rockets will quickly deal with any space rock and turn it into cosmic dust. Moreover, we will know in advance about its approach. But suppose that a huge stone the size of dozens of Everests will fly towards us. In that case, humanity should hurry with Mars colonization. But don't worry. Observing the sky shows that large asteroids capable of causing severe damage to our planet are moving in a different direction. The most giant known asteroid that could collide with Earth might do so in 2088. The probability that it will fall on our planet is 1 in 50,000, so you shouldn't have to worry about threats from outer space. What lies in the bowels of our planet is much more dangerous. Millions of tons of magma and hot gases can burst to the surface through destructive volcanic eruptions. More than 70,000 years ago, a large-scale eruption threw a tremendous amount of ash into the air, which then floated in the atmosphere in the form of a giant gray cloud for a long time. As a result, Earth's surface cooled down by several degrees, which led to one of the most massive extinctions in the history of our planet. Some eruptions happen not only inside volcanoes. There's such a thing as flood basalt. A colossal magma bubble accumulates under a vast area and begins to seep through faults in different parts. Magma slowly goes out there for many years and destroys all living things around. And the worst thing about this situation is that we can't do anything about it. Humanity has learned to track meteorites in space, but we're still not good at predicting a volcano's behavior. Even if we find out that some giant rock will wake up in the next 6 months, there's nothing we can do about that. We won't be able to prevent an eruption. All we can do is evacuate people from dangerous territory. We have no protection against earthquakes, and even more so, we can't stop the emission of ash into the atmosphere. It's possible that artificial intelligence will help us with this in the future, but right now, we're powerless. As you can see, there are several options for the end of the world for humanity, and they're all slightly different from those imposed by pop culture and the media. In the end, is it right to look for threats from space or artificial intelligence? Let's cut the Earth in half. You can see all of its layers. Here's the inner core. It's about 40 times hotter than the inside of your oven. That's the mantle, an ocean of hot lava. Here comes the crust of the Earth, the solid surface on which our civilization lives. But if you look up, there are many layers besides the atmosphere and the ozone layer. Scientists recently discovered a strange bubble here, which protects our planet from radiation. And nope, it's not the Earth's magnetic field. This bubble is made of radio waves. Our planet grows like a Christmas tree in the radio spectrum. But we're interested in low-frequency waves, the ones that let us keep in touch with submarines. So, radio waves are like light waves, or regular ocean waves. Look at this one. The distance between the two peaks is the wavelength, and the number of these waves over a period of time is the frequency. For example, there are 10 waves in this interval of 1 second. So, can you guess the frequency of this wave? Yep, it's 10 Hertz. Cell phones use waves with a frequency of 300 to 3000 megahertz. So, add 6 more zeros to that number. But waves of that frequency don't penetrate barriers well. Think of how you lose your cell phone connection when you're driving through a tunnel. That's because there is metal inside. It's a conductive material that weakens the radio waves a lot. Salt water is also a kind of conductor. So, if the submarine is deep enough, the thick layer of water weakens the signal, and we lose communication. To maintain it, we send fewer waves but make them longer. In the same amount of time, the frequency of the short waves will be much higher than the frequency of the long waves. That's why they're called very low frequency waves. But, as it turns out, these waves travel all over the Earth and even into space. This is where things get interesting. The waves collide with particles of radiation from the Sun. We think of the Sun as a friendly giant giving us light and heat, but it actually emits a lot of harmful radiation. Each flare, or the electrical discharge of material on our home star, causes an even greater burst of radiation. These particles fly to our planet, just as radio waves do. They travel 93 million miles from the Sun to Earth in 8 minutes and crash into our bubble, which acts as a shield. Basically, radiation particles from the Sun accumulate in the radiation belts around the Earth. Our planet's magnetic field traps them, and a recently discovered bubble of very low-frequency waves lies right below this radiation belt. It helps us repel some of the harmful emissions. Analysis of old studies confirmed that the radiation belts used to be much lower and closer to Earth. But when our civilization began to use radio actively, our waves raised that belt higher. No one expected such an effect from simple radio waves, but it'll give us a way to protect astronauts in the future. When you're on Earth, its magnetic field keeps you safe from radiation. You can physically see it when charged solar wind particles make the air particles at the poles of our planet glow. This is an aurora. Next time you admire this beauty, know that it's actually the Earth saving you from some extremely harmful rays. But if you're outside the Earth's magnetic field, somewhere in space, I have bad news for you. Nothing protects you there. This is a big problem for astronauts, who spend months on the International Space Station. Perhaps scientists will learn to create protective bubbles of very low frequency waves around space stations and spacecraft. The same is true for other planets. We're probably going to colonize Mars. There is no magnetic field there, and nothing can protect you from radiation. But if you create an artificial bubble there, you can reduce the harmful radiation. Another invisible bubble protecting us is the atmosphere. It's like a layer cake or an onion. Each level of the atmosphere has its own properties. The lowest layer that we live in is the troposphere. This layer contains 80% of the weight of all the air on the planet. It's also the main place where water vapor lives. And this is where the machine called weather works. The sun sends rays of energy to the Earth. Our planet's surface reflects them and heats the air in the troposphere. This makes it move and change places with the cold air. So all the wind, cyclones, storms, and tornadoes only happen in the troposphere, up to about 7.5 miles high. That's why commercial planes fly at an altitude of around 6 miles. The wind or other bad weather conditions hardly affect this area, and the air here is not as dense as it is down on Earth. Flying 1 mile above sea level is like moving through a biscuit. It's hard, but at a 6-mile altitude, flying feels like moving through light whipped cream. The plane almost feels no resistance, so it's a win-win. They save fuel and keep the passengers safe. A couple of significant downsides are that it's very cold and you can't breathe there. It's cold because there are very few air molecules to absorb heat from the ground and transfer it to each other. You wouldn't be able to breathe here for the same reason. That's why planes are equipped with oxygen masks, just in case. Let's go a little here. This is the stratosphere. There's even fewer air molecules up here, and that's where the weather probes fly. They're the kind of small balloons with computers people use to predict the weather. This part of the atmosphere also contains the well-known ozone layer. This is our shield against harmful ultraviolet radiation. Ozone is almost the same as oxygen, except it has 3 atoms in it. When harmful ultraviolet rays enter our atmosphere, they crash into the O3 molecule. The ray breaks the molecule into O2 and another oxygen atom. The ray itself is converted into heat, but the ozone regenerates quickly. A single oxygen atom joins the O2, and the ozone molecule is ready to protect us again. It's the invisible shield that protects us from radiation. It gave birth to all life on Earth. As our civilization developed, we started to emit freon gas into the atmosphere. We used to fill our old refrigerators with it. A single chlorine atom would detach from a freon molecule when in the air, and then it would bind a single oxygen atom. Now, the ozone can't regenerate like it used to. Fortunately, we banned the use of such harmful gases, and the ozone layer began to regenerate. Scientists expect it to fully recover in the middle of the 21st century. The stratosphere ends at about 31 miles. The next layer is the mesosphere, the coldest of them all. On average, it's about -140 degrees Fahrenheit. That's 5 times colder than your freezer. This is the layer of the atmosphere where incoming meteors start to ignite because of friction in the air. Then they will eventually burn up completely. The air here is too thin for airplanes or balloons to fly, but it's still too dense for satellites. So, this layer of the atmosphere is not well studied. The next layer extends from 55 miles above sea level to about 500. That's a little more than the distance between Las Vegas and San Francisco. Kármán line is situated in this layer of the atmosphere. This is the boundary between our planet and space. The thermosphere is where all our spacecraft and satellites fly. It's also home to the International Space Station. The temperature rises extremely. The air here is about 10 times hotter than your oven can produce. It's all due to solar activity. But you would never be able to feel this heat. The air molecules that carry the heat here are so small that you would literally float between them. Imagine a giant pool with only 3 drops of water. That's the thermosphere. And the highest layer of our atmosphere is the exosphere. This is the widest layer of our air bubble. Scientists believe its boundaries are about halfway to the moon at 120,000 miles. This is the point where the pressure of solar radiation begins to exceed the Earth's gravity. It's still part of our atmosphere. This means that astronauts who went on various space missions and have been on the ISS have actually never left the Earth's atmosphere.
Voyager 1, which has been traveling through interstellar space for more than 45 years and is trailing a long gray beard by this time, not really, it suddenly began to send strange signals to Earth. Even more bizarre, there are no signs that the probe has broken or anything. Scientists from NASA are desperately trying to find the reason. So, what's happened exactly? First of all, let me tell you a bit more about Voyager 1 and its long journey. Voyager 1 is an American space probe. Scientists from NASA sent it into space on September 5, 1977. Voyager's goal was to explore the outer planets of our solar system, namely Jupiter and Saturn. Initially, scientists assumed that the mission would take about 5 years. Haha, the joke's on them. The probe exceeded all expectations. Not only did it fulfill its mission, but it's still working for much longer than expected. Voyager 1 has been wandering around space for more than 45 years. It's hard to estimate what Voyager 1 has done for science. Firstly, it successfully sent a lot of photos of Jupiter and Saturn to Earth. By the way, you can even check out these photos yourself. All of them are published on the NASA website. Thanks to Voyager, we also discovered several new moons of Jupiter and a previously unknown system of its rings. We learned that Jupiter's famous red spot is actually a giant superfast storm. And after leaving Neptune's orbit behind, Voyager also sent a lot of important data about interstellar plasma. So Voyager 1 successfully proved to scientists how useful it was. After that, it happily headed for its next goal, the Kuiper Belt and the heliosphere.
The Kuiper Belt is a ring of icy bodies that extends from Neptune to a distance of approximately 50 AU from the Sun. It's kind of similar to the asteroid belt, but about 20 times wider and 100 times heavier. And the heliosphere is an area around the Sun where the pressure of the solar wind is balanced with the pressure of interstellar gas. Yeah, I know, it sounds like some hard scientific stuff. Just keep in mind that this data really helps us understand the universe as a whole. So, this is Voyager's last task, to tell us more about interstellar space. The probe has already sent us more than 60 frames for a mosaic of the solar system from a distance of over 4 billion miles from Earth. Scientists use these frames to make a big colored picture. The photo was called the pale blue dot, and you've probably already guessed what that dot is. Yep, that's what our Earth looks like through Voyager's eyes. This photo clearly shows how tiny we really are, and how precious and fragile our planet is. But Voyager 1 also has another, even more important mission, to tell other civilizations about us humans. You might have heard about the famous Voyager Golden Records. People created many audio and video files and added them to these records. There are a few sections. The first one contains hello in 55 languages, including ancient and extinct ones. Almost 80% of the recordings are different musical pieces, like Bach, Beethoven, Mozart, and Stravinsky. Folk music from different countries and ages, and a bit of the blues, like famous songs by Louis Armstrong and Chuck Berry. The remaining 20% of the recordings contain different human voices, sounds of nature and animals, as well as 116 images encoded as audio signals. There's also recordings of speeches by Kurt Waldheim, a former UN Secretary General, and Jimmy Carter, a former US President. These are just some friendly messages. In addition to the records, scientists also packed a needle for playing them. Don't worry, they also left a simple drawing that showed how to use all this stuff and how to translate the sounds into pictures. They added Earth's coordinates, which they created using a pulsar map. It shows the position of the Sun in the Milky Way. The record was packed in an aluminum case and covered with gold to protect it against radiation and cosmic dust. Carrying this record, Voyager 1 set off on its long journey, and it has already traveled quite a distance, I'd say. Right now, Voyager 1 is 154 astronomical units away from us. That's about 14.5 billion miles. This makes it the most remote human-made object. Initially, this title belonged to the Pioneer 10 mission, but Voyager overtook it in 1998. What a bargain for NASA! It's way beyond its best-by date. Voyager 1 is actually so cool that it even overtook its twin brother, Voyager 2, which, by the way, had been sent into space 2 weeks earlier. Voyager 1 moves at a speed of 9.7 miles per second. That's 35,000 miles per hour. Even the fastest sports car in the world travels at a speed of only 305 miles per hour. So it's hard to imagine the speed of Voyager. Anyway, at the moment, Voyager is heading to the borders of the Oort cloud. That's the name of a hypothetical layer of icy objects surrounding the solar system. Astronomers haven't confirmed its existence yet, but they're almost sure it's there. After all, even black holes were only a theory not so long ago. Unfortunately, Voyager 1 won't return back to the solar system. It'll keep in touch with Earth at least until 2025. But eventually, we'll lose the connection with it for good. In 300 years, it'll reach the borders of the Oort cloud. And in 30,000 years, I won't be around then, it'll finally leave the solar system. And if nothing happens to it along the way, in another 10,000 years, Voyager 1 will approach red dwarf star Gliese 445 in the Giraffe constellation. In the future, the probe will probably keep wandering around the Milky Way galaxy. And now, let's finally discuss the mysterious signals part. So, what happened? Well, a rather unusual thing. NASA's Jet Propulsion Laboratory, which monitors and controls both Voyagers, reported this problem in May 2022. Our veteran spacecraft suddenly began sending strange data to Earth. The whole situation puzzles even engineers from NASA. Now, I bet you're thinking, come on, the thing just probably broke down or something. But the truth is that Voyager 1 is totally fine. It works as usual, receives and carries out commands from Earth, and collects and sends scientific data. But the readings of the AACS, which stands for Attitude and Articulation Control Subsystem, don't show what is actually happening to Voyager anymore. This system supports the orientation of the probe in space and helps it keep in touch with Earth. So, basically, the signals mean that the probe's orientation in space is messed up. But scientists claim this is not the case. They know that the source of the antenna signal remains in the same position relative to Earth as planned. The problem hasn't triggered any of the onboard fall protection systems. The probe hasn't even entered safe mode. So, what in the world, or universe, is going on? Suzanne Dodd, the head of the project, says that the problem is not actually that unexpected. After all, Voyager 1 is already 45 years old. The expert admits that what's happening to the probe remains a mystery to them. They don't know exactly where the incorrect data is coming from, and it's unclear how this will affect the operation of Voyager. She adds, though, that it's not that surprising, considering that the probe is in interstellar space. There's a very high level of radiation there. No spacecraft has ever reached that point before. Scientists from NASA say they'll keep closely monitoring the data coming from Voyager 1 until they figure out the problem. If they find it, the management team will try to fix it. Otherwise, the team will have to adapt to the new conditions. It might not be enough just to understand the problem, though. It takes as much as 20 hours and 33 minutes to receive the signal from Voyager, and it takes the same amount of time to respond to it. Well, at least the second spacecraft, Voyager 2, is totally fine, even though it's also currently in interstellar space at a distance of 12 billion miles from Earth. Anyway, we can only wait for news and hope that the problem will be resolved. I actually wonder how much longer can Voyager 1 last? Will it be able to fly to the borders of the Oort cloud in 300 years? What do you think? I'd like to hear your thoughts in the comments. We still can't find the source of the mysterious signal we've been receiving since 2018. We receive it every 22 minutes and nothing can explain this. Some scientists even believe it could be coming from another civilization we haven't met yet. This strange radio signal wasn't found by a scientist on a serious mission. It was actually discovered by a college student just doing a regular project for school. Tyrone O'Doherty, an undergrad student at Curtin University in Australia, was sifting through old data of the southern sky. He was looking for any weird blinking radio signals. He finally stumbled upon one from 2018 that seemed to shoot radio waves towards Earth like a lighthouse beam. Excited about his find, Tyrone shared it with his mentor, radio astronomer Natasha Hurley-Walker. She dove into researching this signal, hoping for a breakthrough. But despite checking different frequency data, they hit a dead end. But then, Natasha spotted a pattern. The signal repeated every 18 minutes. This was huge. But just as they were gearing up to study it further, poof! The signal vanished after only 3 months, leaving them with nothing. Not giving up, Natasha and her team scanned the skies again, desperate for a clue. Months passed, but nothing turned up. They were ready to give up, and then suddenly, a new signal popped up. This one kept blinking for 5 minutes, then it disappeared. And then it came back exactly 22 minutes later. The main question was if that signal was related to an 18-minute one. To figure it out, Natasha went back to the old radio data from that area. As they dug deeper, they realized that, yes, and these signals aren't anything new. They've been beaming towards Earth for 35 years. Back in 1988, Indian and American telescopes had caught them, but they got buried under tons of other data. This was great news for space explorers because it meant they could now calculate how far away this mysterious object was. After doing the math, they figured out it was incredibly far, even on a space scale, 15,000 light-years from Earth. Now, the only thing left to uncover was what exactly this object was. Walker and his team started comparing it to all the known radio-emitting objects out there. Yet its source remains a mystery. The signals still pop up every 22 minutes on NASA screens, always ending with a frustrating match not found message. The scientists called it J183910. Some think that the signal might come from some extraterrestrial beings. Maybe it's the signal that SETI, the search for extraterrestrial intelligence, has been waiting for. This project has been working for over 50 years, trying to find any evidence of life beyond Earth. They also scan the skies for radio waves, laser pulses, and other mysterious signals. So maybe it's a way for extraterrestrial folk to communicate their location. While that idea may sound exciting, we need to be careful about jumping to conclusions. First, we don't have solid proof for that. Before any concrete evidence, it's just speculation. And also, there are other more plausible explanations. Most likely, it comes from a natural phenomenon, and there are a couple of theories for that. The first one is the pulsar theory. Imagine a huge star in space, much bigger than our Sun. Sometimes these big stars finish their life journeys in a spectacular event called a supernova. When this happens, the star's core collapses, becoming super compact, as if you're squeezing all the stuff from that star into a tiny space. That tiny, super-dense core is called a neutron star. Some of these neutron stars are extra special. We call them pulsars. They get their name because they seem to pulse with energy, like a space lighthouse. These pulsars have incredibly strong magnetic fields, much stronger than what you'd find on Earth. They're like enormous magnets in space. Because of this, they shoot out beams of energy. They're also spinning super fast, so these beams of energy seem to pulse on and off as they spin around. Now, the strange signal we detected seems to have similarities with pulsars, but not quite. Pulsars usually have a predictable lifespan and slow down over time, eventually stopping their radio signals. In contrast, our mysterious signal is quite persistent and is blinking beyond what's expected for pulsars. So, maybe it's not a typical pulsar, or not a pulsar at all. There's also a magnetar theory. Now, a magnetar is another type of neutron star. They're like supercharged versions of pulsars, with even stronger magnetic fields and slightly longer pulsating periods. Maybe this is what causes our signal's intense persistence. However, when we plotted the data, we also realized the signal didn't match the magnetar's vibes either. Magnetars not only send out radio waves, but also powerful X-rays because they're so energetic. But the signal we received was only sending out radio waves. So we figured it's not a pulsar and not a magnetar. The signal's behavior is very strange and suggests an unnatural source. This means there might be something in the universe that scientists haven't fully explored yet. And there is a space object that we don't know much about. The final theory is the so-called dwarf pulsar. Sounds a little dopey to me. Couldn't help myself. Now, a dwarf pulsar is like a star that blinks with light flashes, similar to pulsars, but it takes longer for each blink. Usually, white dwarfs are the leftovers from smaller stars. They don't blink because their magnetic field isn't as strong as pulsars. But when a white dwarf becomes pretty hefty, almost the mass of our Sun, it gets super dense and starts pulsating with a strong magnetic field, just like pulsars. They have a cool quirk. White dwarfs are made of electrons, not neutrons like pulsars. When these charged electrons start dancing with a magnetic field, they shoot out periodic light flashes, which happen every 100 to 1,000 seconds. As you remember, our signal has a period of 22 minutes, 1,320 seconds. A bit longer than the usual white dwarf pulsars, but it's much closer to the truth. So far, this sounds like the most plausible explanation. But even this theory isn't fully confirmed yet. This just shows how much there is in the universe that we're still figuring out. For example, fast radio bursts, another mysterious type of signal we've been detecting. They're like quick, intense bursts of energy in the form of radio waves. They have a ton of energy. FRBs are so powerful that sometimes they can be brighter than entire galaxies. Now, imagine this. They release as much energy in a few milliseconds as our sun does in 3 whole days. Wow! These bursts happen all over the sky with huge frequencies, although some have been detected with lower frequencies. Every day, we catch around 10,000 random FRBs in the sky. Some of them repeat, but most happen once and disappear forever. Unfortunately, most of them only last for a fraction of a second, and by the time their energy reaches us, it's 1,000 times weaker than a mobile phone signal from the moon. This is why, despite their brightness, there's still a lot we don't understand about them. We're still trying to figure out what causes these FRBs. They could be coming from different sources, like already mentioned magnetars, colliding stars, or even merging galaxies or white dwarfs. As these bursts travel through space, they pick up information about the cosmic environments they pass through, like interstellar gas clouds. It's very unlikely that FRBs are some messages from extraterrestrial beings, though. Not only because there are thousands of them every day all across the sky, but also because we know that the sources of these bursts must be incredibly energetic themselves. Our neighbors would have to have equipment stronger than entire galaxies for that. But the bottom line is, while all these signals are fascinating, there's still a ton to learn about them.
The space crew had been getting ready for the launch for over 3 years. The preparations for landing on the strange planet included gathering and studying rock samples in the Grand Canyon, exploring ancient volcano formations in the Nevada National Security Site, and looking into gas and lava vents, lava lakes, and pit craters in various locations in Hawaii. To be able to resist microgravity conditions, they learned how to walk obliquely by being strapped and suspended sideways and trying to move along walls. They had to test their limits through intensive diet and sleep regimens to make sure they'd be safe in outer space. It took them 3 days, 3 hours, and 49 minutes to reach the surface of this new world in a place called the Sea of Tranquility. They could have gone for the Ocean of Storms or the Central Bay, but they chose this place to land because it had good visibility and it was relatively smooth and easily reachable with as little propellant as possible. One of the first things they noticed when they got there was that, well, the place kind of smelled. This may sound like the beginning of a science fiction novel, but it's actually the true story about how the Apollo 11 mission landed on the moon on July 20th, 1969. Since then, the moon has had 12 human visitors to this day. We think of it as our neighboring space buddy, but there's still much we don't know about this mysterious satellite. And that should come as no surprise, since the moon is actually always showing us the same face. That is because the Earth and its only permanent natural satellite are in synchronous rotation, which makes us think it's always permanently still. The truth is, it's not in a fixed position, and it is actually moving further and further away from the Earth each year by 1.5 inches. Believe it or not, the Earth and the Moon, although being 238,855 miles apart, deeply influence each other. While the Moon is partially responsible for the tides of the seas and oceans on our planet's surface, our Earth is actually to blame for movement on the Moon. They're called moonquakes, and they last way longer than earthquakes, some of them up to half an hour. It may look perfectly round to us on a warm summer's night, but the Moon is actually oval. The lemon-like shape is caused by the Earth's gravitational pull. Our moon features more than footprints when it comes to traces of humans. In 1969, American astronauts left many objects on the surface of our satellite, such as 2 golf balls, a drawing by famous artist Andy Warhol, and a message from Queen Elizabeth II herself. One of the last people to walk on the moon to this day, an astronaut named Eugene Cernan, scribbled his daughter's initials on the moon's surface in 1972. Since it appears there's no wind or any other type of weather change there, the letters TDC could remain there permanently. It's actually possible to be allergic to the moon. Harrison Jack Schmitt, an astronaut from the Apollo 17 mission, spent some time in a valley in the Sea of Serenity, then climbed back into the crew's lunar module, but had some moon dust on him. Just as he removed his spacesuit, he got red eyes, sneezing fits, and other allergic reactions that lasted 2 hours. Since it's so close to us, we've established that the moon has a time zone of its own. We call it the Lunar Standard Time, but it doesn't correspond to time on Earth. To get an equivalent, the explanation is a bit more complex, but in simple terms, a year on the moon is split up into 12 days, each one about as long as a month on Earth. Each one of these days got its name after a different astronaut who has walked on the moon. The start date of this calendar coincides with the moment Neil Armstrong walked on the moon. So, the Lunar Year 1, Day 1, began on July 21st, 1969 at 2:56:15 Universal Time. Since the moon has a very thin atmosphere, it has some pretty crazy temperatures, both hot and cold. They can go up to 200 degrees Fahrenheit. Over by the moon's poles, however, the temperature is always at around minus 400 degrees Fahrenheit. Humans have tried to trace the connection between our natural satellite and the Earth for as long as we can remember, coming up with words to explain why the moon's existence influences us so. In the Middle Ages, scientists and philosophers thought that during a full moon, some people were more likely to experience different health conditions. Because they saw this inexplicable connection to the full moon, people with these symptoms were named lunatics, or at times, literally, moonsick. People are not the only creatures living on Earth that are affected by moon cycles. Dog owners are 28% more likely to take their pet to vet emergency rooms during the full moon. You may think that's the reason why wolves have this preference for howling at a full moon, more so in popular culture. But scientists haven't been able to find any connection between wolf behavior and the lunar cycles, so it might as well just be a myth. The largest known crater in our solar system is also found on our moon, and is called the South Pole Aitken. This giant formation is located on the far side of the moon and measures 1,550 miles in diameter. One of the many things we've yet to fully understand about our satellite is the unusual flashes of light that can sometimes be seen on its surface. Scientists have named these outbursts transient lunar phenomena, or TLP in short, and they have been seen all over the world for centuries. One of the first instances of TLP dates back to 1178, when monks from Canterbury claimed to have seen a flaming torch on the surface of the moon after the sun had set. TLP does not simply mean light flashes. Reports also have detailed other unusual events, such as gas-like mists, reddish, green, blue, or violet colorations, or even the darkening of certain locations on the moon. Is something strange happening with our moon? Is it the beginning, or did we just start noticing it with the newer space study equipment we have nowadays? There are a lot of different theories that scientists have developed trying to piece together what can be causing these events. The unusual flashes on the moon can be caused by anything from meteoric impacts to electrostatic activity. It's difficult to pinpoint the explanation for each event, since most of these episodes are recalled either by a single observer on Earth or from a single location. The fact that there is noticeable seismic activity on the moon can also explain why we can sometimes see unusual flashes of light on the surface of our satellite. When the moon's surface moves, it can cause different light-reflecting gases to erupt, which can explain luminous developments. Some scientists have even suggested that residual geologic activity may also be the cause. This is all the more shocking, given that we've always looked at the moon as a lifeless world. Did you ever notice that our moon can change its color? There are actually many scientific explanations for that. The moon appears to be a brown-tinted gray when you look upon it from outside of the Earth's atmosphere. When gazed upon from the Earth's surface, the moon appears to change color, depending on various phenomena. The moon seen near the horizon will most likely be yellow or red-tinted. The rarer, blue-colored moon indicates that you're looking at our satellite through an atmosphere carrying larger dust particles. The moon can even appear purple at times, but what causes this specific hue is still up for debate. The fact that we don't know exactly if or how much water there is on the moon's surface is not the main reason why we aren't already building houses up there. It seems that radiation actually has a lot more to do with it. Recent studies have shown that the moon's surface has a radiation rate 5 to 10 times higher than that you experience on a transatlantic passenger flight. That also means it's 200 times higher than the rate on the Earth's surface. In future lunar explorations, like the Artemis project for example, scientists need to take this into consideration, not to expose the astronauts. Named after Artemis, Apollo's sister, this program aims not only to place astronauts on the lunar surface in the future, but also to build some sort of an establishment there to study the moon in safe conditions. While the project started in 2017, the first planned mission is set for launch in summer 2022, with an estimated duration of 25 days. The space object, with no crew on board, is planned to reach lunar orbit and safely return with sufficient data for the next 4-person mission scheduled for May 2024. Artemis 3, 4, and 5 are expected to be launched in 2025, 2026, and 2027 respectively, each with a planned duration of approximately 30 days. Jupiter has 79 known moons, and the 4 biggest of them that are particularly interesting are Galilean moons. They were named after Galileo Galilei. He discovered them in the 17th century. They have something in common, but at the same time are all very different. Europa is the smallest of the Galilean moons with a diameter of 1,860 miles. It orbits Jupiter every 3.5 days. The first images we got from there were taken in the 1970s. Its surface mostly consists of water ice. Europa has long fractures, often around a mile wide, that can extend for thousands of miles across its surface. They were probably formed as the crust pulled apart from tidal forces on the mysterious ocean beneath the surface. In 2012, scientists discovered water vapor plumes erupting close to its south pole, rising up to 125 miles. These plumes can help us find what's inside Europa without having to land there. Scientists think there could be a magnificent ocean hidden 10 to 15 miles beneath the solid surface. That ocean could be 40 to 100 miles deep. Even though it's just 1/4 of Earth's diameter, it contains twice as much water as all of our oceans together. This ocean is a potential environment for some forms of life. Scientists believe the entire ice crust is floating on that ocean. It probably makes a full rotation around Europa once every 12,000 years. In the image the Galileo spacecraft took, you can see small dark brown spots. They're 6 miles across and formed as the hot, less dense material was getting to the surface. It either pushed the crust or broke through it altogether. The surface of Europa consists of so-called chaos terrains. They're rough areas surrounded by a smoother surface. Its equator could be covered in ice spikes called penitentes that can go up to 50 feet high. We have them on Earth too, especially in dry areas at high altitudes. But none of them are as big as those on Europa. Our moon has over 5,000 big craters with a diameter of more than 15 miles. Europa's surface lacks impact craters and doesn't look like it's more than 50 million years old. This means the surface of Europa is changing and reforming all the time. This moon is icy and is one of the smoothest of any solid space objects in our solar system. Because of it, it's 5 times brighter than our moon. Europa is under a constant blast of radiation coming from Jupiter. It's so strong, we wouldn't last even a day there. Europa is 5 times further away from the center of our solar system than Earth. That means it barely gets any heat coming from the sun, so it can remain frozen since the average temperature is -250 degrees Fahrenheit at the equator and around -360 degrees Fahrenheit at the poles. About 40 years ago, the Voyager 1 spacecraft came close to the rocky moon Io and discovered that it's a volcanic champion of our solar system. Io is Jupiter's 5th innermost moon, 4.5 billion years old, nearly the same age as Jupiter itself. It's similar in size to our moon, and even has a similar density and amount of gravity. Many moons in our solar system consist of silicates and water ice, but Io is made of iron and silicate rock. You'd be able to see some beautiful auroras on Io. As this moon rotates around Jupiter, auroras change brightness all the time, but they're always there. Io is relatively close to Jupiter, almost 260,000 miles above its cloud tops. If you could come to Io and take a look at Jupiter from there, it would appear almost 40 times bigger in the sky than our moon. Stargazing there would be amazing. Io needs 42 and a half hours to orbit Jupiter. Our moon needs almost a month. At some points, Io's tidal bulge can go up to 330 feet. It's similar to what we have on Earth. The gravity of our moon causes ocean tides. Io doesn't have an ocean, but the ground itself moves and goes up and down. It's like an elevator taking you to the bottom and then the top of a building with 30 stories. The gravity of Jupiter and its other big moons affect Io, so the solid ground tides on its surface are over 5 times as high as the highest ocean tides on our planet. All this makes Io so hot on the inside that some of the inner materials melt, boil, and try to escape in any way possible. Eventually, it creates a hole in the ground, which then turns into a volcano. Io is the most active body in our solar system when it comes to volcanoes. Io has more than 400 of those, with 150 of them erupting all the time. Some of them shoot their hot gas plumes 200 miles into space. It would be difficult to walk there because we're talking about a pretty intense world of floodplains of liquid rock, huge lava flows, multiple lava lakes, and giant collapsing mountains. Ganymede, the largest moon in the solar system we know of, also has the biggest water ocean. It's 26% greater than Mercury when it comes to volume, but it's less dense. This giant moon has a thick crust of water ice 90 miles deep. There might be a huge ocean of liquid water underneath. It extends 60 miles deep, which is about 10 times deeper than the deepest point in the Earth's ocean. The Voyager spacecraft also detected polar caps made of water frost there. Ganymede is half rock, half water, including tiny amounts of metals and ice. Its atmosphere is very thin and doesn't contain oxygen. This ocean most likely doesn't contain life. The Earth is a great example of how certain microbes and creatures can survive deep down without sunlight. But the ocean of Ganymede is so deep and the pressure is so strong that the water at the bottom is probably compressed back into ice. Certain forms of life in the deepest areas of our ocean survive thanks to geothermal vents that eject minerals. Since there's likely thick ice between the ocean and the core, this isn't the case with Ganymede. But the ocean there is salty, with multiple layers divided by icy sheets. If there's any chance of life, it could be in the part where the rocky core is in contact with the most internal icy layer. Beneath all that water and ice, Ganymede is the only moon in the entire solar system with a magnetic field. It's possible because this moon has a liquid core. Ganymede circles Jupiter approximately once every 7 days. Its orbit is so eccentric that at some points, it's pretty close to Jupiter. Ganymede, Io, and Europa have gravitational forces that affect each other. In the time Ganymede orbits Jupiter once, Europa makes 2 orbits, and Io makes a full circle 4 times. 1/3 of Ganymede's surface contains big dark regions, while the other 2/3 are lighter. Dark areas are older and contain more craters. Lighter areas have long ridges and grooves, about 2,300 feet high and thousands of miles long. Callisto, the third biggest moon in the solar system, 3,000 miles in diameter, needs 17 Earth days to orbit Jupiter. Its atmosphere is very thin. There are many impact craters, but its ancient crust has basically been the same for more than 4 billion years. When a planet is geologically active, like the Earth, some things can erase most of the evidence from past impacts. Water, volcanoes, tectonic plate movements, human activity, and weather. All this changes the surface. Callisto has experienced none of those. Scientists think this moon used to be an ocean world that eventually froze over. It was hit by meteors from time to time, but mainly remained untouched. And yet, it still has some pretty impressive craters, like Valhalla, the biggest multi-ring crater in our solar system. That's 2,500 miles in diameter. Major craters on Callisto contain more rings than those on other celestial bodies. Whatever hit the moon was big enough to have punctured the thin crust, causing water to spread on the surface. And under this thin crust, there could be either salty ocean or soft ice. The Galileo space probe detected that Jupiter's magnetic field couldn't penetrate through this moon, likely because of a layer at least 6 miles thick. That's why it's hard to explore Callisto. Moons like Europa have vents that eject water from the subsurface oceans. But to explore Callisto and discover more about its past, we'd have to use the old-school way, digging through the crust. If we wanted to explore the outer parts of our solar system, Callisto would be a great spot because Jupiter's radiation doesn't reach it. So we'd be safer there than on some other inner moons.
Whoa! A wall of fire spreads around the epicenter of the impact. It burns everything in its path. The waves raised by the explosion cover large cities, and earthquakes are so strong that giant skyscrapers fall like a house of cards. So, these are the possible consequences of the collision with the first interstellar object in history to visit our solar system. We discovered it in 2017, but we're still not sure what it is. An asteroid, a comet, or a spaceship of some outer space civilization. So far, scientists have named it Oumuamua. Sounds like a Hawaiian cow. Well, whatever it is, its speed is much faster than other asteroids, about 54 miles per second. At that speed, you could cross the US from coast to coast in less than 3 minutes. So this asteroid could travel from Earth to the Sun in about 2 months. By comparison, our rockets can travel up to 17,000 miles per hour. The same trip across the United States would take them about 9 minutes. So, many scientists speculate that this is an artificial object created by a very advanced civilization. Okay. The shape of the object supports this theory. It's long and narrow and resembles a spaceship. It's about half a mile long, way bigger than the Eiffel Tower. Scientists decided to see if Oumuamua was really someone's spaceship and pointed some radio telescopes at it. If the civilization on that ship had used communication or scanned us with their tech, we would have known about it. But there was complete silence. Kinda like that. Not a single radio wave. But that doesn't disprove the theory of outer space civilization. To find out for sure, we decided to determine the weight of the object. To do that, we use light. More precisely, its reflection. You see, different materials reflect light differently. We take an unknown black stone, for example. It absorbs almost all the light, reflecting almost nothing. Check out the catalog, it's charcoal. Knowing the size and material of the object, we can determine its weight. So, we need to see how much light this object reflects. And when scientists pointed their telescopes at Oumuamua, they learned that it reflects colors that match with iron and also with some solid rocks. And Oumuamua was flashing all the time, a bright flash. Then it would slowly fade, and then it would start to shine again. This means it was spinning. And it wasn't going around its axis like an arrow. It rotated chaotically, moving its edges up and down. Any artificial object or spacecraft would have been torn apart by such overloads. But Oumuamua is still intact. That means it's made of super hard materials that keep it from falling apart. And it's not hollow like a spaceship. It's one solid body. Hey, like me. The astounding speed of this object makes it pretty mysterious. Some comets can have the same or even higher speed, but they also have a kind of rocket effect. So when a spaceship starts from the launch pad, you see fire bursting out of its engines. Every second, the rocket mixes fuel with oxygen, ignites them, and ejects them at a tremendous speed. According to the laws of physics, this is like pushing off a wall. The rocket sort of jumps up from the combustion gases it throws down. That's how the rocket creates thrust and accelerates. Comets work on a similar principle. The sun's rays hit the surface of the comet. Light elements like ice start to evaporate. That gas goes one way, the comet goes the other. Just like a rocket, the comet is pushing off the evaporating gas and accelerates. This gas also forms the comet's long tail. It's as if the massive rock is dragging all this gas behind it. I can relate. Or it's like a car pulls air with it when it goes at high speed. But Oumuamua is not a comet, and it doesn't have that tail, and it doesn't have the same rocket effect as a comet, so it couldn't have accelerated to that speed. But some scientists believe that Oumuamua used to have a tail. Although we discovered it in 2017, it entered our solar system in 1995, and it was hit by the sun's rays even back then. When we discovered this asteroid, it had already lost about 95% of its mass. It simply evaporated. Other scientists believe that Oumuamua got this velocity during its birth, somewhere far away in another star system or nebula. Perhaps it was a dramatic collision of some exoplanet with another cosmic object. The colossal explosive energy of the collision threw the elongated shard into outer space. Or it could have been a supernova explosion. When a star reaches the end of its lifespan, it becomes a red giant. It's an inflated version of the star, hundreds of times bigger. Then it shrinks and explodes with tremendous force. The blast waves can travel many light years away from the epicenter, and it's one of the brightest events in the universe. So, the supernova might have torn some exoplanet to pieces. One of them, Oumuamua, gained a lot of energy and speed and began its long journey toward Earth. This might explain why Oumuamua keeps spinning so wildly. But recently, scientists published a theory that Oumuamua may be a giant block of ice. The kind of ice we're used to is water, H2O, but Oumuamua could be nitrogen ice, N2. It may have remained intact in interstellar space for 500 million years. And when it arrived in our solar system, nitrogen ice could have reflected 2/3 of the sun's rays, so it didn't heat up as much. That explains why Oumuamua doesn't have a tail. You can find the same nitrogen ice on Pluto, as well as on Triton, one of Neptune's moons. So Oumuamua comes from a similar icy exoplanet. But we can find out for sure only by sending a space probe to it. Scientists came up with a plan for that called Project Lyra. The problem is that Oumuamua is leaving our solar system at tremendous speeds, much faster than our rockets can fly. And we need to catch up with this space rock as quickly as possible before it gets too far away. To do this, we can use a gravity maneuver. First, the space probe makes a flyby of Jupiter. It passes close to it to take advantage of its gravity to accelerate. After that, the probe will head towards the Sun, and it'll fly around it as close as possible to fire like a catapult towards the space rock. The second option for reaching the asteroid is to use microprobes. We have to launch about 1,000 of them into orbit. They should be no heavier than a match. Each of them will have a light sail the size of a boxing ring. Then we'll focus a powerful laser beam from the ground onto this sail. It will allow us to accelerate the probe to about 20% of the speed of light. It shouldn't go too fast not to fly past the asteroid. It should be able to enter its orbit or land on it. But if we're too slow, Oumuamua will leave our solar system before we can catch up with it. It'll be a great experience because in the future, we'll be able to use such asteroids as a space taxi. All we have to do is enter the orbit of such an interstellar asteroid or even land on it. Then we would keep moving through space at incredible speeds without using any fuel at all. This would be a great option for traveling long distances or to deliver supplies to other star systems. So why should we be afraid of such objects? Well, a collision with an asteroid the size of Oumuamua could wipe out an entire state. If it were to hit somewhere in the ocean, it could cause waves taller than our skyscrapers. Scientists are anxious to find ways to protect us against such objects. One of them is ramming. If we spot a potentially hazardous object, we could send a spaceship towards it, pedal to the metal. The spacecraft will have to ram the asteroid at an angle that will move its trajectory just a little bit. Moving it too much on a cosmic scale would only dramatically change the asteroid's final destination, and we only need to get the asteroid past our planet. We can also create a controlled explosion on the asteroid. It's based on the same principle. The force of the explosion would have to shift the trajectory of the asteroid slightly, or smash a giant rock into smaller pieces. Asteroids up to 80 feet wide would burn up completely in our atmosphere due to friction against the air.
Rocks between 80 feet and half a mile in size may not burn up completely and cause local damage. Anything larger is considered very hazardous. You think? The traditional method of science fiction is to put rocket engines on the asteroid. Then we can not only change the trajectory of the space rock, but also control it. And we can use it against other asteroids. It would be something like space billiards. In 2017, a strange object was spotted in our solar system. It had the shape of a long tube, similar to a pancake. No known asteroid or comet we've seen looks like that. Its exterior was also peculiar. It was at least 10 times more reflective than the average stuff that flies through space, with some saying it had a surface similar to polished metal. When it went past the sun and left our reach, it accelerated faster than what our gravity could account for. At first glance, it was like this thing had a rocket strapped to its back. This unusual visitor even got a special name, Oumuamua. It comes from Hawaiian and translates to scout or visitor from a faraway land. And because of its characteristics, scientists soon began to wonder if this was at last a visit from otherworldly creatures. Before they went full-on with the science fiction suppositions, astronomers gathered the information they were sure about, starting with the fact that Oumuamua must have come from another solar system. There must have been some unfortunate event in its home system that led to its ejection. What they didn't know was that this was a comet or asteroid. They're both celestial objects orbiting a sun, but they have distinct compositions and behaviors. Comets are composed primarily of ice, dust, and rocky material, often referred to as dirty snowballs. When a comet approaches the sun, the heat causes the ice to vaporize, releasing gas and dust particles into space. This creates a bright glowing tail that can extend for millions of miles. Comets generally have elliptical orbits, often taking them from the distant reaches of our solar system closer to the sun. Asteroids, however, are mostly made of rock and metal. In our neighborhood, they are remnants of the early formation of the solar system and are typically found in the asteroid belt between Mars and Jupiter. Unlike comets, asteroids do not develop tails when they approach the Sun, as they have no ice. Their orbits generally follow more circular paths compared to comets. By all accounts, Oumuamua should be a comet, because it seems to come from a different location in the universe. Yet, it doesn't exhibit the typical signs of cometary activity. Oumuamua lacks a tail and does not spew out gas as it passes by, not like me. Even though it behaves like a comet, it looks more like an asteroid. Now, another big question is how scientists even managed to spot Oumuamua in the first place. Considering the vastness of space and time in the galaxy, it's remarkable. Stars have lifetimes spanning millions or billions of years, and the formation of a solar system takes hundreds of millions of years. Even the fastest objects take tens of thousands of years to travel from one star to another. In contrast, humans have only been observing the skies with telescopes for around 400 years, a tiny fraction of cosmic time. And it's only in recent decades, even years, that we've had the technology to detect and track fast-moving, dim objects. Either rocks like these are abundant, or we've been incredibly lucky with our detections, or it's simply wanted to be seen. Now, another question that was asked was where such objects could come from. It's highly unlikely that Oumuamua came from a mature, stable solar system. That's because such systems don't eject enough material to fill up the galaxy. Occasionally, a random rock might get flung out, but it can rarely travel so far. Young systems, however, act differently. In these chaotic environments, collisions, mergers, and migrations are happening everywhere. Plenty of tiny rocks roam around, perfect candidates for ejection. The solar system that kicked Oumuamua out must have had a planet similar to Jupiter. Its massive size and gravity could influence other objects in the system, causing potential ejections. But not all solar systems develop Jupiter-sized planets. Often massive planets end up close to their stars, becoming hotter versions of Jupiter. These planets, snugly orbiting a sun, are less likely to eject debris. Now, Neptune-like planets may play a role too.
While not as massive as Jupiter, they tend to call the outer regions of solar systems their home. Our solar system has the Kuiper Belt, a reservoir of comets in its outer reaches. During a solar system's early stages, interactions between Neptune-like planets and debris are common. Finding Neptune-like planets in other systems has been challenging, though. Our methods for detecting exoplanets work better for massive objects close to their stars, making it difficult to spot Neptune counterparts farther out. Oumuamua was also linked to a peculiar theory about how life came to be in the universe – panspermia. Now that's a hypothesis that suggests that life exists throughout the universe and can be distributed between planets by various means, such as asteroids, comets, or even spacecraft. It says that life must have originated in one location in the universe and then spread to other celestial bodies. Fans of the panspermia theory have suggested that such interstellar objects could potentially carry tiny microbes, those building blocks of life between star systems. If such objects were to impact a planet or a moon, they could transfer these materials and seed the celestial body with life. For now, there is no evidence to support the theory that this comet in particular has transported life between star systems. After years of research, the overall consensus became that Oumuamua was indeed a comet. The reason why it moves so strangely is because it might have frozen hydrogen on its surface that reacts when touched by sunlight. The closer it got to our Sun, the faster it became, releasing that hydrogen and also changing its path through our solar system. Its color also supports this theory. It's red, which might mean it's been hit by cosmic rays for a long time. The longer it was touched by those rays, the more hydrogen it gathered in the process. But since they can't be completely sure, astronomers have a plan to follow this visitor. One idea is to send a mission to check it out. It's already far away from us, but it may not be too late just yet. We may be able to send a probe fast enough to catch up with the comet. The plan was named Project Lyra and aims to use the Earth's orbit and that of Jupiter to bounce out a probe far enough to reach Oumuamua. If it works, it will be the fastest space device we've sent out in the universe. One potential trajectory of the space probe involves the gravitational pull of our planet and that of Jupiter as a lasso effect, but not Ted Lasso. The probe will leave our planet and re-enter Earth's orbit before sending it to meet with Jupiter's pull. It will be sent back near our planet a second time, where it will be ejected with enough force to reach the comet. Project Lyra also aims to follow a second faraway visitor named Borisov. This one was discovered by an amateur astronomer and now bears his name. What's interesting about it is that it's, well, spotless. Similar to our experience with Oumuamua, we haven't seen anything like Borisov before either. Studies of the light coming from its cloud of dust and gas show it's very clean compared to other space objects. After it was first noticed in August 2019, astronomers studied its path through our solar system and concluded it came from another star too. But Borisov gave us more time to study it because we spotted it earlier in its journey through our neighborhood. Researchers used advanced telescopes to look at the dust coming off Borisov. They found it's throwing off over 400 pounds of dust every second. They also found Borisov has more carbon monoxide than comets from our solar system usually do. But the amount isn't the same everywhere on the comet. This tells us the space object probably started forming near its home star before moving away, maybe because of larger planets in its system. The light from Borisov is way more polarized than light from other comets we've seen, and its cloud is super smooth. This tells us Borisov has never interacted with another star. If an asteroid like Apophis hits Earth, we will be destroyed. Massive earthquakes will strike, and tsunamis will flood everything. Apophis is a billion-year-old celestial body that has been in the solar system since its inception. So you might be thinking, well, how likely is it that this giant space stone will collide with our planet in 2029? Well, let's find out, shall we?
Apophis is a big, bad asteroid discovered in 2004 by the Kitt Peak National Observatory in Arizona. Since then, it has proudly held the title of one of the most dangerous asteroids ever located. It's around 1,100 feet wide, which is a bit bigger than the Empire State Building and the Eiffel Tower. Because of how scary it was named Apophis, like the Egyptian immortal creature that was considered to bring eternal darkness and destruction to Earth. Oh boy. In 2021, researchers had a once-in-a-lifetime opportunity to study this floating rock when it passed near our planet, and we'll come back to that in a minute. Now, some scientists say that there is a small chance of Apophis hitting the Earth on Friday, April 13, 2029. The Yarkovsky effect is to blame for this, since it can slightly nudge this space rock towards Earth. This effect originates from the uneven emission of thermal photons from a rotating celestial object, resulting in a fascinating force exerted upon it in space. These emitted photons possess momentum and play a pivotal role in shaping the dynamics of the body. The asteroid has two sides, light and dark, just like the Moon. The light side faces the Sun and is warmer than the dark side. But the thing also turns, so the sides constantly change direction and temperature. This change could be detrimental because it slightly pushes Apophis toward Earth. Unfortunately, nobody knows how the Yarkovsky effect will influence the asteroid's path. On the other hand, on the asteroid's last flyby of Earth in 2021, astronomers used radar to take accurate measurements of its trajectory and confidently concluded Apophis will safely miss Earth in 2029 by about 20,000 miles and won't bother us again for at least 100 years. Now, generally speaking, every 8,000 years, our planet is hit by a falling star that has similar dimensions to those of Apophis. The last time we were hit by a slightly smaller meteor was in 2013. A new spacecraft developed by NASA called the OSIRIS-REx was launched in 2016 to collect samples from another slightly less terrifying celestial body called Bennu. 4 years later, it finally arrived at the thing, got some samples, quickly said goodbye to Bennu, and started traveling back towards Earth. The samples were safely stored in a capsule dropped in Utah. So far, this has been the most significant sample ever taken from an asteroid. After the delivery, the spacecraft didn't waste any time and started chasing Apophis. Now, OSIRIS-REx has been renamed to OSIRIS-APEX and is currently playing tag with Apophis. With some luck, on the 2nd of April 2029, when the asteroid zips close by Earth, the spacecraft will reach Apophis and land on it. It will stay on Apophis for 18 months, collecting valuable information and taking thousands of pictures. The asteroid will be monitored with the help of powerful telescopes. At some point, Apophis will get too close to the Sun, and then all the monitoring work will be on Osiris's apex back. If you live in Europe, West Asia, or Africa, you're one of those lucky people who will have a once-in-a-lifetime opportunity to see Apophis with the unaided eye. It'll be visible in the sky in these regions in 2029, and those who have telescopes will be able to spot it once again in 2036. OSIRIS-APEX will experience some problems because the asteroid has a thick crust, and the spacecraft won't be able to collect data as easily as it did with Bennu. OSIRIS-APEX has a unique thruster that will blow all the dust from Apophis while landing. This will be a perfect chance to analyze the surface of the asteroid to see what it's made of. The craft will spend 1.5 years mapping the asteroid, trying to detect changes in its shape. All this research will show how the celestial body is likely to move so we can better design plans to protect Earth from such things. In 2025, NASA is also going to launch the mission Apophis Pathfinder, and it will be the first spaceship to ever touch this asteroid. It will land approximately a year after its launch. Also, NASA has proposed sending a swarm of tiny craft into space to help humanity develop effective protective tactics against asteroid strikes. We know that Apophis originated in the primary asteroid belt between Mars and Jupiter. In the past million years, this celestial body has changed its path because of the considerable influence of Jupiter's gravitation. Now it seems like it favors the Sun more, meaning this asteroid will come very close to Earth. That's why it's classified as a near-Earth celestial body. A lot of tests and research have been done to find a way to deal with asteroids. Some solutions include drilling and detonating the space body from inside, or testing new technologies, like attaching rockets to it and trying to steer it away from Earth. We can also hit it with something moving at high speeds to make it change its course. Apophis is an S-type asteroid made of rocks and minerals like iron and nickel, and is shaped like a peanut. It can tell us a lot about the past and possibly the future. Sampling this space object could reveal how life on Earth began and how plants appeared. There are many theories that suggest that water arrived on our planet on an asteroid or a comet. Asteroids are like priceless time capsules. Unlike rocks on Earth, which have undergone thousands of changes, like erosion, most celestial bodies are still intact and much easier to study. When meteors fall on Earth, they get covered in debris that's impossible to clean. That's why studying Apophis while it's still in space is so important. Also, some asteroids are made of precious metals like platinum. Right now, we have a high demand for metals that we use in production, and mining metals on Earth is quite tricky. Just one large meteor might have iron, nickel, gold, and platinum that could last us millions of years. If Apophis has this amount of metals, well, we'd want to break it down and bring it back to Earth. One space rock could be worth quadrillions of dollars, making space mining highly profitable. And still, it would cost us more to get it back to Earth than to dig up these materials here. As technology progresses and new kinds of rockets are developed, this might become possible at some point. So, even though we're safe for the next 100 years from Apophis, you probably still want to see what would happen if something like it did impact. Come on, sure you do. Well, first let me tell you, you'll hear the sound of the collision and know what's happened even if you're miles away. You should leave your house or apartment immediately. Shortly after the impact, massive earthquakes will strike, and many tall buildings will fall. So, staying away from cities might be your best option if you have a choice. But don't escape by car. There will be massive traffic jams, and everyone will panic. Going on foot or by bike is your best option in this scenario. A prime way of transportation will be traveling by plane, so if you've always wanted to get that pilot license, now you've got a good excuse. If you have time, take along extra snacks and water, and an extra pair of socks. It's nice to live by the ocean or the sea, but in this scenario, it's the worst place to be, because giant tsunami waves will hit coastlines after the impact. If you live far away from the impact area, the tsunami might take 30 hours to arrive. You'll have a bit of time to prepare.
So, you're standing on a diving board in the middle of an open space. You look down, but that's not a pool. It's a giant black hole. Well, what the heck? You start swinging and then you jump. The gravity of the black hole grabs you, and you pick up speed. Just a little more, and you'll enter the dark abyss. But you're not afraid. You're sure you can survive the fall into the black hole. Besides, you have a clear goal to travel through time. But first, let's figure out how it works and why time stops near a black hole. This is the space-time grid. It's what our entire universe is made of. And just like a regular grid, it sags if you put something heavy on it, like me. For example, let's put the planet Earth here. You see a little funnel that is formed around the Earth. And if you put a small ball next to the planet, it'll roll into the funnel. That's how gravity works. The heavier the object, the more it bends space-time. By comparison, here's the Sun. It's almost 333,000 times heavier than the Earth, so it makes a really big funnel. So big that all the planets in our solar system move around that star inside that funnel. So now, let's put a black hole on a space-time grid. Its centers are infinitely heavy, so they create a limitless deep well. And anything caught in the black hole's gravitational field can never leave it, not even moving at the speed of light. Okay, their gravity is infinitely strong, But why do they slow down time? It's all about the speed of light. According to physics law, the speed of light must be the same at every point in our universe, even in a black hole. So, for our experiment, we take this ball, a photon of light that can travel 671 million miles per hour. You could get from Earth to the Sun at that speed in 8 minutes. That's how long it takes light to travel from our star to our eyes. So, when you're looking at the Sun, you're looking back in time 8 minutes ago. By the way, don't look at it directly. Now, the critical thing to remember here is that velocity consists of two physical quantities: space, miles, and time, hours. We'll use that later. Now, let's look at the black hole in our space-time grid. In three-dimensional space, it appears like this. But if we assume that space is two-dimensional, our grid looks like this when viewed from above, just a lot of squares. And this is the black hole right in the middle. If you look at the grid from the side, you'll see a straight line. And the black hole here looks like a pit, or like an endless well. Now, let's follow our photon of light in three-dimensional space. Here, it's moving toward the black hole, and then it falls into the well of the black hole, and it continues its motion at a constant speed. Now, the side view. Again, the photon moves from left to right and then falls. Its velocity doesn't change. The problems begin if you look at the experiment from above. When the photon of light moves in the distance of the black hole, its speed is stable. But then it goes down into the well. First, it slows down and then it just stands still. But it's moving downwards. The photon moves in an arc down the well in the lower dimension without changing its speed. But in the higher dimension, it traveled a minimal distance at the same speed. Usually, this would mean that the photon was moving at a low speed in the second case, but not in the case of the speed of light. Remember, it must be the same at every point in the universe. The number 671 million miles per hour shouldn't change. So, we change the very parameters of that number, time. Time itself must slow down so much that this slight movement of the photon, when you look at it from above, was at the same speed, 671 million miles per hour. But if you go down and look at this well much lower, you see that its walls are almost vertical. So, a photon of light would be moving in a vertical trajectory. That means that if you look at it from above, the photon will just be standing still. Again, its velocity can't change, so time will vary. At that point, it should just stop. This is what happens near a black hole. Now, if you look at a black hole, you can see this effect in action. It swallows up the light around it. But as for an observer, it seems to you that the light stays in orbit around the black disk. In fact, at that moment, the photons are still moving at the speed of light inside the black hole. It's because time has slowed down there so much that you feel like the light has stopped there. This disk is called the event horizon, the point of no return, the last stop before you go into the black abyss. And at the very center of the black hole is the singularity. This point of space is so dense that if you tried to describe it with any numbers or physical quantities, they would all tend toward infinity. Simply put, all the laws of physics we know just stop working here. So scientists can't say exactly what awaits you in the singularity. Before you make that jump into the black hole, let's drop a space probe there with a blue light that flashes once per second, and let's attach giant clocks to it. You see the probe falling into the black hole, gaining speed, but then it starts to slow down. Moreover, the probe flattens out and seems to spread out around the black hole. And then you notice that the blue beacon on the probe has changed its light. It now flashes as red. It's because the light is a wave. Blue is a truly short wave with a high frequency, but the black hole's gravity acts on this wave, stretching it out. The light waves get lengthened and become broader and less frequent. The new wavelength and frequency match with the red color. It's called redshift. Also, the probe blinks now not once a second in short beeps, but lights up and goes out for a long time. It's because of the time warp. If you, as an observer, look at the clock on the probe, the second hand there barely moves. However, the clock on your hand works as usual. But if you could be in a black hole, time would seem normal to you, and the arrow on the clock would move as it did before. But the hands on the clock outside the black hole would move like crazy to you. That's because time goes much faster outside the black hole. Oops! Your probe just got ripped apart. That's because of the substantial difference in gravity that acts on the probe. The black hole's gravitational force increases with every foot of approach. That is, if you were to extend your hand toward the black hole hard, the gravity on your fingers would be much stronger than on your shoulder. This force would cause your fingers to lengthen, simply like spaghetti. That's why many people think it's impossible to survive falling into a black hole. But scientists think you could survive without a problem. Hey, maybe they should jump first just to make sure. The thing is, you have to pick a black hole as big as possible, like the ones at the centers of galaxies, for example. That bright spot at the center of the Milky Way also has a black hole. It's about 1 million times heavier than the Sun. And this is the Messier 87 galaxy, one of the most massive galaxies among our neighbors. In 2019, humanity got its first ever photo of the black hole at the center of this galaxy. It's about 6.5 billion times heavier than our Sun. So, it's the perfect place to make your jump into a black hole finally. Let's go. At first, you feel a strong acceleration as the incredible force of gravity grabs you. But in the case of a supermassive black hole like this, the gravity doesn't change as dramatically. That's because of its size. Right now, the gravitational force on your legs is about equal to the gravitational force on your head, so you don't turn into spaghetti, and you feel comfortable. You see that the light from the stars and all the space around you has begun to shrink at a certain point. It means that you have already passed the event horizon and are now moving toward the black hole's heart. As a result, the light of the universe becomes a small dot for you and then disappears altogether. If we look at our space-time grid, you're already falling into a well. Time is completely stopped for you. However, the rest of the world continues to move steadily through time. If you could now look at the Earth from a black hole, you would see a time lapse, an accelerated video of how the months and years go by on our planet. If you had a jetpack that had an incredible engine to pull you out of the black hole, then you can make a jump forward in time. In 1 second, centuries on Earth could pass in the heart of a supermassive black hole. But this only works one way. You can't go back in time. But for now, you keep falling into the black hole. Beyond that, no one knows what'll happen to you. We only have theories about wormholes and white holes that might transfer you somewhere else in the universe. So, enjoy your trip, and just think about all the frequent flyer miles you're racking up.
The James Webb Telescope, or JWST, is like the ultimate intergalactic paparazzi. It takes pictures of some of the most famous celebrities in the universe. Stars, galaxies, exoplanets, you name it. The James Webb Space Telescope will snap a photo. So if you're a fan of cosmic celebrities, let's take a look at some of these best star-studded photos. The Carina Nebula. The image of the nebula with the beautiful name Carina was published on July 12th. JWST captured a beautiful view of the nebula, located about 7,500 light-years from Earth. Nicknamed the Cosmic Cliffs, it is, in fact, a hotbed of young stars, some of which are several times larger than our Sun. The Carina Nebula is a celestial spectacle located in the southern constellation Carina. It's really huge, approximately 260 light-years across. Massive stars within this nebula are so bright and hot that they create a glowing cloud of gas and dust around them. The Carina Nebula also contains swirling clouds of gas and dust where new stars are being born. The gas collapses under its own weight, becomes hotter and denser, and all this eventually leads to the creation of new stars. However, the Carina Nebula isn't just some peaceful place of star formation. It's the site of some of the most destructive events in the universe, which create massive shockwaves that obliterate everything in their path. Very chaotic and cool. The Stefan's Quintet. This photo was also posted on July 12th. Stefan's Quintet is a visual group of 5 galaxies located at a huge distance from us. about 290 million light-years in the constellation of Pegasus. It's like a cosmic family reunion. All these galaxies are related to each other and interact with each other in some interesting ways. They're pulling and tugging on each other with their gravity, constantly exchanging gas and dust. This interaction is causing some of the galaxies to collide and merge, which can create all sorts of cool effects, like bursts of star formation and supernovae. Thanks to JWST, we were able to see shockwaves, tidal tails, and other amazing details about these galaxies. Their interactions create a stunning sight that we can see in this photo. Jupiter. And here's our old giant friend. This image was published by NASA on August 22nd. Jupiter is the largest planet in our solar system, and it's known for its many moons and its beautiful swirling clouds. But it also has a system of rings, just like Saturn, which are made up of tiny particles of dust that orbit the planet. These rings are much smaller and less visible than Saturn's, but they're still pretty neat. Jupiter also has auroras, which are colorful light displays that occur in the planet's atmosphere. They're caused by charged particles from the solar wind interacting with Jupiter's magnetic field. Just like on Earth, they can be seen near the poles of the planet. But these auroras are much brighter and more intense than ours. We can even see this crazy light show from space. And now, we were finally able to capture this dazzling sight. JWST's photo shows the auroras of Jupiter, its rings, and even two moons, Amalthea and Adrastea. It's amazing how bright and clear they are on this photo. The Cartwheel Galaxy. NASA released this image on August 2nd. This photo shows us the Cartwheel Galaxy and its companions. The Cartwheel Galaxy gets its name from its shape. It kind of looks like a cartwheel, doesn't it? This is a giant swirling mass of stars, gas, and dust, which is located in the depths of space. It's shaped like a pinwheel with long spiral arms. These arms are held together by the gravity of the central region, which is home to a supermassive black hole. But the Cartwheel Galaxy is a bit different from its spiral relatives. It has formed when a smaller galaxy collided with a larger one, creating a shockwave that rippled through the gas and dust. We'll definitely have to visit this galaxy someday. It's sure to be a wild ride. Spiral Galaxy M74. And here comes another spiral galaxy. NASA released this image on July 22nd. JWST had to peer through thick layers of dust and gas to see this beautiful star cluster. M74 belongs to a special class of spiral galaxies known as the Grand Design Galaxy. This means that its spiral arms are noticeable and clearly outlined. All sorts of amazing things are happening inside of spiral galaxies. Supernovas, stars being born in clouds of gas and dust, and many other cosmic wonders. The glowing gas and dust, the bright stars, and the swirling patterns of the spiral arms make them some of the most striking objects in the universe. Well, we can clearly see it on the example of M74. The Tarantula Nebula. This image of the nebula with a creepy name Tarantula was published on September 6th. The photo covers as much as 340 light-years across. This is a huge distance. Thanks to this image, astronomers have discovered new young stars that were previously shrouded in dust. The Tarantula Nebula is located 160,000 light-years away from us, in the Large Magellanic Cloud. It's the largest and brightest star-forming region in the local group, the galaxies nearest our Milky Way. It's named after its shape, which looks like a bit like the legs of a big tarantula. It's a vast region of space, about 1,000 light-years across, and it's home to some of the most massive and luminous stars in the universe. One of the reasons why the Tarantula Nebula is interesting to scientists is its composition. Its composition is close to the region of stars of the cosmic noon, the so-called state of our universe when it was only a few billion years old. At that time, star formation was at its peak. Thanks to the Webb telescope, we can study this galaxy better and find out what our universe was like at its peak. Neptune's rings. This photo was published on September 21st, 2022. In this photo, we can even see 6 small moons next to the planet, with Triton shining brightly in the upper left corner. You didn't think it was the sun, did you? And yep, Neptune has rings too. They're like the ultimate cosmic accessory. They add a touch of glamour and style to the planet. But unlike some earthly bling, these rings are made of small particles of dust, rather than diamonds and gold. There are 5 known rings around Neptune: the Gall, Leverrier, Lassell, Arago, and Adam's rings. Scientists think that these are relatively young, much younger than our solar system, and much younger than, for example, Uranus's rings. They were probably created when one of Neptune's inner moons got too close to the planet and was torn apart by gravity. We haven't seen Neptune's rings so brightly since Voyager 2 flew past it back in 1989. So this is a great opportunity to take a closer look at these rings. The Pillars of Creation. This photo was published on October 19th. The Pillars of Creation became famous thanks to the Hubble telescope, but this photo is very lush and much more detailed. These columns, located in the Eagle Nebula, are about 5 light-years tall, which is really, really long. And they look like some majestic rock formations, only much more transparent. Just like a typical Hollywood movie set, they're full of action and special effects. They're home to some of the most dramatic processes in the universe. The gas and dust are collapsing under their own gravity, forming clumps that will eventually become stars. The place is full of intense radiation, jets of high-energy particles, and supernovae. It's like a cosmic version of Survivor. And if this wasn't creepy enough, here's another photo published by NASA on October 19th. They shared it right before Halloween. Here, the pillars resemble an eerie hand reaching for something. Brrr. Anyway, all these photos give us a truly awe-inspiring sight. They remind us of the incredible complexity of the universe and the amazing things that are happening even in the darkest and most remote corners of the cosmos. Let's hope that the James Webb Telescope will continue to amaze us in the future.
So, we might be getting closer to finding a massive icy planet beyond Neptune's orbit. Yeah, sorry Pluto, still not you. Recently, some universe mapping using data from a telescope in Hawaii eliminated about 78% of the possible locations for this mysterious Waldo from space. Some people call it Planet 9, while others prefer Planet X. Either way, it's been causing controversy since its existence was first proposed, and that is mainly because no study so far can answer the big question: does it really exist? If discovered, Planet 9 would rank as the 5th largest planet in our solar system, with a mass 10 times that of Earth. It's also theorized to be gaseous, like Uranus. The initial study on Planet 9, dating back to 2016, suggests that this colossal new planet orbits the Sun 29 times farther out than Neptune, which sits at about 2.8 billion miles. As a result, the Planet 9 would take between 10,000 and 20,000 years to complete a single orbit around the Sun. If confirmed, this yet-to-be-understood world would dominate a region larger than any other known planet in our cosmic neighborhood. These are all intriguing hypotheses, but without a single piece of evidence or observation to back them up. Before dismissing this as a wild guess, it is important to note that these researchers relied on complex mathematical modeling and computer simulations to speculate about the planet's characteristics, because that's what they do. The hypothetical presence of this planet would explain various mysterious features located beyond Neptune. We are specifically talking about the Kuiper Belt, a huge donut-shaped region filled with icy debris left over from the formation of the solar system, including comets and dwarf planets like Pluto. What happens is that the 6 farthest objects in the Kuiper Belt exhibit elliptical orbits that are all oriented in a similar direction within physical space and tilted approximately 30 degrees downward relative to the orbital plane of our 8 known planets. What's strange here is that despite their distinct orbital velocities around the solar system, they maintain this alignment. The likelihood of such alignment occurring randomly is extremely low, around 0.007%. So here comes Planet 9, a hypothetical massive celestial body that offers a plausible explanation for this strange phenomenon, potentially exerting gravitational influence to shape these orbits. The initial theory didn't hold up for long, facing accusations of observational bias and calculation errors. Then, in 2017, another study popped up, sparking back the idea that maybe Planet 9 is out there after all. This time, Spanish astronomers tried a novel approach, focusing on observing extreme trans-Neptunian objects. These celestial bodies orbit the Sun in highly stretched elliptical paths, with average distances exceeding 13 billion miles. The research suggests that the distances between these objects' nodes and the Sun might provide clues to Planet 9's location. You see, these nodes are the points where a celestial body's orbit intersects the solar system's plane. When these objects reach these points, they're more likely to interact with other solar system bodies, potentially causing significant changes in their orbits or even collisions. So, if the trajectory of these extreme trans-Neptunian objects remains stable, everything's fine. But if it's not, well, that's a sign that something else, something big, is messing with their path. And that's exactly what the research found. There is something unseen out there, throwing these objects off course. And that something could be a planet chilling at a distance between 300 to 400 times farther from the Sun than Earth. To this day, the study of the extreme trans-Neptunian objects is the strongest evidence we've got for Planet 9's existence. And if you're still not convinced by this theory, know that strange motions like these have led to planetary discoveries before. Neptune, for instance, was spotted because Uranus's motion didn't quite agree with the predictions of Newtonian gravity. But the deflection of its orbit could be explained if it was caused by a pull of an undiscovered planet. And just like that, we discovered Neptune. Now, the year is 2021, and there's all this buzz about Planet 9 again. After correcting some old guesses, studies are now leaning towards the idea that this mystery world follows an epic loop around the Sun every 7,000 years. That is massive news, because it means this planet might be closer than we ever thought, making it easier for our telescopes to spot it. The paper also suggests there is a whopping 99% chance that the funky orbits of these distant objects are all because of this unseen planet, not just some cosmic coincidence. Now, the odds of this whole situation being a fluke are down to a 1 in 250 chance, which is much better than the 1 in 10,000 chance back in 2016. All these optimistic numbers have brought us to where we are today, keeping our hopes and working on better equipment to continue the mission of spotting Planet 9. As mentioned earlier, researchers in Hawaii created some kind of treasure map utilizing the Panoramic Survey Telescope and Rapid Response System to eliminate 78% of its locations. This is great news, considering how challenging it is to find a planet-sized needle in a cosmic haystack. But unfortunately, Planet 9's presence remains a ghost in the dark outer reaches of our solar system. Enthusiasts are still convinced of its existence and believe it is only a matter of time before we celebrate the discovery of Earth's new cosmic cousin. They're putting their hopes on the Vera C. Rubin Observatory, which is currently under construction in Chile and is scheduled to begin science operations in late 2025. Over the course of 10 years, this observatory will scan the entire southern hemisphere sky every few nights with a 27-foot, fast-moving telescope equipped with the largest digital camera in the world. The idea is to catalog everything in the solar system, reaching out to and beyond Neptune, and tracking the movements of millions of celestial objects, including space junk, asteroids, comets, and stars. If Planet 9 is indeed out there, This next-generation telescope could be the one to find it. The existence of this mysterious planet is far from being universally accepted in the scientific community. That is simply because Planet 9 isn't the only explanation for the strange phenomenon occurring beyond Neptune. One theory suggests that a group of distant objects, such as dwarf planets, comets, and moons, might be collectively influencing the orbits of the extreme trans-Neptunian objects. Others believe that a black hole is behind all this. These compressed masses are some of the densest objects in the universe, potentially capable of affecting the orbits of other masses, like how this supposed ghost Planet 9 is believed to be doing. Another bold perspective suggests that our current understanding of the laws of gravity is flawed, actually incomplete. This theory, known as modified Newtonian dynamics, proposes that these distant icy objects exhibit strange behavior not due to influence from another planet, but rather because the immense gravitational field of the Milky Way is influencing them. However, even supporters of this theory acknowledge that it is too early to draw firm conclusions, and much more extensive research is still required. While we continue our relentless hunt for Planet 9, some astronomers have taken it a step further, suggesting the existence of a hypothetical Planet 10. This world has a mass and size like that of Mars or Earth and is located on the edges of the Kuiper Belt. But the thing is, if this alleged Planet 10 is indeed as small as scientists believe, it might not have enough gravity to clear its orbit of debris. And that is pretty similar to what happens with Pluto, being one of the reasons why it got into trouble back in 2006. So yeah, it's better not to get too excited. This supposed Planet 10 might end up classified as another dwarf planet. The Hubble Space Telescope was put into a low Earth orbit in 1990. If you think about it, it's had over 30 years of experience looking at various space objects. It was named after astronomer Edwin Hubble and was built by NASA. It is also part of a group of devices called NASA's Great Observatories, along with the Compton Gamma Ray Observatory, the Chandra X-ray Observatory, and the Spitzer Space Telescope. The Hubble Space Telescope was built to explore the universe and answer some of its biggest questions, such as how galaxies form and evolve, and how the universe itself has changed over time. The telescope has made many important discoveries, including providing evidence of the existence of dark matter and helping to determine the rate of expansion of the universe. One of the most famous images taken by the Hubble Space Telescope is the Pillars of Creation. It's a photo of a region of the Eagle Nebula, where new stars are born. The photo, which was taken in 1995, shows massive pillars of gas and dust towering above the nebula. It has become one of the most iconic images of the universe. The Hubble Space Telescope continues to operate and make important scientific discoveries, despite some initial technical difficulties. In 1993, a problem with the telescope's main mirror was discovered, which affected its ability to focus light properly. A repair mission was sent to the telescope in 1994 to fix the problem, and since then, the telescope has continued to work perfectly. One of the more interesting discoveries made by this amazing telescope is actually pretty recent. A report based on the data from the Hubble Space Telescope shows that there is a faint glow in space around the solar system that cannot be explained by anything we know to exist. Because they have yet to figure out the source, astronomers call this mysterious glow ghost light. We don't know that this light is not coming from the stars or galaxies near the solar system, nor is it coming from dust on the solar system's plane. The researchers aren't sure what the source of the light is, but they think it might be tiny particles of dust and ice left by comets. But it's only a theory that has not yet been confirmed. When we study the universe, we often find bright things like planets, stars, and galaxies. But from time to time, we discover some light coming from places where we didn't expect to see it, like from between planets. This light may be coming from deep within our solar system, and it may be a new phenomenon that hasn't been studied before. In other words, there may be something at the center of our galaxy that produces a lot of light. spacecraft Voyager 1 also captured images showing a lot of light coming from the edge of our solar system. How come we haven't noticed this until now? Well, because most of the light in pictures taken by the Hubble telescope comes from things close to Earth. But people usually ignore this light because they're interested in things like stars and galaxies that are farther away. We've never actually looked closely at the amount of light in the universe and where it comes from. Scientists have been using the Hubble to find faint galaxies that may have been missed before and which may be the source of this dim glow. They found that there are not enough such galaxies to account for extra light in the sky. It's not a lot of light, though. It's like the glow from 10 fireflies. But it doesn't make it less important. It shows that we may be missing something. Let's look at some other important discoveries we've made with the help of Hubble. Like dark matter, which we can't see but know is there because of its effect on gravity. It makes up for about 23% of the universe. By looking at how it affects light, the Hubble telescope helped make 3D maps of where dark matter is. These maps show that dark matter seems to be getting clumpier over time, which means it behaves very similarly to how gravity does. The Hubble telescope also discovered 2 new moons around Pluto, named Nix and Hydra, and studied the dwarf planet's changing surface. Additionally, it's found the mass of planet Eris, which is larger than Pluto. This helps scientists realize there may be similar objects in the Kuiper Belt, a region outside our solar system. This led to Pluto being reclassified as a dwarf planet. Further observations of these distant objects could help us understand the evolution of our solar system. Gamma-ray bursts are the most powerful explosions in the universe, and for a long time, no one knew where they had been coming from. Hubble helped us find out that these bursts happen in galaxies, producing a lot of stars and having few heavy elements. This suggests that gamma-ray bursts happen when big stars collapse into black holes. These galaxies have lots of big stars that fall apart quickly, and the stars there don't have much heavy stuff, so they can turn into black holes. In 1994, the Shoemaker-Levy 9 comet collided with Jupiter. Hubble captured the whole event in detail, like a resourceful journalist. The impact broke the comet into a lot of small pieces, which resulted in 21 other visible collisions. The largest impact created a fireball and a dark spot on Jupiter's surface. Hubble's observations not only sparked public interest in cosmic impacts, but also provided new insights into Jupiter's atmosphere. To move forward with our list of discoveries made by the Hubble telescope, we also need to talk about black holes. There are points in space where gravity has so much force that even light cannot escape it. The gravity becomes so strong that matter gets squeezed into a very small space. We know that this can happen when a star, like the Sun, nears the end of its life. At the beginning of its life, a star's hydrogen ignites in its dense hot core. Because of gravity, it tries to draw its own mass into a tiny point. As long as it has the energy generated by the hydrogen fusion, it also pushes outward. If we look at it this way, the life of a star depends on a delicate balance between these forces, and it can last millions or even billions of years. Once that energy is exhausted, the only force remaining is that of gravity. So, some stars become black holes. Since light itself cannot escape its pull, we can't visualize black holes. For the human eye, they are invisible. We need special tools and unique telescopes to help us point them out in the universe. Hubble found that most galaxies with a central bulge of stars likely have supermassive black holes. It also noticed a strong connection between the size of these black holes and their host galaxies, which might help us understand how the universe has changed over time. Then, what is a supermassive black hole, you might ask? Go ahead, ask it. It is a very large black hole that is typically found at the center of a galaxy. It is millions or even billions of times more massive than our Sun. These black holes are so powerful that they can swallow stars and even entire galaxies. Scientists are still exploring these mysterious objects, but they believe that they play a crucial role in the formation and evolution of galaxies. Now, before Hubble, we really didn't know how old the universe was. It often led to weird paradoxes, like the one where stars discovered by astronomers were older than the universe itself. But by figuring out the approximate rate at which the universe is expanding, Hubble helped us narrow down its age, which is about 13.75 billion years. Trying to figure out the exact age of the universe is an important question. That's because most astronomers think that the universe has not existed forever, but appeared in one really hot and dense fireball called the Big Bang. I wasn't around then.
Boom! An explosion of supersonic waves, interplanetary heat, dust, fumes. The Earth's atmosphere has been invaded by a cosmic rock the size of Everest. A few seconds ago, this rock, weighing trillions of tons, was hurtling towards Earth. It could fly from New York to Anchorage faster than you could fry yourself an omelet. This monster's name? The Chicxulub Incident. Epic name, right? 66 million years ago, it crashed into the Earth. Back then, dinosaurs ruled the planet, but not for long. The epic collision took place in modern Mexico, in the Yucatan Peninsula, right near Cancun, where the dinosaurs were vacationing. Well, probably not. Still, the huge space rock hit the ocean, but even all that water couldn't stop the inevitable. The collision caused a huge amount of energy to be released. The horror on a planetary scale had begun. Imagine a mini-sun lighting up the surface of the Earth with tsunamis the height of the Statue of Liberty bursting from the epicenter of the watery impact. Not good. The blast blew through the surface of the Earth. It was as hot as an oven and burnt everything in its path. The impact provoked a colossal earthquake and serious volcanic activity. A bunch of volcanoes simultaneously released hot lava and ash into the prehistoric skies. Millions of tons of ash and soot poisoned the air. This formed a huge ash cloud in the atmosphere, which blocked out the sun's rays for several years. The long winter had begun. Only there wasn't any snow falling from the sky, but rain made of sulfuric acid. Yes, the Chicxulub incident might just be the most important thing that ever happened in the history of our planet. Even more than YouTube. Back then, there were loads of volcanic eruptions, a lot of flammable oxygen in the atmosphere, constant temperature changes. It was the perfect and worst time for all of this to go down. So, how are we so sure about all this? Well, the asteroid left an absolutely huge crater on the planet's surface. Today, this scar is hidden under the Gulf of Mexico. Scientists found a lot of places on Earth with abnormally high levels of iridium. This metal is very rare on Earth, but it's in a lot of asteroids that scientists have examined. Scientists studied some 66 million-year-old rocks. In the layers of rock, they found dust, the same dust that comes from asteroids. This could only have happened if a huge asteroid had crashed into Earth. The catastrophe led to the extinction of not only the dinosaurs, but also the asteroid. It was so hot at the point of impact, part of the asteroid just disappeared. A lot of water vapor and carbon dioxide shot up into the atmosphere. But the biggest problem, sulfur. It got kicked up by the asteroid impact and flew up into the air. These tiny sulfur particles blocked out a lot of the sun's rays. Without the sun, a lot of plants disappeared and the climate eventually got colder. The immense heat turned stones into glass. Scientists call these things tektites. The energy of the impact threw them up into the skies. After a short flight, the tektites fell down to Earth. But it wasn't pretty. Rain fell too, only instead of drops of water, you'd have seen hot glassy fireballs. They bombarded the planet's surface for days. The tektites set fire to everything. Scientists found evidence of this all over the world, not just near the collision site. But a lot of things from back then are still a mystery. Some scientists think that Chicxulub wasn't even an asteroid. It might have been a comet. Asteroids are mostly made of stone and metal. Most often they kind of look like a potato. A comet contains rock, metal, and ice. Comets look like dirty cosmic snowflakes, complete with ammonia, methane, and carbon dioxide. Comets sometimes come from the Oort cloud. It's a huge cloud of ice and debris around our solar system. From time to time, comets break free from the pack and head towards our sun. According to scientists, this special comet flew right past Jupiter. The gravity of that huge planet accelerated the comet even more. It flew towards the Sun, gaining more and more speed. The comet's outer ice shield started to evaporate, and it probably gave off a lot of dust and gas, which made it look like it had a tail. The Sun's gravity eventually shattered the comet apart. One of the fragments flew through space and crashed into the Earth 66 million years ago. So, asteroid or comet? The truth is, we'll never know. What we do know is that the Earth was seriously unlucky to be in its path, and it was never the same again. The catastrophe stopped the development of 75% of life on Earth. Some bigger marine animals, like crocodiles, turtles, and fish, survived the impact. Out of all land animals, the only ones to survive were the ones that were, on average, smaller than the modern raccoon. That includes a bunch of special species of dinosaurs, the ancient ancestors of birds. Scientists believe they survived for two reasons. After the huge impact, it took a long time for plants to start growing again, and a lot of animals didn't survive. Most remaining animals didn't have enough food. But these dinosaurs had a beak. With its help, they could split open nuts and dig seeds out of the soil, so they survived. The second reason is that these lucky guys had bigger brains. Some people think that they were able to cooperate with each other and quickly adapt to the new conditions. Other life forms survived too. Fungi and mold survived underground and underwater. Gradually, the darkness cleared away, and ferns began to take over the lifeless landscape. After a few thousand years, forests started to reappear. The animals that survived were pretty much all inconspicuous and small creatures. They lived in burrows, safe from all that hot ash. Before the collision, mammals had lived in the shadow of dinosaurs. But with all the dinosaurs suddenly gone, things were about to change. Mammals were able to take over. They began to dominate life, at least on land. Back to the moment when everything changed. Turns out, it wasn't the size of the asteroid that made it so powerful. It was more about the angle in which it hit the Earth. If the angle of impact had been different, the dinosaurs might have even survived the catastrophe. So, what would that have looked like? Well, let's travel back, way back. Oh no, there's a giant asteroid heading for Earth. Oh, wait, never mind, it missed. Whew. There are plenty of earthquakes, tsunamis, and volcanic eruptions every day, but dinosaurs don't mind that much. No big deal. Fast forward a few million years, and most of these ancient lizards have changed and are now unrecognizable. Thanks to a couple of ice ages, many dinosaurs are now totally covered with feathers to protect them from the cold. Mammals exist, but they're few and far between. You see a lot of bats in caves. There are tons of rat-sized rodents in the forests. During the day, they hide in the undergrowth or in burrows. At night, they go out in search of food. There are no horses, no elephants, or other large mammals. Why become large and eatable when there are so many dangerous reptiles with huge fangs around? There are no whales in the sea. Parrots, hawks, and pigeons are nowhere to be seen. But pterodactyls 2.0 whiz past you constantly. Some are about the size of a helicopter, while others are no larger than a swan. There are plenty of primates, but they're in no hurry to climb down from their trees and walk on two legs. No venturing out into the savannah, no evolution into Homo sapiens. In this alternate reality, open spaces are very dangerous. But then again, so are forests and trees. Nowhere is safe. To get some delicious primate treats, many smaller dinosaurs learned to climb trees. This was already happening back in the Cretaceous period, right before that huge asteroid just missed Earth. Whew, that would have been an epic collision. Dinosaurs have grown wiser since that near miss. Some are even as smart as a modern chicken. A large brain uses a lot of energy, and that's not always a good strategy for survival. Safer to keep brains small and keep making those teeth bigger and pointier. Well, guess what? Blue Origin, the company owned by Jeff Bezos, has sent dinosaur bones to outer space. Can you believe it? Why? Well, it's all part of their Dream Big initiative to inspire people, especially students, to reach for the stars.
On April 14, 2021, they launched almost 200 pieces of dinosaur bones into space using their New Shepard rocket. These bones are super old, like between 66 million and 70 million years old. They were fragments from a dinosaur called a Dromaeosaurus, which was part of a raptor family. It was kind of like a bird, but also a fierce hunter. It was about 7 feet long and had sharp claws on its feet. These guys were really good at hunting and slicing into their prey, you think? Can you imagine how cool it would be to see a real dinosaur like that? The bones were carefully packed into a small container that was about 4 inches long. Then, on April 14th, they launched into space on a test flight of Blue Origin's New Shepard rocket. The rocket went 65 miles above the ground, which is a little above the point where Earth ends and space begins. The dinosaur bones were in space for about 10 minutes and 10 seconds. Alongside them were more than 25,000 postcards from members of the Club for the Future, which is a special group that Blue Origin created to inspire future generations. There was also a test dummy named Mannequin Skywalker on the flight to collect data. Once the dinosaur bones came back from their trip to space, they were put on display. Each of them was carefully placed and shown to people who are part of the Club for the Future, as well as in museums all around the country. But you know what's even more surprising? This wasn't the first time dinosaur bones went into space. In the past, NASA astronauts also took fossils on their mission. Back in 1985, a piece of a baby dinosaur's vertebrae and an eggshell flew on NASA's Space Shuttle Challenger. And in 1998, a 210-million-year-old skull went on to space on another shuttle called Endeavour. They must have had quite an adventure up there. I don't know, do fossils have fun anymore? Oh, and don't forget about the Tyrannosaurus rex. Yep, even parts of a T-Rex were sent into space in 2014 on NASA's Orion spacecraft. I bet those bones were really big and scary looking. But, surprisingly, this is not the only strange thing we've sent into space. In fact, a lot of our weird stuff has been there. For example, back in 2018, Elon Musk, the guy behind SpaceX and Tesla, did something totally wild. He sent his own shiny red Tesla Roadster into space. But that's not all. Inside the car, there was a dummy dressed in a spacesuit, and they named him Starman. How cool is that? Originally, the plan was to put the car in orbit around Mars, but something unexpected happened. The car went way past Mars and got stuck going around the Sun instead. Can you imagine driving a car around the Sun? It takes almost 560 days for the car to complete one lap. It's almost a 2-year-long trip. As of June 2023, they have completed more than 3.5 orbits around the Sun and have traveled over 2.5 billion miles. That's like going around the Earth over 100,000 times. The car has definitely gone above and beyond its normal driving limits. What's that they say about your mileage may vary? Unfortunately, Starman doesn't send us any new pictures anymore. It's been a while since we heard from him. Scientists think that both the car and the dummy passenger may have suffered some damage during their cosmic adventure. But, oh well, it was inevitable. It's space after all. Now, another strange thing that will be launched into space is the president's hair. Yep, you heard that right. On President's Day 2023, a company called Celestis made an unusual announcement. They're going to send some famous president's hair into outer space. Hair samples from George Washington, John Kennedy, Dwight Eisenhower, and Ronald Reagan were carefully collected and verified. This precious presidential hair will then be placed on the Enterprise spacecraft, which is going to launch from Cape Canaveral, Florida, sometime in the summer of 2023. But wait, that's not all. The spacecraft won't just carry president's hair. It will also have remains of other important people. One of them will be Gene Roddenberry, the creator of Star Trek. Some of his ashes were sent into space before, back in 1997, on Celestis' first flight. Well, I guess some of his remains still remain for a second trip. Now, here's the best part. The Enterprise spacecraft will not stay close to Earth. Oh no, it'll have a grander destination. It's set to travel beyond the farthest reaches of our solar system. It's going on an incredible journey into the unknown, from hair to eternity. Prices starting at $12,500 and up. But it's not as cool as a space party. Back in January 2018, something totally funky happened. Rocket Lab, an aerospace company, secretly sent a giant disco ball into space. They named it the Humanity Star, and boy, was it a sight to see. This massive mirror was about 3 feet wide and covered in 65 shiny panels. It spun rapidly as it orbited around our beautiful planet, reflecting sunlight back to Earth. It was so bright that you could even spot it without a telescope. The Humanity Star was like a dazzling reminder of how delicate and special our place in the universe is. But here's the sad part. The disco ball's time in space was short-lived. It came back down to Earth's atmosphere on March 22nd, just 2 months after it launched. That was way earlier than expected. Guess the party had to end sooner than they thought. Now here's a fun fact. Just like with dinosaurs, the Humanity Star wasn't the first disco ball to make its way into space. Starshine Project launched 3 similar shiny objects between 1999 and 2001. One of those groovy satellites, Starshine 3, stayed up in space for over a year. And let's not forget about Japan's mirror-covered satellite called Ajise, launched in 1986, which is still up there orbiting Earth today. Humans sure love to send disco balls into space, huh? Well, scientists also have a sense of humor. So, prepare for some interstellar monkey business. Sometimes astronauts like to dress up as animals while in space. Back in 2016, an astronaut named Mark Kelly had a hilarious plan. He smuggled a full-body gorilla suit to his twin brother Scott, who was staying on the International Space Station. Can you imagine a gorilla floating around in space? Well, it happened. There's even a video that went viral. Scott surprised another astronaut, Tim Peake, from the United Kingdom, by chasing him through the different modules of the ISS while wearing the gorilla suit. And here's the twist. Tim Peake was actually in on the joke, so it was all a good-natured prank. Now here's a funny backstory. Mark Kelly had actually tried to send the gorilla suit to Scott in 2015. He hid it on a SpaceX Falcon 9 rocket, but sadly, the rocket went up in flames shortly after liftoff. Talk about bad luck for a gorilla suit. But do you know what item had better luck? The famous lightsaber from Star Wars, wielded by none other than Luke Skywalker himself. In 2007, a team of astronauts had a special mission. Alongside assembling the Harmony module on the International Space Station, they brought along Luke Skywalker's lightsaber. It was a tribute to the iconic movie series that inspired so many space lovers. The launch coincided with the 30th anniversary of the first Star Wars film, A New Hope. Fun fact, this lightsaber was Luke's second one, a cool green laser sword from Return of the Jedi. So these are the weirdest things we've sent into space. Next time you gaze up at the night sky, remember it's not just planets and stars out there. It's a cosmic playground filled with strange and wonderful objects from our very own Earth. And who knows what peculiar items will venture into space next?
We've all been afraid of the dark at some point in our lives, haven't we? I mean, do you remember getting tucked into bed by your mom or dad after they read you some scary fairy tale with monsters and dragons or even dinosaurs? But just as your parents were about to turn the lights off and silently step out of your room, you remembered. What if there was something hiding under your bed? Or worse, what if some spooky creature was stuck somewhere in the closet? You could probably get up and check, but it was too dark out there. Wouldn't it be great to have some source of light that would come from within your body? You could always use it whenever you get surrounded by darkness. Unfortunately, as humans, we aren't able to do that. But there are a bunch of creatures out there that can, in fact, light themselves up. That's thanks to a little something scientists call bioluminescence. Animals and fish living in the ocean tend to have this talent more often than others. And you can find these creatures anywhere, close to the surface or deep down at the bottom. 2.5 miles deep if you have a knack for numbers. These creatures use their light for a lot of things, like communicating with other members of their species, luring in prey, and even scaring away enemies. Bioluminescence is basically an organism's ability to emit its own light. Chemistry has a lot to do with it. Such animals use two chemicals, one called luciferin and the other called luciferase. Add a bit of oxygen and bam! Light! Should you ever wonder if you actually observe bioluminescence or if someone just dropped a glow stick in the ocean, be on the lookout for neon blue, green, or even red sparkles in the sea. They're usually spread over a large area. This can even make the water look like glitter or a starry sky. You can thank squid, tiny crustaceans, and algae for this romantic atmosphere. Now, I've got another unusual phenomenon for you. How about a golden waterfall? I'm not kidding, it actually exists, and it's a natural phenomenon. To see it, you have to drive to Yosemite National Park to the Horsetail Fall. Make sure to plan your trip in winter or early spring. That's the only time during the year when you can see this awesome phenomenon. It doesn't need any scientific explanation. It's nothing more than sunlight at dusk hitting the waterfall in such a unique way that it makes it look like a river of lava. Or gold, your choice. That's the reason why during this time of year, the Horsetail Fall is also named the Fire Fall. Unfortunately, this phenomenon is becoming less and less visible within the years, mostly because of drought and other issues connecting with the melting of snow. So, should you ever decide to visit, keep an eye on the waterfall since the effect is very brief. Ever heard of a dirty thunderstorm? It's also called volcanic lightning. Apparently, specialists looking into the phenomenon have yet to fully grasp what it is. When a regular thunderstorm happens, particles with positive and negative charges collide, hence the giant spark we call lightning. It also makes a lot of noise, which you can recognize as thunder. But when a volcano is erupting, some of the volcanic ash particles get electrically charged, and while getting projected into the air with a huge force, they collide and cause electrical discharges. This whole process makes it look like there's lightning coming from the volcano itself. Imagine all that ash, gas, and smoke coming from the crater, and then add some electricity to the mix. It'll make the whole picture look really bizarre. No wonder this phenomenon is called the dirty thunderstorm. Now, how about clouds that look like waves? Those are called asperitas clouds, and they're actually quite close to the ground, unlike your regular day-to-day clouds. The name comes from the word aspero, which in Latin translates to rough or uneven. On rare occasion, you may spot such clouds when the weather is calm, but they're mostly associated with thunderstorms. These clouds appear during unstable atmospheric conditions, and surprisingly, they don't produce rain. Even though they do resemble dark storm-like clouds, they also create random patterns, tricking your eyes into thinking you're looking at the surface of the sea from under the water. Another impressive kind of cloud is called mammatus clouds. What makes them so special is a series of bulges emerging from the base of each cloud. One such cloud enters a level in the atmosphere where the wind direction changes. You can see these wave-like patterns in the sky. Australia is the place for you if you like surfing, but not all the waves you can catch there are made of water. Near a town called Hayden, there's a mysterious wave made out of rocks. This granite formation supposedly dates back to 2.63 billion years ago. That's way before dinosaurs started hanging around the planet. Standing at 49 feet high and 360 feet long, the wave was formed as a result of two processes: weathering and erosion. There's softer sediment at the base of the wave rock, which was chemically weathered by groundwater. Winds and rain did the rest of the job, causing the erosion of the rest of the formation. Its red, yellow, and gray stripes are made of iron hydroxide, carbonates, and other chemical compounds that were washed down by the rain. You've made it to Australia, so stick around a bit more. There's one more location here that seems unreal. You'll need to fly over this one, however, if you want the best picture. In the western part of the country, surrounded by green woodlands, there's a series of lakes. They're all a staggering shade of bright pink. Out of them all, the most famous is Lake Hillier, a 2,000-foot-long reservoir. It's surrounded by both sand and a forest of eucalyptus trees. This makes the cartoon-like hue of the lake stand out even more. One of the many theories explaining the color of these mysterious lakes is connected with algae. These algae appear to gather high levels of a substance called beta-carotene, which has a red-orange pigment in it. Another explanation involves haloarchaea. Those are microorganisms that sometimes look red. Even if you don't enjoy flying, the lakes are great for taking a swim. They're not toxic, even though they have loads of salt in them. This means you'll be able to stay afloat easily, and the water won't damage your swimsuit. During winter up north in Canada, a bizarre phenomenon happens at Lake Abraham in Alberta. Underneath the frozen surface, you can spot some weird objects that look like frozen jellyfish. It's definitely not the case, as these creepy formations are just frozen methane bubbles. Those are pockets of gas that were trapped underwater and got stuck there after the lake had frozen. They appear when leaves and grass fall into the water and bacteria digest them. This process transforms them into methane. This phenomenon is as beautiful and strange as it is dangerous. The pockets of methane can easily become highly flammable. When the temperatures rise during the spring, the ice melts and these bubbles start popping and fizzing. It's a spectacular sight to observe. Picture a lake filled with soda. Remember not to bring any source of fire. It can be very dangerous for visitors. You can check out these types of lakes all across Canada's Banff National Park. Nature often tends to make its own music. Just listen to the sound of crickets at night, or the soothing noise of a waterfall. But in Bucks County, Pennsylvania, there's a strange geological phenomenon which takes nature soundtracks to a completely different level. These are called the ringing rocks, and scientists still can't explain their unusual behavior. If you strike these rocks with a heavy object, like a hammer or another rock, the stones will make a ringing sound, as if they were hollow, but they're not. What makes the ringing rocks even more bizarre, apart from the mysterious sound they make, is that no animal wants to hang around there. Even though the rocks are surrounded by a thick forest, scientists haven't managed to trace any animal activity in the area yet. Even more striking is the fact that despite all the trees around the rocks, you won't find any leaves lying on the boulders. What makes these rocks so unappealing for both animals and vegetation is still up for debate. The problem with that asteroid that destroyed dinosaurs was not that it fell, but where it fell. This colossal space rock found the worst place where it could land. Also, the angle at which it hit the ground was the most unfortunate. If it had fallen vertically, there would have been less destruction. But it fell at such an angle that it threw a huge amount of dust into the air. After the disaster occurred, tons of soot started burning. 65 million years ago, only 13% of Earth's surface contained the right amount of sulfur and oil needed to form a colossal amount of soot. If the asteroid had fallen on the other 87% of the territory, dinosaurs could still be living today, but it hit the worst place and lifted 1 million tons of burning material into the sky. A cloud of incandescent particles covered the sky and set off on a journey across the mainland. Then, these particles settled on the ground and caused large-scale fires. Trees were burning and sending more soot into the sky. But the asteroid collided not only with rocks, it fell on the coast in a place where the seabed was filled with sulfate. As a result of the collision, it started burning, which caused the release of sulfuric acid into the atmosphere. The air became poisoned. It seems the dinosaurs didn't stand a chance. And now, let's imagine the asteroid falling in another place, somewhere in the middle of the ocean. Huge waves flooded part of the land, but almost all kinds of dinosaurs survived. Or even better, the rock could have fallen somewhere in the desert and left behind a giant crater. That's all. Yes, several dinosaurs passing by wouldn't have survived the collision, but the situation wouldn't have been so critical in general. So, giant lizards remain dominant on our planet. They don't allow other animals to develop since Tyrannosaurus and other ferocious reptiles hunt mammoths and other ancient creatures. The population of mammals is decreasing. Velociraptors are fighting for territories with saber-toothed tigers and giant bears. A struggle for survival between dinosaurs and other animals begins. Then the Ice Age comes, and some reptiles don't survive. Then new players enter the field. Those are humans' early ancestors. Living side by side with dinosaurs is difficult. Lizards attack settlements and caves, so people have to build high walls for protection. By the way, the Tyrannosaurus poses less danger to people than you might have thought. According to the latest research, many creatures were able to run away from this monster. Yes, you probably saw how easily they caught up with cars in the movies, but it wouldn't be as scary in reality. Paleontologists and biologists have analyzed the strength of dino's bones and found out that the creature couldn't reach high speeds. The maximum it was capable of was running twice as slow as a field athlete. Thousands of years have passed. People have learned to live with dinosaurs. They've even managed to tame some lizards. They've domesticated herbivorous dinosaurs to develop agriculture. Triceratopses and bulls now plow fields together. Imagine farms swarming with diplodocuses or brachiosauruses. People climb their long necks and pick fruit from high trees. Stegosauruses protect pastures from wolves and velociraptors. Dinosaurs with shells, such as ankylosauruses, help people cross deserts. They, along with camels and donkeys, carry heavy loads. People share the planet with ancient lizards and live in harmony. The situation in the seas and oceans is much worse. Sea reptiles attack wooden ships and catch all the fish. Imagine that you're sailing to another continent with tons of grain, fabrics, fur, and other goods. And then a giant mosasaur appears on the horizon. It's one of the most powerful sea lizards. A great white shark looks like a small fish next to it. The creature could easily defeat a megalodon. And then it comes across a wooden ship. It bites into the deck and pulls the whole boat underwater. Water dinosaurs are the main obstacle to communication between countries. This slows the progress down for 100 years. People built metal ships to withstand the attacks of the mosasaur. And finally, they managed to establish sea connections. A similar problem occurs when the first planes take off into the sky. Imagine you're flying on a passenger Boeing. You look out of the window and see a pterodactyl. Wait, it's impossible. These winged lizards aren't so fast, but they can catch up with a helicopter or some old biplanes. This poses a serious threat to flights, so people install sound protection systems on board each aircraft. Pterodactyls hear irritating ultrasound from a distance and fly as far away from it as possible. People equip submarines and ships with the same sound shields. Then, after people have learned how to defend themselves from dinosaurs, another problem appears. Lizards are the kings of wildlife, so they displace all other animal species. Dinosaurs run across African savannas, and lizards with fur live in cold winter forests. Lions, wolves, and bears are not the rulers of the wild. Rhinos fight with Parasaurolophuses. Stegosauruses attack hippos and take away their territories. Venomous dinosaurs live in jungles. Lizards that can climb trees scare monkeys. Imagine a reptilian ape jumping from one branch to another. To save regular animals from extinction, people have to control the population of predatory reptiles. Huge parks and nature reserves appear in all countries. People transport dinosaurs there and separate them from other wildlife. Dinosaurs seem to be completely under control. When the danger caused by giant reptiles passes, people begin to breed smaller, harmless lizards. Someone buys a chameleon, and someone keeps a Microceratus at home. There are dinosaur exhibitions. People take these creatures for a walk as if they were dogs. Some people take selfies with reptiles, go shopping, and sit in cafes with small lizards. Dinosaurs aren't formidable now. They're kinda cute. People ride horses, camels, Parasaurolophuses, and Pachycephalosauruses. Of course, many have tried to tame velociraptors, but failed. Those are dangerous reptiles and they don't know how to obey. Taming them is almost as difficult as taming an alligator. But dogs and cats are still more popular because they're more intelligent. The brain of a dinosaur is almost the same as that of a chicken. But who knows, if they had lived to this day, perhaps they would have evolved into smarter creatures. Just imagine if dinos were intelligent. In this case, people would have a big problem. Some scientists think that even if a meteorite hadn't destroyed the dinosaurs, they wouldn't have survived to this day. they needed to carry their own colossal weight at all times. It was an enormous load on their bones and joints. Most dinosaurs wouldn't have been able to survive the Ice Age with such characteristics, but smaller lizards might have succeeded. Fast and agile dinosaurs, such as velociraptors and pachycephalosauruses, would have survived, but in what form? Could dinosaurs have already evolved into something else? Look at the good old chicken. Many scientists believe it's a direct descendant of the formidable Tyrannosaurus. Somewhere deep inside the bird's DNA, there are genes that the dinosaur had. Yep, it's hard to believe, but look at the chicken's body structure and how it walks. Remove the plumage, cover the creature with scales, and give it toothy jaws instead of a beak. And now, you have a mini T-Rex in the coop. And by the way, not only chickens might be the relatives of giant lizards, many birds are dinosaurs' living descendants. Surprisingly, alligators, snakes, crocodiles, and monitor lizards are not as close to ancient reptiles as pelicans, storks, and other flying creatures. Over millions of years of evolution, the paws of dinosaurs turned into wings, and toothy elongated jaws ended up as beaks. The genetics of birds is the key to understanding dinosaurs. Pelicans are similar to pterodactyls, ostriches to velociraptors. Perhaps many other animals also share some genes with ancient lizards. If the meteorite hadn't fallen, all dinosaurs would have evolved into completely different, unusual creatures. Scientists want to carefully study the DNA of birds and try to reverse evolution with the help of genetic engineering. They hope to breed dinosaurs out of eggs one day. But to do this, they need to find a specific genome that hasn't changed over tens of millions of years. It hides in the DNA. And it's not so easy to find it and extract it. Do you think we will see powerful reptiles by 2050?
66 million years ago, I wasn't around then, a huge asteroid hit the Earth and triggered the mass extinction of almost all living creatures on the planet, including dinosaurs. Had the space object crashed somewhere else, some dinosaurs would have been able to survive and still live nowadays. According to some research, the asteroid had about 1 in 10 chances of wiping out the dinosaurs and other animals of that time. It was way more likely to just hit the ground without any strong destructive consequences. To understand how things could have turned out if the place of the collision had occurred elsewhere, we need to find out what happened that day and why the disaster turned out to be so devastating. This huge space rock fell into the coastal area of the Yucatan Peninsula in Mexico. This caused a chain reaction that triggered natural disasters around the world. The place the asteroid hit is called Chicxulub Crater. Now half of this area is underwater. The asteroid was about 7.5 miles in diameter and moving at a speed of 27,000 miles per hour. This rock, bigger than Everest, was rushing toward Earth faster than the speed of sound by almost 40 times. Wow. The energy released in the collision was as powerful as an explosion of about 10 billion atomic bombs, and the destructive force of the blast wave was just one of several disasters. The asteroid happened to fall in one of the worst possible places, and because of the way it fell, it threw a huge amount of dust into the air. Imagine you're jumping into the water like a professional athlete vertically, leaving hardly any splashes behind. And now think of how much water splashes when you jump into the pool like a cannonball. So the asteroid landed the cannonball way. The second disaster the asteroid provoked was soot burning. A small part of the Earth's surface consists of rocks. Only a tiny percentage of that part was rich in oil and sulfur back then. The asteroid burned and lifted so much soot into the air that it would be enough to fill an indoor baseball stadium. According to research, 65 million years ago, only 13% of the surface of the entire planet could have contained the necessary amount of organic material for the formation of such a volume of soot. That's why this place was considered the worst. If the catastrophe had happened on the territory of the other 87%, then dinosaurs would have been alive today. A huge cloud of soot and carbon dioxide rose into the air and covered the sun. The soot turned the sky gray and partially blocked sunlight. This led to a quick drop in temperatures almost all over the planet. It seemed like Earth was inside a gray veil. Many plants and animals couldn't survive the cold snap. Trees began to wither because of the lack of sun. The photosynthesis process was disrupted. The cold and withering of trees led to another catastrophe: global famine. Herbivores couldn't survive because they lost almost all of their food. Plants, flowers, and trees didn't manage to get through the catastrophe. These destructions spread far beyond the asteroid impact site. Hot dust particles, asteroid chunks, and small pieces of rocks settled to the ground across the continent and caused large-scale forest fires. Burning trees threw even more soot into the air, which made the situation even worse. The huge asteroid brought heavy metals with an increased level of toxicity from space. The melting of these substances during the collision provoked firestorms. The asteroid didn't only hit continental land but also water, which triggered a huge tsunami. But that's not the worst part. The seabed was filled with sulfate, and when the energy of the asteroid burned it, it provoked the release of sulfuric acid into the atmosphere. The acid cloud mixed with a cloud of soot and began to spread throughout the sky. Hot rock particles were falling to the ground like fire rain. An acid rain started because of sulfur. It lasted for almost several days and left no chance for the animals to survive. Acid rain made the water in rivers, lakes, and seas poisoned. The acid destroyed anything that couldn't burn. A part of the clouds went to wreck the land, and the other part, the ocean. This made the situation even worse, as sulfur droplets wiped out a huge amount of seaweed and phytoplankton. The ocean generates almost half of all oxygen reserves on our planet. Those days, the sea creatures living in its upper parts were destroyed. It wasn't the blast wave, but lack of sun, acid, darkness, and cold that became the main reasons for the extinction of dinosaurs. But even when some lizards escaped from fires and sulfur, they met the sea element. The asteroid impact caused large-scale tsunamis across the planet. The very first wave was around 1 mile in height. That's almost 3 times higher than the Empire State Building. Billions of gallons of water were moving at 90 miles per hour. A wave this strong could easily destroy half of New York today. The meteorite created a series of waves 52 feet high. Massive walls of water the size of 5-story buildings collapsed on the shore and demolished everything in their path. Lack of sunlight, temperature drop, acid and fire rains, reduced oxygen production, forest fires, giant tsunamis, and the explosive wave with the power of 1 billion atomic bombs. All this reduced the biological diversity of Earth by 75%. Yeah, that'll change your climate for sure. Giant asteroids used to hit Earth before, but they never caused such disasters all over the planet. What if this asteroid had fallen into another place, say a forest, far from water and mountainous terrain? This would have caused severe fires. A huge black cloud of ash would have risen into the sky and obscured the sun. But it would have unlikely generated acid or fire rains. Most of the species of the planet could have survived this catastrophe. What if the meteorite had fallen somewhere among the ice and snow? This would have provoked a rapid increase in temperature across the planet. Huge tsunamis would have sunk big tracts of land. However, ash and sulfur dioxide wouldn't have filled the sky. Acid rain wouldn't have hit the ocean. Many marine creatures could have survived and lived to this day. And dinosaurs, far from the oceans, wouldn't have noticed the meteorite fall at all. Probably the most terrible events would have occurred if a meteorite had fallen on an active volcano. This would have triggered the largest lava release in history. Destructive earthquakes would have begun, and the whole sky would have been covered with volcanic ash. What if the meteorite had hit some desert? It would have melted billions of tons of sand and turned it into glass. Just imagine glass dunes that heat our planet even more. And we could dig up the well-preserved remains of ancient lizards out of the glass. Anyway, there were many different possible catastrophic scenarios, and the worst of them came true for the dinosaurs. They are unlikely to return, although perhaps they can be reborn. Scientists were inspired by an idea from a famous Hollywood movie. They wanted to find a mosquito that got stuck in amber. They would extract dinosaur DNA from it. But there was a problem with this. The oldest DNA sample they managed to find was 1 million years old. Dinosaurs were extinct about 66 million years ago. Besides, DNA is a very fragile thing. The probability that it could have been preserved intact somewhere for so long is very small. So, instead of searching for this ancient dinosaur DNA, scientists decided to take DNA from the closest ancestors of these lizards, birds. Over millions of years of evolution, dinosaur paws could have turned into wings, and elongated mouths could have become beaks. Pelicans are very similar to pterodactyls, ostriches resemble velociraptors, and chickens are very much like T-Rex. Okay, let's just stop and imagine for a moment a chicken the size of a T-Rex.
Hey, you want a piece of me?
Now, the common chicken is recognized as the closest relative of the huge lizard. Remove the plumage from it, cover it with scales, give a toothy mouth instead of a beak, and attach a long tail. And you get a real mini Tyrannosaurus rex by body structure and movement. Deep in its DNA, there are similar genes that formidable predators have. With the help of genetic engineering, scientists plan to play with its DNA and try to reverse the evolution, which means breeding dinosaurs can become a reality. Well, that could come back to bite you. Hundreds of dinosaur species roamed our planet, and researchers give a name to a new type approximately every 2 weeks. It's not fair to stick to T-Rex, Stegosaurus, Spinosaurus, and other famous sauruses all the time. They've had their chance to shine in the movies and across the internet. So let's check out dinosaurs that no one talks about. First on our list is Torosaurus. The special thing about this dinosaur is that it definitely had one of the largest skulls ever found. It was big because of this frill going from the back of the animal's skull and covering its neck. The frill wasn't there for protection. It was probably just to show off a bit. The bone in the frill was thin and full of holes. As you can see, it's very similar to Triceratops. There are still debates about whether these two are the same species, but more and more studies show that they were more like cousins. They were probably similar in size, but Torosaurus had a longer head with big openings, as well as longer frill bones with a groove on top. It also had more pairs of horns on the back of the frill. Some like to call Torosaurus a bull lizard. These fellas were plant eaters that may have lived in social groups. They existed at approximately the same age, but Torosaurus somehow ended up on the less popular side of the family. Kentrosaurus was a small stegosaurus. It's one of the least cuddly dinosaurs of all time. Its long, thin spikes seemed to be a pretty good defense mechanism. Stegosaurus, on the other hand, had shorter, thicker spikes that were less likely to bend or snap when the animal used them. Now, you wouldn't want to get anywhere near Kentrosaurus, though. Its tail could swing in a big half circle and hit with a force strong enough to break a human skull. Any volunteers? No? Okay. One scientist used scans of the dino's fossils to make a computer model of its skeleton. The model showed that Kentrosaurus had a flexible neck. It must have been really useful for looking around to see if something interesting was going on or if there was any dangerous animals trying to sneak up. Kentrosaurus typically walked on all four legs with straight hind limbs. The computer model tells us it could spread its front legs out to its sides, too. Maybe it was a way to protect its belly during fights. Stegosauruses, in general, had tails that were like big weights at the back of their bodies. That's why their balance point was closer to their hips. That's also the reason why they could easily stand on their hind legs and swing their tails around. So most people haven't heard of heterodontosaurs, even though their fossils showed that dinosaurs got feathers way back before we thought and in groups where we didn't expect it. In 2008, paleontologists identified the first known skull of a baby Heterodontosaurus, which was less than 2 inches long, smaller than a tea bag. This baby dinosaur had relatively big eyes and a short snout compared to bigger ones of its kind. Now, what's really interesting is that some scientists used to think that Heterodontosaurus's tusks, like those of modern warthogs, only appeared when they were fully grown. But it seems they had them from the early stages of their life. Heterodontosaurs had 5 fingers on each hand, 2 of which were opposable. It was a good tool, considering the animal probably ate both plants and meat. Humans have different types of teeth, some for biting, some for chewing, and also canines. But most reptiles have just one kind of teeth. Pedrodontosaurus was special because it had 3 different types of teeth: small peg-like ones, big teeth resembling canines, and square-shaped teeth that did the cutting job. Scientists are not entirely sure how this creature used these different types of teeth. Maybe it was for digging up roots, breaking into termite nests, or even defending themselves against dangerous animals. Okay, say this name with me now: Psittacosaurus. She was quite a common dinosaur in its time, but she never still gained popularity. Scientists found out that when these dinosaurs were young, they probably crawled, considering they had longer arms and short legs. But as they got older, between 4 and 6 years old, their hind legs started growing much faster and became much longer than their front legs. So later in life, they likely didn't move on all 4s anymore, but walked on 2 legs. Inside the stomach of one of these creatures, scientists found pebbles. This shows the animals either had a hard time digesting what it ate, or it didn't chew its food very well. Its beak looks quite familiar. That's how it got its specific name, a parrot lizard. It was really strong, and some believe the creature used it to crack and open tough nuts and seeds before the pebbles in its stomach helped mash them up for digestion. These guys might have been good at swimming. They had broad feet, and the shape of their tail could have helped them move in the water relatively easily. Some scientists even believe they might have spent most of their lives swimming in rivers and lakes. In 2004, researchers found something really sweet: 24 young parrot lizards huddled together. They were too big to be hatchlings, so it could be a bunch of teenagers who had left their nests and then formed a group where they could support one another and defend themselves better. But apparently, that plan didn't work out so well. Now, check this one out: Stygimoloch, or as they call it, Styx demon. We're looking at a peaceful plant-eating creature with bony spikes and knobs on its skull. Most scientists believe it was a younger form of this fellow, even though they used to think they were a separate species. Stygimoloch is smaller than its more popular cousin, but it's also more robust and has a pretty thick neck. This dinosaur, with small forelimbs and long hind legs 3 feet high, which is half as high as an average human. That doesn't sound dangerous in the world of giant and fierce dinosaurs, but the animal had a very thick skull roof. Maybe it wasn't the strongest tool to defend itself, but it probably helped in combat with rivals from its own species. They most likely headbutted to win the hearts of their chosen ones. But rivals from its own herd were a piece of cake compared to the predators that might have gone after it. After all, this dino lived at the same time as old T-Rex. Now, when someone tells you to picture a dinosaur, Chisaosaurus would probably be the last thing coming to your mind. It looks as if you've put together pieces of random animals and tried to make your friends believe this truly was a real animal that once roamed the earth. But it's actually a dino, with giant sharp claws on its forelimbs, a bulky body, and a long neck ending with a tiny head. Now, don't let the claws scare you though. These creatures didn't go after other animals since they were herbivores, but these claws could protect the animal from intruders and predators. The full scientific name of this creature describes it as a giant sloth-like reptile from China. This animal was one of the biggest and oldest members of the group where it belonged, which lived around 115 million years ago. No, I wasn't around then. At first, it was hard to tell which animals were related to this weird-looking dinosaur. But in the 1990s, scientists made a conclusion that they were modified plant-eating theropods, which is similar to carnivorous dinos. They also most likely had feathers and small wings, like some sort of a very big turkey. tiny critters to colossal creatures, all animals are trying to escape from a wall of fire moving in their direction. The temperature is rising, and everything around starts catching fire. Soon, lots of animals and plants on Earth will cease to exist. This is the aftermath of a giant asteroid crashing into our planet. But what if dinosaurs had had critical thinking skills? They could have guessed what was going to happen, because this asteroid was visible a year before the impact. 1 year before the impact. With no city lights, all bright spots in the sky are stars. Some of them are planets reflecting the light coming from the sun, like Mars. But one of these dots is the asteroid. Later, it's going to be known as Chicxulub Impactor. It got this name because of the region of modern-day Mexico where it fell. Anyway, at this point, the asteroid looks like a star. It has the same brightness as Neptune. You could even have photographed it with a high-quality camera. If only dinosaurs had thumbs. The impactor is now passing through Jupiter's orbit. From this distance, Earth looks like a pale blue dot. 1 month before impact. The asteroid has become much brighter. It's now the most brilliant spot in the night sky after the Moon. The asteroid crosses the orbit of Mars. Its tail, consisting of dust and gas, is getting longer and longer. It's now as long as 2 times the distance from Earth to the Moon. 1 week before the impact. The intruder's tail is now 5 times the distance from the Earth to the Moon, but the dinosaurs can't appreciate its beauty. To them, it's just another bright dot in the night sky. If this asteroid were flying toward Earth right now, scientists could pinpoint the exact location of its impact within a mile. Then we would evacuate people from the impact area and avoid a major catastrophe. 1 day before the impact. The Chicxulub Impactor now holds first place among the brightest objects in the sky. The light surrounding it, called a halo, seems even bigger than the Moon itself. The asteroid is now passing through the Moon's orbit. It looks like a bright spot that leaves an ashy trail behind it. 1 hour before the impact. The light from the Chicxulub Impactor is brighter than the full Moon, and its movement can be seen with the unaided eye. Nights on Earth aren't dark anymore. Only now, dinosaurs begin to feel anxious. All animals on Earth start to seek shelter. 10 minutes before the impact. The asteroid is now passing through Earth's orbit. Thousands of small fragments from its tail begin to fall on the planet. It looks like a meteor shower. So far, these fragments are too small. They all burn up in the atmosphere before reaching the surface of the planet. The asteroid is approaching South America. If someone was looking at it from Europe, it looked like a sunset. The bright dot of the Chicxulub Impactor is falling behind the horizon. 2 minutes before the impact. Dinosaurs can now easily see the asteroid's shape. If they knew how to do it, they could even estimate its size. It's a bit more than 6 miles across, which means it's almost the size of Manhattan Island, and the giant's weight is 15 plus 15 zeros pounds. It's flying toward the Yucatan Peninsula at a mind-boggling 7.5 miles per second. At that speed, you could get from New York to Los Angeles in around 10 minutes, but you'd kind of burn up on the way. 10 seconds before the impact. The Chicxulub Impactor is now approaching the ground. A few more feet and bam! The night sky suddenly turns white. The flash is so bright that the sun isn't visible at this point. The asteroid's entry causes a powerful blast that can be heard on the other side of the world. The huge asteroid begins to burn because of friction with the air. It heats up and splits into many pieces. These pieces shower on Earth. After a few seconds, the largest part of the meteorite hits the ground. Its mass and speed provide the Chicxulub Impactor with an enormous amount of energy. In the next moment, a super powerful explosion shakes the ground. The blast wave from the meteorite begins to spread out from the impact site. It rips out huge chunks of soil and trees and then pushes them to the ground like dominoes. The temperature of the blast wave is so high that everything around the impact site catches fire. The energy released during the collision also penetrates deep into the planet. This causes the strongest earthquakes in our planet's history. They, in turn, generate tsunami waves as high as the Empire State Building. 5 minutes after the impact. The meteorite leaves behind a huge crater. It's as wide as Lake Huron and deep enough to fit inside 2.5 Mount Everests. Dinosaurs are running around in panic. They try to evacuate toward North America, but most of them don't make it through unfamiliar swampy territories. Another danger is the ongoing meteor shower. Hundreds of tons of ash and debris rise into the air.
Heated up by high temperatures, they fall to Earth in the form of liquid lava. Ash and smoke fill the atmosphere and block the sun's rays. Earth plunges into darkness. For several more weeks, our planet will be totally dark. Acid rains will fall on its surface non-stop. There was a lot of sulfur in underground deposits on the Yucatan Peninsula. The energy of the explosion evaporated all this sulfur. Now it's cooling in the air, gathering in clouds, and dripping to the ground. Most animals survive the impact, but the mass extinction continues for many more months. The collision has plunged Earth into darkness, and this has wiped out most of the plants that fed on sunlight. The plant-eating dinosaurs have lost their main food source and begin to disappear. But plant-eating dinosaurs are the main diet of meat-eaters, and now dinosaurs like T-Rex have nothing to eat. Soon they go extinct too. In other words, it wasn't a meteorite that wiped out dinosaurs, but hunger and climate change. Meteorites of this size fall once every 100 million years. It means that such an event might happen again. Will humans manage to survive this disaster? These days, we can look out far into space, and the appearance of an asteroid the size of the Chicxulub impactor won't be a surprise to astronomers. In general, asteroids that are more than 460 feet across are considered potentially dangerous. Anyway, if we know about the approaching space body, we'll be able to build shelters filled with food and water supplies. Once the asteroid is close enough, we can wait for the impact and its consequences inside. But when people come back to the surface, they'll see cities and towns torn down. Our planet will look like a lifeless desert. That's why we need another alternative, which is to prevent the impact. Here, we have many options depending on the size and material of the asteroid. According to NASA, the most effective way is a kinetic ram. We'll need to send a fairly large and heavy object, such as a spaceship, into space. When it approaches the asteroid, scientists will choose the perfect trajectory, and the ship will crash into the space body. A powerful collision will change the asteroid's course, making it fly past Earth. The further the space body is from our planet, the easier it'll be to send it away. Another option is a controlled explosion on the surface of the asteroid. Newton's first law of motion will help us here. It says if a body is moving at a constant speed in a straight line, it will keep moving that way unless it is acted upon by a force. So, if we make a big enough explosion or force, the asteroid will shift its trajectory. How much it moves depends on the amount of force applied to it. We can also blast the asteroid right from inside. In this case, there will be no need to change its trajectory. Instead, we'll try to turn one huge hunk of rock into a bunch of smaller fragments. They will burn up in the atmosphere and do no harm to our planet. Another way is a gravity tug. Every heavy object has its own gravitational force and gravitational field. Our goal will be to send a spacecraft to the asteroid and make it fly close to the intruder. The asteroid will attract the spaceship, but its engines will resist. As a result, the ship will slowly but surely pull the asteroid toward itself. This method will take much longer, but gradually, the trajectory of the asteroid will change and it won't crash into Earth, hopefully. We can also use solar power. We can build a spaceship with a system of giant magnifying lenses. Then we'll send that station closer to the Sun. When we spot an asteroid, we'll point the lens in its direction and focus the beam on the space body. The heat from the Sun will cause the asteroid's material to evaporate. Eventually, this will make the intruder change its trajectory. Traveling back in time now, this used to be hard. We fly past the Middle Ages, the first human civilization, the ancient ancestors of the first humans, the dinosaurs, the first land animals, the ancient sea creatures, and so on to the very beginning of all time. And there it is! This nebula is our solar system. Right now, it's just a cloud of multicolored dust made of hydrogen and helium spinning around. This cloud has begun to shrink and become denser. There's a theory that there were supernova explosions near our nebula. Their shockwaves squeezed the nebula from different sides until the center of the cloud became too heavy. The enormous weight presses it, and nuclear chain reactions begin at the very center of this cloud. It heats the cloud and makes it glow. Soon it forms into a dense sphere, and that's how our Sun is born. It happened about 4.5 billion years ago. Our planet doesn't exist yet. There's only a disk of dust and space debris orbiting the young Sun. These pieces of debris are fusing gradually and getting heavier and heavier. Let's look at the very center of this pile of asteroids. The total weight of the debris compresses the central region so much that a dense metallic core is forming there. The enormous pressure heats the core, and the temperature at the center of the young Earth reaches nearly 10,800 degrees. And there's a liquid core around the solid one. It creates the magnetic field of our planet. Now, when radiation from the sun and the solar wind reaches Earth, it smashes into a shield in the form of our magnetic field. So far, our planet is burning and looks more like a ball of lava. But it begins to cool down, forming a solid crust. At this point, another protoplanet appears on the horizon. It looks more like an asteroid, the size of Mars, and this massive piece of debris flies towards us. It hits the young Earth at such an angle that it knocks a part of our planet outward. The debris itself breaks into several pieces and stops in our orbit. After a while, all of this debris comes together to form the Moon. As a result of this collision, the Earth began rotating too fast. A day now lasts about 5 hours instead of the usual 24. But the Moon is heavy enough to slow our planet's rotation with gravity. Now, the Earth doesn't look like a hospitable place. The gravitational forces of the Moon are penetrating deep into the Earth and causing more volcanic activity. Also, meteorites are constantly falling here, causing frequent explosions on the surface. Ow! The gas that comes out of the volcanoes forms our atmosphere. The ice that was brought to our planet on meteorites evaporates. The vapor rises and turns into rain. This rainwater falls to the surface, cooling the hot lava and forming the first lakes and rivers. For several 100 million more years, Earth resembles the surface of Venus. It's a lifeless place with a bunch of volcanoes, acid rains, and no oxygen to breathe. The sun wasn't as bright as it is now. Plus, the sun's rays could barely pass through tons of volcanic dust in the atmosphere. But about 3.5 billion years ago, the first life appears here in the form of single-celled organisms that didn't need oxygen. They appeared in the shallow, warm parts of the ocean near the shore. These bacteria reigned on Earth for nearly 2 billion years throughout the Archean eon. They left stromatolites. These are stone pillars at the bottom of shallow warm water. They're the product of simple organisms and bacteria. These bacteria evolved until they learned photosynthesis. Bacteria began to produce oxygen by absorbing the energy of sunlight. At first, this oxygen was spent on oxidizing rocks, but then excess oxygen began to fill the atmosphere. Plus, at this time, the first algae appeared, which also produced oxygen. This event is called the Great Oxidation Event, good name, which caused almost all living organisms to disappear from the face of the Earth. For simple organisms, oxygen was toxic, and the remains of bacteria and microorganisms sank to the bottom of the ocean. Many millions of years later, these remains will be recycled, and under the tremendous pressure of water and the Earth's crust, they will turn into oil. The Archean eon ended with this catastrophe about 2.5 billion years ago. At the same time, continents were forming on Earth, which would later drift through the world's oceans like puzzles and form a supercontinent. But for now, methane and carbon dioxide still make up most of the atmosphere. They cause the greenhouse effect and the rising temperatures on Earth. But the emergence of oxygen stops the greenhouse effect, and the temperature on our planet drops. An ice age, the so-called Huronian glaciation, which lasted from 2.4 to 2.1 billion years ago, begins. Scientists speculate that our planet was almost completely covered in ice at that time, even on the hot equator. A huge change when you consider that 2 billion years ago, our planet was like a ball and lava, but now it's like a block of ice. Earth, during the Huronian glaciation, was more like Jupiter's satellite Europa. There, too, is a thick crust of ice, under which there's a liquid ocean heated by the core. The evolution of the Sun saved our planet. Since its birth 4.5 billion years ago, it's been getting bigger and hotter. So, after 300 million years of an ice age, the Earth began to warm up. But almost all life there had been wiped out, and evolution has to start all over again. About 1 billion years ago, all of the continents of our planet were assembled into one hypothesized supercontinent, Rodinia, and all the oceans made up one colossal ocean of Miravia. 750 million years ago, that continent broke apart and huge chunks of land began drifting across the planet. Complex plants and multicellular organisms appeared just at this time. Algae, sponges, and fungi weren't the only inhabitants of the ocean. This is Sprigina. They're a kind of worms the size of a human finger. We have remains of these animals that are at least about 550 million years old. 541 million years ago, the Phanerozoic eon began. The main event at that time is the Cambrian explosion. Life began to blossom on Earth, and a great variety of living organisms appeared. Mollusks and echinoderms like starfish and sea urchins appeared. Living organisms evolved, having not only an internal but also an external skeleton, like trilobites. Some of these things could reach nearly 3 feet in length. Their protective shells suggest that there were predators in the ocean. A food chain started forming at that time. At the same moment, the drifting continents fused again. This supercontinent has a different shape and is called Pannotia. Later, these continents drifted apart again and began to collide with each other. This led to the formation of mountain ranges. Then the continents met for the last time and formed the giant supercontinent Pangaea about 335 million years ago. Here we can already see the outline of the modern continents of Africa, North and South America, Australia, and Eurasia. One of the largest sea creatures ever, the Dunkleosaurus, appeared. Some individuals could be as long as a school bus and weigh as much as a large SUV. The land had a hot and humid climate. It encouraged ferns and other plants to grow faster. Some of them could reach the height of a 3-story building. And for the first time in Earth's history, some animals leave the ocean and go on lands, such as L. generpeton and Ichthyostega. Anyway, at first, they live only on the coast because their skin wasn't adapted to the constant sunlight. In addition, they experience breathing problems. The first animals on land had both gills and lungs, but the lungs were underdeveloped, so they had to return to the water. Millions of years later, these animals evolved into more advanced amphibians. Though they were no bigger than ordinary lizards, they could already live fully on land. But this blossoming of life ended in a new ice age. Glaciers from the poles slowly crept toward the equator. Animals weren't prepared for this, and most of them didn't survive this extinction event. But 290 million years ago, evolution retook hold and more evolved land animals began to appear. Gradually, they increased in size, multiplied, and gave birth to a new species like Scutosaurus and Gorgonopsis. But this period didn't last long either. Only 40 million years later, as a result of unknown events, 95% of all living organisms on Earth ceased to exist. It could have been caused by a giant meteorite or by increased volcanic activity. Also, one hypothesis says it could have been the release of methane from the bottom of the ocean. The Mesozoic era began after this extinction. This is where the dinosaurs, as we know them, appeared and started a new page in Earth's history.
You're picking some veggies in the garden when you come across something big and round. It's covered in soil. When you dig it out, you find out it's a giant egg, bigger than one of an ostrich. But you don't have any chickens or ducks. And even if you did, none of those animals could lay an egg of that size. You pick it up. It seems real. You take the egg inside and build an incubator for it. A couple of days pass, but nothing. You go on with your life and forget about the egg's existence. You've been working in your garden all day long. All you want now is to get into a tub filled with hot water and have some dinner later. But while you're eating, you hear some noise coming out of the room with the incubator. You ignore it, thinking it's just some mice scampering around. But then the sound intensifies. You head there and see the eggshell cracking. In a couple of minutes, something begins to crawl out. You grab your phone and immediately start filming it. A tiny reptile pokes out of the now broken egg and starts examining its surroundings. You're shocked. You place your phone on a special platform to keep filming the creature. Meanwhile, you grab your laptop and begin researching what animal it could be. The creature doesn't have the snout of an alligator, nor does it look like a Komodo dragon. You go back to your dinner and feed the reptile some leftover meatloaf. It gulps the food down in a flash. The next day, you build a small terrarium to keep an eye on your new pet. Over the following weeks, you record every second of its life. You call the reptile Buster. The creature has already grown to the size of a dog. It runs fast and jumps pretty high too. You think it might be some new reptile species, but it doesn't crawl like an alligator or a lizard. Your pet has 2 tiny arms and large legs. Its jaws are massive for an animal its size. The reptile also has razor-sharp teeth. Your friend comes over for a movie. At one point, Your reptile runs into the living room and starts biting the furniture. Your friend freaks out and starts yelling, "Dinosaur!" You calm him down and take the dino to the garage. You explain to your friend how you found the animal, and he tells you to contact someone to examine it. The next day, you take Buster to the vet and take a seat in the waiting room. You keep your pet in a cage so that no one can see it. But the dino starts growling in a strange way. Many people grab their pets and move away from you. It's finally your turn. You bring Buster in and show it to the veterinarian. The man looks shocked. He puts the creature on a metal examination table and starts looking closely at its features. Sharp teeth and claws, scaly skin. The vet tells you you've been raising a T-Rex for 3 weeks. He calls in other specialists to examine the animal. The next thing you know, you're in a lab with a bunch of scientists studying Buster. You sit there anxiously as they collect its DNA samples. They even ask for the footage you've been recording. After a couple of hours, they come back and tell you that you indeed have a dinosaur. They'll have to keep Buster in the lab to conduct further studies, so you go home feeling a bit lonely. A couple of years pass. Now you have a degree in paleontology, specializing in T-Rexes. You've been working with the lab and monitoring Buster that has turned into a fully grown dino. You also teach at the university and have published a book called My T-Rex Buster. It has become a bestseller. One day, you come back from the university and turn on the TV. That's when you hear breaking news. A large creature has broken out of a lab outside the city. It's now on the loose. They show several images of the beast's footprints that lead to the forest. You get a call from the lab. They ask you to head down there as fast as you can. The researchers tell you what's happened and ask you to accompany them to the forest to find the dino. You put on a special protective suit and get into a jeep. After a couple of hours, you arrive at the spot where Buster was last seen. You get out and try to follow its footprints, but the rain has removed the marks the creature left almost completely. The scientists check the tracking device placed under the dino's skin, but it's not working. They bring some food Buster likes to try to lure it out. After a couple of hours, there's no news. It's already night when you hear some rumbling in the distance. Everyone jolts awake. People around you are on high alert. You hide and wait. A large shadow the size of a school bus appears from the dark. A fully grown T-Rex can reach 40 feet long and 12 feet high. The giant lizard approaches the meat and sniffs it. After a couple of moments, it runs off. Everyone gets out of their hiding places and tries to follow the animal. The meat has a special substance in it. It was supposed to put the dino to sleep. This way, it wouldn't be a problem to bring it back to the lab. But the dino was smart enough to feel something suspicious. Despite its size, the T-Rex is quite slow. It can move at a speed of only 12 miles per hour and can't even outrun a human. But Buster somehow manages to cross a raging river and disappears into the dark forest. No one has been prepared to make it through such an obstacle, so the whole team makes a detour through the mountains. It's a difficult climb, with everyone carrying the equipment needed to catch the T-Rex. From the height of the mountain, you can see almost all the forest. Far away, treetops are shaking. The giant reptile is heading to the north. Everyone tries to get to the other side of the mountain as fast as they can. But then, one of the crew members slips and falls. Good thing a safety rope holds her in place. You pull the woman back to the path. You continue walking until you reach a cave. Everyone puts on their helmets with flashlights and goes inside. The deeper you go into the cave, the smaller it gets, so you have to crawl to get through. The rocks are sharp, and there's water everywhere. It's easy to get lost in here. The cave starts trembling. Everyone rushes to get through the narrowest part. You finally make it out of the cave. That's when you find out that the cave was trembling because of the T-Rex. It was stomping around the mountain. It spots your group and starts running towards you. People panic and rush back into the cave. The T-Rex catches up with your team and tries to snatch someone, but by that moment, everyone is already safely tucked inside the cave. Suddenly you scream, "Buster!" Shockingly, it seems to calm the creature down. You step outside, even though everyone is trying to hold you back. You get outside and face the massive creature. It's just staring at you. You slowly approach it, trying not to make any sudden moves. Someone from inside the cave gasps. It startles Buster. It starts thrashing and roaring, but you're still there, trying to calm the animal down. Eventually, it gets quieter and comes closer. You put your hand on its head, caressing it. After a few seconds, someone inside the cave steps on a twig and it cracks. The T-Rex jolts and runs away. You're furious. Now, you have to track it once again. After you spend many more hours in the forest, the sun starts to rise. Everyone is exhausted and about to pass out. You decide to call it a day and head back home. But as soon as your team gathers near the jeeps, you receive a notification that a giant T-Rex has entered the city. A helicopter picks up you and the other team members. There isn't enough room for everyone, so several people stay behind, waiting for the next chopper. The T-Rex is dashing through traffic. People in the streets are running for their lives. Dozens of news companies are filming the incident. Many people are posting it on social media. The dino breaks into the mall and destroys everything it sees. Your helicopter lands, and you get out, trying to think of a way to calm the creature down. You rush into the mall, but the T-Rex has already run away to the other side of the building and managed to escape. You're following it, but suddenly you get a phone call saying that the team members left behind in the forest have spotted your T-Rex. You can even see the live footage of the animal. That means there are 2 giant reptiles on the loose in your state.
Big herds of dinosaurs run through the forest. The temperature rises rapidly, and everything behind them begins to ignite. Some dinosaurs get stuck in swamps and can't get out. Pterodactyls fly over their heads as they try to avoid the blast wave that will soon cover the Earth. This event happened about 66 million years ago. It wiped out almost every living thing on Earth. Birds and flying dinosaurs were just about the only ones who could survive the most massive extinction event ever. Hey, don't blame me, I wasn't around then. Let's go down their evolutionary tree to look at the world's first bird, Archaeopteryx. It was about the size of a modern raven, but it looked like a small dinosaur with feathers. It had many small conical teeth, almost like alligators. It's because Archaeopteryx was closer to reptiles than to birds. However, its brain was 3 times larger than that of these reptiles. Although it had wings with feathers, it could hardly fly like modern birds. Its shoulder joints didn't allow it to lift its wings above its back, so it couldn't make a full wing beat. Most likely, Archaeopteryx was capable of gliding flights with small wing flaps. Evolution has led to more evolved species capable of full flight. Pterodactyls. These guys had no feathers, but membranes made of skin and muscle. Its wingspan was about the length of a human leg. It could fly perfectly and catch fish and small animals. Although flying dinosaurs could easily outrun terrestrial predators like velociraptors and T-Rexes, most of them didn't make it through the impact of a giant meteorite. Let's look at this event step by step to see how they got to our time. 10 minutes before the meteorite crash. A massive rock about the size of Manhattan Island is moving towards Earth in space. It weighs 460 trillion tons. That's like 3 trillion blue whales, the heaviest mammals that ever lived on Earth, and it's approaching our planet at 12 miles per second. At that speed, it could cross the Atlantic Ocean in just 4.5 minutes. That's twice as fast as our modern spacecraft could fly. 5 seconds before the meteorite crash. Ooh, this is getting tense. The Earth's gravitational force continues to pull the giant meteorite. It blows a hole in our atmosphere and creates a popping sound so loud you could hear it on the other side of our planet. All the animals on our planet wake up in a panic. They lift their heads up and see a huge rock that begins to burn through the air. Smaller fragments start to break away from the main meteorite. This fire is so bright that it shines almost like the sun. Flying dinosaurs and other ancestors of modern birds are the first to sense danger. They make a beeline to the sky and try to fly as far away from the impact site as possible to save their lives. The moment of impact. The colossal mass and velocity of the meteorite give it an enormous amount of energy. As soon as it touches the Earth, it causes an explosion of 150 trillion tons of TNT. The blast wave literally rips out chunks of our planet and throws them up. A huge wall of energy begins to move from the point of impact in all directions. It snatches the trees out with their roots and pushes them to the ground like dominoes. The shockwave completely wraps around our planet. This energy turns into heat. Everything around the impact site begins to ignite. Green jungles and trees turn into smoldering charcoal in seconds. The ground and rocks simply evaporate. The collision caused a massive earthquake. Some dinosaurs may have fallen into cracks that appeared in the ground. A strong earthquake caused a tsunami with waves higher than the Empire State Building. Dinosaurs that weren't trapped in the burning forest were washed away by the enormous waves. The dinosaurs of North America tried to escape by running to the north, but the blast wave inevitably catches up with them. Flying dinosaurs have no problem with earthquakes or tsunamis. They fly high enough to avoid the giant waves, but they will have to contend with continuously falling meteorite debris. 5 minutes after the meteorite crash, a meteor shower of giant rock fragments continues to fall to Earth. Some meteorites were the size of a car, others were more like a large building. Ashes and dust rise into the air. Their temperature is so high that they melt and turn into liquid lava and then fall back to Earth, causing more fires. Meteor showers cause trouble for flying dinosaurs too. They have to maneuver and dodge the falling red-hot rocks. The high temperatures are a huge problem for them because it might make them lose feathers. With no feathers, they aren't able to fly. 10 hours after the meteorite crash, the dinosaurs continuously ran north all this time. They found themselves in unfamiliar territory with many swamps. Giant dinosaurs like T-Rexes have legs as long as an adult human's height. They have a chance to get through this terrain, but if they fell, they could never get back up. The smaller dinosaurs like Triceratops had short legs and couldn't go through the dense swamps. 1 month after the meteorite crash, 15 trillion tons of ash were ejected into our atmosphere. A dark cloud blocked the sun, and the Earth was immersed in complete darkness. Surviving plants couldn't feed on the sun's energy and stopped producing oxygen. Surviving dinosaurs could hardly breathe because of the lack of air and a large amount of dust. The lack of sunshine in the sky made photoplankton disappear. Many marine animals were left without their only source of food. The dust and ashes in the atmosphere prevent our planet from getting heat from the sun, and the temperature here is beginning to drop. The place where the meteorite fell was rich in sulfur. This toxic acid evaporated at the time of the impact and formed in clouds. Now there are acid rains on Earth. Flying dinosaurs now have to hide from these rains. They have to stay in caves and can't go outside to get some food. So far, a large number of terrestrial and flying dinosaurs have survived. They come out to see the aftermath of the disaster. The site of the impact was in present-day Mexico, the Yucatan Peninsula. The Chicxulub crater is located here. It's about 93 miles wide, like half of all of Lake Michigan, and it's 12 miles deep. You could plunge the whole Mount Everest in there, and there would still be 6.5 miles of available space. It wasn't the impact itself that made the dinosaurs disappear. The fire destroyed most of the plants the herbivorous dinosaurs ate. With no food, their numbers dwindled rapidly. Predatory dinosaurs had nothing to eat either. Acid rain and the disappearance of photoplankton threatened all marine life. Even though birds managed to avoid the blast waves and tsunami, they were short of food too. About 80% of all birds didn't make it to the end of the extinction event. The problem was that all of the forests on Earth were wiped out. Most birds would nest and live in trees. Besides that, the forests were always full of food, from all kinds of ants and termites to flying insects and small mice. So, only those species that lived on the ground and could fly well survived. Most likely, they fed on the seeds of small surviving plants. This habit made flying dinosaurs lose their teeth during evolution. Instead of jaws with a bunch of sharp teeth, they got long beaks to grab tiny seeds from the ground. Although Earth looks like a terrible place to live now, there's an evolutionary boom for birds. They have to travel long distances in search of food. Their wings get stronger. They also feel safe from predators who regarded them as food before. No T-Rex now catches a sleeping bird off guard. About 1,000 years after the collision, the first dense forests appear. It gives another boost to evolution. 1 million years later, forests full of food are populated by the ancestors of modern mouse birds. And 65 million years later, in modern times, we have about 10,000 species of birds. Pigeons, crows, eagles, and hawks, even penguins. These are all descendants of the dinosaurs. But there were other survivors. Some alligator and crocodile ancestors were able to adapt to changing conditions. About 80% of turtle species managed to survive the mass extinction, and now their descendants live among us. Snakes and lizards were also able to wait out the hard times in their burrows. Even some mammals, like monotremes, survived. this hedgehog-sized animal was able to continue to evolve. Many millions of years later, these mammals evolved into primates, which later gave life to modern humans. Much later came the iPhone.
Have you heard about a diamond star that could put all the riches on Earth to shame? Or how about twinkling stars with surfaces made of solid iron? So let's take a look at these weird stars and try to unravel their mysteries. There's a star in the Centaurus constellation that was nicknamed Lucy in the Sky with Diamonds. Yes, it was named after a Beatles song, because it basically is a Beatles song. You see, the star was discovered to have a massive diamond at its core. Now, you may be wondering how big this diamond really is. Well, it's estimated to be about 10 billion trillion carats. That's a 1 followed by 34 zeros. To put that into perspective, the Hope Diamond, which is one of the largest diamonds on Earth, is a measly 45.5 carats in comparison. Can you imagine the size of the ring you could make with this star diamond? And it's about the same mass as our sun. But don't get too excited about the prospect of owning this diamond just yet. Even if you were Jeff Bezos, you wouldn't be able to afford it. According to Ronald Winston, CEO of Harry Winston Inc., the diamond is so big that it would likely depress the value of the market. So you'd have to settle for a much smaller diamond engagement ring. One interesting thing about the Lucy in the Sky with Diamonds star is that it's incredibly dense. In fact, it has the mass of the sun crammed into an object only a third the diameter of Earth. That's like trying to fit an elephant into a shoebox. And yet, despite its massive size, it's actually quite cool, with a core temperature of only about 12,000 degrees Fahrenheit. By comparison, the core temperature of our sun is about 27 million degrees Fahrenheit. Since the discovery of Lucy in the Sky with Diamonds, several other crystallized stars have been found, some with diamond hearts the size of Earth. It just goes to show that the universe is full of surprises, and you never know what kind of treasures you might find out there in the vast expanse of space. And this isn't the only weird star we've discovered so far. There are many strange, unexplained things in outer space. For example, let's take Vega. Vega, also known as Alpha Lyrae, is a bright star located in the constellation Lyra. It's one of the brightest stars in the night sky and is easily visible to the naked eye from most parts of the world. Now, Vega may look like a beautiful, bright star to us Northern Hemisphere folks, but little do we know, it's hiding a secret. It's actually quite squashed. You see, Vega's high spin rate causes it to bulge at the equator, kind of like a cosmic belly. It rotates once every 12.5 hours, which is pretty fast for a star, and it throws material out around its waistline. It's almost like the star is hula hooping. This material is further from the center of the star, so it experiences less gravity, causing it to cool and darken, leading to a gravity darkening effect. So Vega is basically a cosmic fitness guru's worst nightmare. Although for us stargazers, it still looks round because we're looking at it from Earth's pole end. However, if we saw it from a different angle, we'd get a very different view. One that might make us wonder if Vega has been sneaking some cosmic donuts behind our backs. But while we might joke about its equatorial waistline, there's no denying that Vega is still one of the brightest and most fascinating stars in our galaxy. But if you want something actually bright, then how about a supernova? Supernovas are giant space booms that occur when stars reach the end of their life cycle. It's like the grand finale of a fireworks show, but on a cosmic scale. They release more energy in a few seconds than our sun will produce in its entire lifetime. And this is exactly what happened to the next star of our show. This celestial object, with a weird name, IPFT14HLS. But there's a catch. It isn't your average supernova. Even though this star made a blast in 2014 and started to fade away like usual, recently it made an unexpected comeback and brightened once more. Talk about a dramatic entrance. And if that wasn't enough, this thing continued to fade and brighten at least 5 times in total, which is a bit like a yo-yo. It's like the star just couldn't make up its mind about whether it wanted to stay bright or fade away into the abyss. Also, when scientists measured the supernova's spectrum, they found that it was evolving 10 times slower than other stars. Maybe it's a supernova that just wants to enjoy its golden years. All in all, this object is a real mystery. But this is not the only star suffering from the 2-in-1 syndrome. At first glance, MY Camelopardalis appears to be a fairly common star, but after a closer look, astronomers concluded it was actually 2 stars in one. These 2 stars are orbiting each other at over 600,000 miles per hour. It's a contact binary star system, which means that the stars are so close together that they share a common envelope. In other words, they're so close to each other that they're practically smooching. These celestial Romeo and Juliet are one of the most massive known binary stars out there. Each of them individually weighs in at a whopping 32 and 38 solar masses, respectively. Astronomers also think that they might be on the brink of a stellar merger, which means that one day they might just combine into one giant superstar. Wow, who knew space could be so romantic? Next, introducing another long name, HD 140283, also known as Methuselah's star. This little guy in the constellation Libra has been around for a while, and by a while, I mean a really long time. Actually, scientists used to think it was older than the universe itself. Just imagine if it turned out to be true. But eventually, they figured out that it's actually around 14.8 billion years old, a peer of our universe. That's still pretty impressive though. This star is so old, it remembers when the Milky Way was just a baby galaxy. But despite all that, this star still has some life left in it. It's just starting to expand into a red giant, which is kind of like when you hit your 30s. Talk about aging well. But if all these things are somewhat comprehensible, then how about a star that was literally named WTF star by scientists? No, I'm not kidding. At least it used to be. Now it's called Tabby's star. It also has a more scientific name, but that one is a bit of a mouthful. But what's really bizarre about this star is its irregular dimming. For some reason, it doesn't glow like a normal star, but blinks, as if someone turned on and off a flashlight. And it's not just a little dip, we're talking up to a 22% drop in light. So it's not because it sometimes gets blocked by a planet or something. Scientists have come up with all sorts of explanations for this strange behavior, from comets to dust to even an extraterrestrial megastructure. That's right, but before your imagination runs too wild, it's important to note that the most likely explanation is just plain old dust. Perhaps the star is surrounded by some kind of dust cloud, and sometimes it prevents us from seeing it clearly. Although this explanation is still not 100% confirmed, there are still plenty of mysteries surrounding Tabby's star. One thing's for sure, it may be a bit of an oddball, but that's what makes it so fascinating. So, there you have it, folks. We're left in awe of the incredible diversity and strangeness of the cosmos. There's so much more to discover out there. So let's keep exploring and keep being amazed by the wonders of the...
Now tell me, what's the scariest thing in the universe? What, besides Darth Vader and a lightsaber? Well, actually, I was asking about black holes, swallowing anything that comes too close without doubts or regrets. Blinding supernovae, mysterious hypothetical wormholes? Yeah, probably not. Because the most terrifying things in the universe are likely to be rogue planets. Ooh. Nomads, orphans, sunless, unbound. That is what these creepy worlds are called. They have no sun. Unwanted in their star systems, they were once ejected into the soulless emptiness of space. And some of them didn't even have their own star systems. They were born lonely. Rogue planets don't have sunlight. The never-ending night reigns on their surfaces. No light means no warmth, and almost no chance of any kind of life to be able to survive in these frozen worlds. How lonely! Kinda makes you tear up a little. Okay, I'm done. But how do rogue planets get born? When planetary systems, including our solar system, form, it can get messy. Most planets appear from the cosmic dust that is floating in space around a newborn star. And when these planets form, they push one another. This gravitational game of tag often shoves some planets toward the edges of the newly formed star system. And sometimes, one or two of them get ejected from their home altogether. There are also nearby stars that can play with planets too. Stars aren't often born on their own. Clusters of dozens to thousands of stars can appear in space. And in such a crowded environment, it's not a rare occurrence when a star with its own planets steals away a planet or two from another star. After getting a new planet, it can keep it for itself or throw it away into the dark, deep cosmos. Some free-floating planets pop up in a different way, with no parent star to help them. Like stars, they form from collapsed clouds of gas and dust, but since they are too weak, they can't put on enough weight and can't start nuclear reactions that make stars emit light. Such planet-like objects are known as failed stars. Or planets can go rogue after their parent stars disappear. Yes, sometimes stars go out, destroying some of their planets in the process. At the same time, the most distant ones, located in a safer zone, are left more or less intact. But the enormous force of a supernova ejects these planets away from the former star at a tremendous velocity. In any case, astronomers think there may be more rogue planets in our home Milky Way galaxy than anyone ever suspected. A recent simulation has shown there might be billions of them. But the problem is rogue planets are very hard to detect. You know, it's a tricky feat to find any exoplanet, even when it belongs to a planetary system. After all, planets don't give off their own light like stars. That's why when astronomers want to locate an exoplanet, they look for something blocking the light of its parent star, and it's usually the very planet passing between the star and the observer. But researchers can't use the same technique with free-floating planets because there's no parent star and thus there's no light to get dimmer. Another method of detecting exoplanets is the radial velocity method. It detects the planet's gravitational effect on its parent star. But, as you may guess, it doesn't work with rogue planets either. Luckily, there are still some ways we can detect these space wanderers. Imagine a line of sight between a telescope on Earth and a distant star. When an object crosses that line, its presence is likely to bend and magnify the light of the star. This makes it appear brighter than usual. The trickiest part is to figure out whether this object is a rogue planet. It's true that the stars whose light such celestial bodies bend can't be their parent stars. They're too far away. But there might still be a small parent star invisible because of the glare of the main star. And astronomers have to wait for a long time, sometimes up to a decade, for the main star to move a bit. Then they can finally check if there's also a parent star out there. If there's no parent star in sight, then it's proven the planet is traveling solo. Not apparently. So far, astronomers have identified at least 70 rogue planets or candidate rogue planets. At the same time, we know about more than 5,000 exoplanets in planetary systems. That's a huge gap that proves that detecting rogue planets is a tricky business. Interestingly, free-floating planets might not be as lonesome as we think. They can potentially have moons of their own. They might even take them along when they get pushed out of their cosmic homes. But could a free-roaming world, and possibly its moons, find a new home near a different star? Some experts think it's unlikely. The universe is a very spacious place, and even a large star with an incredible gravitational pull is hardly able to catch a fast-moving planet. For example, in 2017, an interstellar guest, an asteroid the size of a skyscraper, appeared in our solar system. It barreled through the solar system and just kept going without stopping or even slowing down. Now let's have a look at a rogue planet we have managed to spot. Just 20 light-years away from the Sun, a bizarre rogue planet is roaming the Milky Way galaxy. And even though this planet doesn't orbit any star, it still has an incredibly powerful magnetic field, 4 million times stronger than that of our Earth. The exoplanet, with this crazy long name, also produces amazing auroras. When it was discovered a few years ago, astronomers were almost sure they had detected a brown dwarf. This is an object too large to be a planet and too small to be a star. But later, scientists got some evidence that the space object wasn't big enough to be a brown dwarf. The planet sure is a mammoth among its peers. It's 1.2 times as wide as the largest planet of the solar system, Jupiter, and more than 12 times as heavy. Astronomers think the exceptionally strong magnetic field helps the planet produce such auroras. But the most curious thing is that they're generated in a different way than auroras on Earth. It might be because the exoplanet's moon helps the planet create these light shows. To find more amazing rogue planets, NASA's Nancy Grace Roman Space Telescope is going to conduct a survey using the powerful techniques of a wide-field telescope. The stars in our Milky Way galaxy move all the time, and chance adjustments of the telescope can help researchers spot rogue planets. But there's one drawback. We won't know the distance to such a planet even if we find one. There's one more mission concept called Cleopatra, the clever NASA acronym for the Contemporaneous Lensing Parallax and Autonomous Transient Assay. See, I told you it was clever. It might be able to exploit parallax effects to calculate the distances to rogue planets. Parallax is a shift in the position of a foreground object when seen by observers in slightly different locations. Could Earth one day turn into a frozen sphere aimlessly floating through space? Unlikely. Since our sun isn't going to blow up one day, our world isn't likely to be pushed out of the solar system by our star going supernova. But a rogue planet could cause life on Earth to end. Oh boy. One day, such a space intruder might push Earth out of the habitable zone near the Sun and take its place. And our planet would have to retreat to an extreme orbit farther from the Sun. The climate all over the planet would start getting colder and colder, turning first half of the planet, then our entire world into an icy desert. There would be a lack of food and other resources. It'd be getting darker and darker. There wouldn't be enough light for planets to get energy. They would wither, and animals that used to feed on them wouldn't be able to find food. Most species would go extinct. The farther our planet would be from the Sun, the weaker the star's gravitational pull on our planet would be. In the end, our beautiful Earth would get too far away from its main source of light and heat. It would turn into a lifeless piece of rock covered with a thick layer of ice. Wow, bummer. But hey, don't worry, I guarantee that will never happen. At least, not on my watch. Now, are there real-life space monsters? Well, of course, there are no huge beasts made of stars that are flying through the universe. However, there are some things in space that truly remind us of things from our nightmares. The first one is the Eagle Nebula, also known as Messier 16 or Star Queen Nebula, a wonder located in the constellation Serpens. This dazzling nebula was discovered in the 17th century and earned its nickname from the visual impression it creates. If you look at it, it resembles a giant eagle flying through the universe. It's a young star cluster, located super far away, about 5,700 light-years away from Earth. The Eagle Nebula spans a region of about 70 by 50 light-years in size. For comparison, our entire solar system is only 2 light-years long, with the distance between the Sun and Pluto being only around 5 light-hours. This enormous nebula is home to more than 8,000 stars. One of them is especially bright. It's a duo of massive stars, one about 80 times heavier than our Sun. And the nebula is actively creating new ones. Every day, the gas and dust in there are being compressed by the intense radiation and stellar winds from hot, massive stars within the cluster. This triggers the birth of new stars. And finally, in the heart of this nebula lie the iconic pillars of creation. These are vast columns of dust and gas seen in blue, red, and green hues. They serve as active stellar nurseries. The dark clouds slowly draw together to birth the stars of the future, shaping the rich and complicated materials found in the universe. Pillars of creation stretch about 4 to 5 light years, so about twice as big as our entire solar system. The Eagle Nebula is remarkably interesting to astronomers. It's a wonderful place for us to study the star's birth and evolution. The grandeur of this place is amazing. However, it's more fascinating than frightening, unlike the following monsters. Quasars, captivating powerhouses fueled by supermassive black holes at the heart of galaxies. These black holes are millions to billions of times the Sun's mass. Matter spirals into them, forming a luminous accretion disk. Gravity within generates intense energy across the spectrum, making quasars shine brilliantly. Sometimes they can even outshine entire galaxies. These cosmic monsters have been intriguing astronomers for years. Quasars have the appearance of regular stars, but have incomparable levels of energy. Their name comes from quasi-stellar radio sources. They're radiating across the spectrum: radio waves, visible light, ultraviolet light, X-rays, and gamma rays. We've been catching their signals for many years, but first glimpsed them only in the 1960s. Quasars are one of the most ancient objects in our universe. Their light, traveling billions of light years, helps us to learn more about the universe's early days when these monsters were aplenty. They gradually dimmed over time, so we can only imagine how brightly they looked back then. One of the most iconic of them is Quasar Colossus. It's not one monster, it's a giant group of 73 quasars. Together, they're spanning 4 billion light-years and outshine 100 million Milky Ways. Something like that is impossible for us to even imagine. Our next monster is called a pulsar. When a big star goes out of its fuel, it goes boom. What's left behind that is a neutron star, which has a mass several times that of our Sun, but crammed into a sphere as small as a city. They're super dense. Sometimes it teams up with some friend, like a companion star. If the companion shares its stuff with a neutron star, things can go wild. The extra material might make the neutron star collapse, becoming even denser. In that case, it would turn into a so-called quark star. But if it doesn't happen, the neutron star goes a different route. This immense density means that the protons and electrons in the star collapse into each other, forming a sea of neutrons, particles without an electric charge. This is when the so-called pulsars are born. Now, pulsars come with an incredible magnetic flare. These stars boast magnetic fields trillions of times more powerful than Earth's. The fun begins when this supermagnetized pulsar starts to spin. It's not a leisurely twirl. Pulsars can rotate hundreds of times per second. They're the fastest objects in the entire universe. As the pulsar whirls around, it shoots out beams of electromagnetic radiation. These beams act like lighthouses, sweeping across the universe with each rotation. If the Earth happens to be in the path of one of those beams, astronomers detect pulses of radiation. That's where the name pulsar comes from. There's someone closely related to pulsars, the zombie stars. Sometimes, even after the star reaches the end of its life and goes supernova, it doesn't fade away entirely. Some matter might remain. In that case, it transforms into a celestial zombie. These zombie stars often appear in pairs, with one star giving in to its smaller companion. It acts like a vampire, feeding on other nearby stars. It drinks up hydrogen to come back to life. When it grows to the size of a planet, it bursts into a brilliant supernova again, destroying the star it fed on. Zombie stars aren't fussy eaters. They go beyond devouring stars. One of them is in the Virgo constellation, and it doesn't just munch on stars. It gobbles up the energy and stuff from its planets. And just like actual zombies are always on the go to find more food, these stars travel through galaxies. Recently, we found another one of them in a faraway galaxy. It's been traveling and evolving over the years, getting brighter. And this show started millions of years ago, back in the age of dinosaurs. Studying them can help us better understand how space objects work in wild conditions. It also helps us reveal secrets about fundamental particles and explore the physics of super-dense stellar leftovers. Now that we've met zombies, there are also cosmic vampires. Blue straggler stars defy aging by sucking life from their neighbors. They appear younger and bluer than their ancient companions because of that, confusing poor astronomers about their true age. Scientists studied 21 blue stragglers in a faraway 7 billion-year-old star cluster. That's when they made a breakthrough. They assumed that it was because of mergers or collisions. But then scientists revealed these sneaky stars as thieves, feasting on nearby stars to stay forever young. While this discovery explains most blue stragglers, a few remain mysterious, which means they probably have varied origins. Researchers plan to use the Hubble Space Telescope to detect their hidden companions and learn more about them in the future. Our final monster is an electric leviathan. In 2011, astronomers stumbled upon a colossal jet spewing out of a galaxy with a funny name, 3C303. It's 2 billion light-years away. What made this discovery truly electrifying was the electric current it carried, an insane 1,018 amps. For comparison, a regular light bulb can barely reach 1 amp. This is equivalent to 1 trillion lightning bolts. This jet, powered by a supermassive black hole at the galaxy's core, extended over 150,000 light-years, surpassing the Milky Way span. This faint galaxy, first observed in the 80s, was hidden from us for a long time. We only discovered it thanks to catching different wavelengths. Typically, jets emerge from galaxies with active supermassive black holes. Only around 10% exhibit matter-spewing jets. The secret to the record-breaking current of this little galaxy lies in the hyperactivity of its black hole. This black hole creates a super robust magnetic field, and this magnetic field creates this electrical leviathan. So not only do we find the universe's highest electrical current, but it also marked a rare opportunity to study one of these large jets. Scientists keep making their equipment better to study in more detail, so we can learn more about them in the future. So check this out. Astronomers have discovered an exoplanet they're calling Super Saturn. It's got rings over an AU wide. An AU is the astronomical unit, the distance between the Sun to the Earth. That's an incredibly huge ring system, hence its name. Super Saturn is being called Mamajek's object after the astronomer who led the team to whom we owe the discovery. Professor Eric Mamajek of Rochester University in New York found Super Saturn while scouring through data downloaded from wide-angle transit observations. WASP is the acronym for Wide Angle Search for Exoplanets. It's an ingenious project developed in the year 2000 by astronomers at Queen's University in Belfast, Northern Ireland, and St Andrews University in Scotland. Using 4 telescopes, the CCD video cameras on the scopes record the slight dimming of starlight caused by objects passing in front of stars. This is called the transit method of exoplanet detection. So, for example, the planet Venus transits across our view of the Sun every couple hundred years. A black dot, The silhouette of Venus is visible, crossing in front of the Sun as Venus passes between our line of sight and the Sun. This tiny eclipse causes the amount of sunlight coming to Earth to be reduced by a minuscule amount, also known as teeny tiny. The same is true for all the stars in the Milky Way that have planets going around them. Exoplanetary transits in front of stars must be in direct line of sight with Earth for the starlight to be dim. Such transits do not occur very often. That's why thousands of stars must be looked at simultaneously for as long of a duration as possible, between 4 and 8 hours a night. WASP was created to stare continuously at as wide of a range of stars as possible. Maybe one of them would show an exoplanet transit. That translates into a lot of data being produced, about 40 gigabytes per viewing session. Computer scientists at Leicester University in England developed a computer program to store the data and generate photometric graphs of the light intensity of each star. Open University, also in England, joined the WASP project, took this data, and made it available for research by astronomers worldwide. The graphs of the intensity of starlight show that changes in its brightness are called light curves. These graphs have two axes. One is in the timeline axis, the other one is the intensity of light. As the object, considered an exoplanet, though it could also be a brown dwarf star, crosses in front of the star, the timeline axis keeps track of how swiftly it is moving. It tells us how close the object is to the star, while the brightness axis keeps track of how much the starlight dims. This way, we can find out how large the object is. Now, obviously, big objects will dim the light more and be easier to detect. At present, Earth-based equipment is not sensitive enough to measure the dimming caused by planets as small as Earth. Neptune's size and larger ones are the limit for WASP. However, the James Webb Space Telescope, which is now in operation, has a much greater sensitivity and will be able to resolve the transits of Earth-sized exoplanets. Now, I know you want me to get to Super Saturn, but there's something else you should be familiar with before we get there. If the exoplanet has an atmosphere, or, in the case of Super Saturn, a ring system, the starlight from the star the planet is transiting will shine through the atmosphere or ring system, and that can be detected too. The light curve will show less dimming in the photometric data, because not all the starlight is being blocked. Some light is still getting through the atmosphere or rings. This is important because it gives astronomers a reading of the atmosphere. The James Webb Space Telescope is fitted with spectroscopes that can determine the gas content of the transiting exoplanet atmospheres: oxygen, methane, carbon, etc. The WASP project has been really catching on. There's a Super WASP project now consisting of WASP North and a WASP South. One looks at the sky above the northern hemisphere, the other looks at the sky above the southern hemisphere. There's also a Next Generation Transit Survey, NGTS, based on the WASP project. It's automated, so astronomers don't have to stay up all night sipping coffee, but they can if they want to. Located at the European Southern Observatory in the Atacama Desert in Chile, the NGTS scans millions of stars and has discovered over 100 exoplanets, down to a size as small as 3 times the size of Earth. NGTS has started a Planet Hunters Club on social media. Citizen scientists can search the online database of light curves and perhaps discover your very own exoplanet. What had been a strictly British effort started by 1 or 2 astronomers is now a worldwide phenomenon. With the ability to read the spectroscopic signatures of atmospheric gases during exoplanet transits, a new idea emerged: technosignatures. That is, specifically identifying gases in exoplanet atmospheres that are produced by civilizations. The James Webb Space Telescope can do this. Gases from pollution, such as chlorofluorocarbons (CFCs), can be seen spectroscopically if present. Tritium from fusion reactions, if they have them, can also be detected, along with heat patterns from cities on the planet's surfaces. Technosignatures is a recent concept that originated after the WASP project started. Who knows what it will turn up? Now, let's get back to Super Saturn. The star that Super Saturn orbits is J1407. a small, dim, sun-like pre-main sequence star of the 13th magnitude. Huh? Well, the human eye can only see stars to about the 6th magnitude, and each magnitude is 2.5 times dimmer than the previous one. So it's not an exceptional star, just another telescopic star out there in the Scorpius Centauri region of the night sky. J1407 is a young star that hasn't yet settled into its stable, long-duration phase. This is important because Super Saturn, officially J1407b, is showing signs of having a ring system in an early stage of development. Super Saturn's light curve was tucked away in the mountain of data from the Super WASP project. Professor Eric Mamajek and his associate Matthew Kenworthy of Leicester University studied the data thoroughly and produced a detailed report on it. Knowledge depends on good data. The horizontal axis of J1407b's light curve, the time axis, is what's causing all the hubbub. It took Super Saturn weeks to transit across in front of its parent star, 56 days to be exact. Planetary ring systems that we are familiar with in our solar system orbit right around the equators of the gas giant planets and are very thin, from only a few meters thick down to a few centimeters. In a telescope, Saturn's rings will seem to disappear when the planet is at zero inclination toward Earth. Saturn must be inclined at an angle in relation to Earth to see Saturn's beautiful ring system. It's something everyone should make a point of seeing: Saturn in a telescope. If Super Saturn's rings block most of the light from J1407 for 56 days, it means that the planet had to be orbiting at a steep inclination to its star. If it were at zero inclination, we wouldn't see the rings blocking any light. Therefore, the orbital time could be determined, 10 years minimum to 200 years if the orbit is highly elliptical. The superplanet itself is calculated to be 24 times the mass of Jupiter, which means that if it is gaseous, it could be a brown dwarf star. Super Saturn appears to have a Mars-sized object orbiting around it, because there is a huge gap in the rings that was most probably cleared out by a large object. The Cassini division in the rings of Saturn is where the moon Mimas has cleared out a path through Saturn's rings. The light curve of Super Saturn has only been observed once. All the exoplanet detection systems are keeping an eye out for it to come back around J1407. No one knows when that will occur. Some astronomers have suggested that J1407b is a brown dwarf star system in itself, merely passing in front of, but not connected to, star J1407. An orbital reappearance of Super Saturn would disprove that conjecture. The center region of Super Saturn blocked out all the light from its primary star. This is what indicates that the ring system is new and in an early developmental phase. Over time, the very dense ring mass close to the planet is expected to thin as all this matter gets absorbed into the planet or ejected into space. This is what has happened with our solar system's gas giant planets. The Mamajek object is a shocker. Never before or since has a light curve been detected like Super Saturn's. Super Saturn has added a new chapter to our understanding of the formation of ring systems. So, here's to you, Super Saturn. Hope to see you again soon.
The sun's heat is beneath our feet. Scientists have figured out that Earth's core is actually as hot as the surface of the sun, around 10,800 degrees Fahrenheit. One of the reasons it's so incredibly hot down there is because Earth is still shedding heat from when it was created billions of years ago. Also, when an object as big as Mars slammed into the young Earth, it not only created the moon, according to one theory, but melted the surface of the planet. A lot of that extra heat is probably still stored inside the core. But there's no need to worry. The planet's core is harder for us to access than it is to probe the surface of Pluto. In fact, chances are we may never develop technology that could physically reach the core. There's no air on the moon. But then, how can it be rusting? Scientists have discovered the presence of hematite on the moon, and it's a kind of rust. A special NASA research instrument examined the light reflected off the moon's surface. It turned out that the composition of the satellite's poles was very different from the rest of it. The moon's surface is dotted with iron-rich rocks, but without oxygen and liquid water, rust can't appear. Solar winds add to the mystery. They bombard the moon with hydrogen, and hydrogen makes it much more difficult for hematite to form. Even though the moon doesn't have an atmosphere, it still has some trace amounts of oxygen. Its source is our planet's upper atmosphere. Earth also protects the moon from almost 100% of solar winds, although not all the time. And even though our natural satellite is bone dry, there might be water ice in the shadowed craters on its far side. A day on Uranus lasts 17 hours, 14 minutes, and 24 seconds. But get this, the planet has a tilt of around 98 degrees, and that makes a season on the gas giant last 21 Earth years. Mars has 2 moons, Phobos and Deimos. In the next 30 to 50 million years, Mars's gravitational forces will tear Phobos apart, and it will likely result in the formation of a ring around the planet. The Earth is the densest in the solar system. At the Earth's center, there's a core that takes up 15% of the planet's volume. It consists of 2 parts, the outer and the inner core. The inner core is a solid ball made of iron and nickel. Its radius is 760 miles, which makes 20% of the entire Earth's radius and 80% of the Moon's radius. The 1,500-mile thick outer core is liquid. It also consists of iron and nickel, but it's not under enough pressure to be solid. Mars houses the biggest volcano in the solar system. While everything seems to be calm on Mars nowadays, in the past, some sort of force caused enormous volcanoes to form and erupt. One of these volcanoes is Olympus Mons. It's 16 miles tall, which is the height of 3 Mount Everests, and 374 miles across, making it about the size of Arizona. The volcano grew to such a gargantuan size because of the weak gravity on Mars and the lack of tectonic plate movement. Gravity is not the same everywhere. The rocks, metals, and other minerals and substances that make up the planet are packed into the ground more tightly in certain places than in others. This has surprising consequences. Gravity varies slightly depending on where you are. You weigh 0.5% less standing at the equator than you do at the poles. In most cases, that's a difference of less than 1 pound. How high up you are also has an effect. So if you were at the top of Mount Everest, you'd also weigh slightly less. Just don't look down. Earth's toughest living thing is so small you can't see it. Water bears, also known as moss piglets, are cute little creatures with 8 legs and squashed up heads that are less than 1/100th of an inch in length. Despite their microscopic stature, they can basically survive anywhere. They prefer bits of wet moss or the bottom of a lake, but they won't complain if you put them somewhere really uncomfortable. They can endure extreme cold and incredible heat, and survive both huge pressure and high radiation. Some of the little bears once even managed to survive unprotected in outer space for 10 days without a problem. That is tough. They handle all these things by rolling up into a ball and hibernating, which reduces their need for oxygen and food. The moon's gravity is about 17% of that on Earth. If you weighed 200 pounds on our home planet, on the moon, your weight would decrease to a mere 34 pounds. You would also be able to carry stuff 6 times heavier than what you can carry on Earth. It would also be easier to walk on the moon's surface, but it would be more dangerous too. Your feet, inside a heavy spacesuit, would sink into the lunar soil up to 6 inches deep. But let's imagine you decided to skip the tedious process of walking by leaping through the air. Then you'd likely lose control of your jumps in no time. Plus, the moon's surface is littered with deep craters. It would be a tough feat to avoid all of them. You can see solar eclipses because even though the moon is 400 times smaller than the sun, it's also 400 times closer to Earth. So it's perfectly capable of obscuring the star. But in 50 million years, I won't be around then. The Moon won't be able to block the Sun completely because of the satellite's changing orbit. A full NASA spacesuit costs an unbelievable $12 million. Yeah, I can believe that. 70% of this hefty sum is for the control module and backpack. At the very center of Uranus, there's a rocky core, small, just half the Earth's mass. Compared to other planets, Uranus's core is rather cool, 9,000 degrees Fahrenheit. An ice mantle surrounds the solid core, and that's the largest portion of the planet, about 80%. It's also not the ice you might be thinking about. It's a hot, dense fluid made up of water, ammonia, ice, and methane, sometimes referred to as a water-ammonia ocean. Uranus's atmosphere is mostly hydrogen and helium, but it has its blue-green color because of methane gas that absorbs the red light. The ocean on Jupiter is larger than any other in the solar system. But unlike Earth's oceans, it's made not of water, but of metallic hydrogen. The ocean's depth is a mind-blowing 25,000 miles. That's almost the same as the distance around Earth. Venus is a champ when it comes to volcanoes. The planet has about 1,600 major ones, but none of them is known to erupt. There's a supermassive black hole 250 million light-years away from us. It hums the deepest sound ever detected from any object in the universe. It's 57 octaves lower than the middle C on your piano. That's 1 quadrillion times deeper than what we can hear. Mercury is a few billion years old. In 2016, scientists discovered some abnormalities on the planet's surface, showing that it's getting smaller. After more research, they found out that Mercury hadn't finished cooling down yet. There are planets that aren't bound to any star orbit and aimlessly wander through outer space. Among the most spectacular-looking space objects are pulsars. Pulsars are a type of neutron star. They shoot out some of their material almost at the speed of light. Regular pulsars spin at a reasonable speed, between 1/10 to 60 times per second. But millisecond pulsars can spin at an impressive 700 times a second, which is way too fast for the human eye to even process. As they spin, they emit a beam of radiation from their axis that looks like the light from a lighthouse. Astronomers can notice pulsars when they face Earth, since it looks like a light being shined on our planet. When the light shines elsewhere, the pulsar can't be seen. Our Sun is insanely massive. Want some proof? 99.86% of all the mass in the solar system is the mass of the Sun. In particular, the hydrogen and helium it's made of. The remaining 0.14% is mostly the mass of the solar system's 8 planets. Saturn's rings are very thin compared to its size. If you had a scale model of the planet that was 3 feet wide, the rings would be 10,000 times thinner than a razor blade. Even though Venus is the hottest planet in our solar system, it still has snow. But not what you'd expect. It snows metals and rains acid. Not a great vacation spot.
In a galaxy far, far away, we found the most luminous object ever discovered, ASASSN 151H. Astronomers were left scratching their heads, wondering what kind of beast could produce such a mind-boggling amount of energy. But just when they thought they had this cosmic enigma all figured out, this object vanished into the depths of space, leaving behind nothing but a faint memory and a few bewildered astronomers. Fast forward to today, and it seems the universe has decided to play a cosmic prank on us. That's right, folks, ASASSN 151H is back, and now it's brighter than ever. So let's take a look at this impossibly bright space object. This event was first detected on June 14, 2015. We noticed it in the southern constellation Indus. It was located within a faint galaxy, which goes to show that sometimes the brightest things come from the most unexpected places. It's like finding a diamond in a pile of rocks or a chocolate chip in a batch of oatmeal raisin cookies. No offense to oatmeal raisin lovers out there. ASASSN 151H was so luminous that if it were in our own galaxy, it would shine brighter than the full moon. Imagine that, no night, no stars. Just this mysterious thing lighting up the sky like a giant flashlight. Wouldn't that be cool? And kind of terrifying. But in all seriousness, it was a fascinating astronomical event. At its peak, it was 570 billion times brighter than our sun. That's so bright you'd be blinded by the sight of it even from afar. So picture this, it's 2015 and astronomers discover the brightest object ever observed. It was one crazy discovery because scientists had no idea what it could be. Is it a supernova? Is that TDE? What in the world is this thing? But then, as soon as they started to study this thing, it started to fade away. That was a huge bummer. Scientists could only sit with their theories and wonder what it could be. But then, against all odds, ASASSN 151H did the astronomical equivalent of a double take, and suddenly got brighter again. Astronomers were like, wait, what? Is that thing coming back from the underworld? For 40 days, its ultraviolet radiation charged up and increased fivefold. Then it plateaued for a couple of months before finally dropping away again. And then astronomers were like, okay, that's just weird. So, what is this thing, and what caused its resurgence? Well, there are a few theories. First up, we have the superluminous supernova theory. A supernova is like a star's grand finale. When a star runs out of fuel, it reaches the end of its life, and then it undergoes a cataclysmic event, releasing a tremendous amount of energy and light. And this beautiful, crazily bright event is called supernova. It's like the ultimate mic drop, except the mic is the entire star. So, some astronomers think that this mysterious object might be a supernova, but a really, really big one. If once it was a star, it probably was 100 times more massive than the Sun. We've never seen such supernovae before, but maybe this star was gigantic and really loved attention. Next, we have the magnetar theory. So, during the supernova event, the core of the star collapses in on itself and forms a very dense object. Imagine a marshmallow the size of a mountain. Now, squeeze that marshmallow until it's about the size of an actual marshmallow. It's so dense that if you could somehow stand on the surface of a neutron star, which you can't because you'd be squashed by gravity, you'd weigh as much as 1 billion elephants. That's kind of what happens to a star after its fuel runs out. This super dense leftover core is called a neutron star. So you could say that a supernova is like a star's big send-off party, where it goes out in a blaze of glory, and a neutron star is what's left over after the party's over, like the empty pizza boxes and beer cans left after a wild night with friends. So, some scientists think that ASASN 151H might be something like that. They think that it was a star that ran out of fuel and became a neutron star. Then it spun so fast that it burst out super hot jets of material. It's like when you spray water out of a hose, but the water is really, really hot. These jets can heat up the stuff around them and make the supernova even brighter than usual. But our mysterious friend was even brighter than that, so this theory might be wrong. But that's okay, we still have a few others. Another theory says that it was caused by the collision of 2 neutron stars. Such a collision would cause a real grand spectacle, with clouds of glitter and all that stuff. Another cool idea is that ASASSN 151H might have been caused by a supermassive black hole tearing apart a star that got too close. It's like if a hungry monster grabbed a hold of a tasty treat, but instead of eating it, it just tore it to shreds and made a huge mess. This one's probably the coolest. And lastly, the most boring explanation. This theory suggests that this mysterious object might not be as bright as we think it is. Instead, its light is being magnified by a galaxy cluster or some other massive object in space. It's kind of like if you put on a pair of glasses that make everything look bigger and brighter. So, these were all the possible explanations of this event. And if these mysteries weren't enough, then remember that scientists have no idea why this object could start glowing again. They thought that maybe it ran into some nearby gas that made it a bit brighter. But then they checked if that was the case and didn't see anything. So, 2-0 in favor of the weird bright thing. In other words, ASASSN 151H remains a mystery. It's still keeping astronomers on their toes and saying, "You thought you knew everything about supernovae? Think again, puny humans." And this isn't the only mystery in our universe. There are tons of things that scientists still can't explain. For example, have you heard of dark matter? No, it's not a group of Goth particles, but it's something even more mysterious. Dark matter is a substance that makes up about 27% of the entire universe. Yet, we can't see, touch, or taste it, even though it's hiding in plain sight. Scientists know that it's there because it has a gravitational pull on visible matter, kind of like how a good cheeseburger has a gravitational pull on me. The weirdest thing about dark matter is that we have no idea what it's made of. It's a mystery box, except we can't even see the box itself. And the mystery of dark matter still keeps scientists up at night. Another dark mystery is the elusive and enigmatic dark energy. It makes up about 68% of the universe, but we still have no idea what it is. Both of these are called dark because they don't interact with light or any other form of electromagnetic radiation. In other words, even though we know they exist, we can't see them directly. Can you imagine? We can only see about 5% of the universe. Who knows what else might be hiding there? One day, scientists noticed that the universe was expanding faster and faster over time. But it must be impossible, right? After the Big Bang, the expansion of our universe should gradually lose speed, like everything in nature. However, this wasn't the case. So something must be pushing it, right? And that's how scientists came up with dark energy. A mysterious force that's thought to be pushing the universe and making it accelerate over time. But what causes it? Scientists still have no idea. And until we figure out what all these things are, they will remain one of the greatest mysteries of our universe. So, our mysteriously bright object isn't even one of the biggest puzzles. We still have tons of things to explain. Who knows what other secrets the universe is hiding from us? Either way, let's hope that one day we'll learn more about our world and answer these questions.
Mercury gets a bad rap for always being hot, but that's not entirely true. The planet's got no atmosphere, so its temperature swings are wild. When it's facing the sun, it can get up to a blistering 800 degrees Fahrenheit, but when it's turned away, it drops to a frigid minus 290 degrees. The reason for this is that Earth has a cozy atmosphere that keeps our temps in check. Mercury doesn't have that luxury, so it's at the mercy of the sun's rays. But despite all that, Mercury's still worth checking out. It's close to the sun, which makes it a prime spot for studying how solar radiation affects planets. And even though it's not exactly hospitable to life, there are still plenty of mysteries to unravel. Venus is often referred to as the sister planet of Earth. Yeah, many people believe that it's this beautiful and lush planet, just like our home. But boy, are they wrong. In reality, Venus is a total diva. She's got this thick atmosphere that traps heat and causes surface temperatures to reach up to a scorching 864 degrees Fahrenheit. I mean, I get it. Venus wants to stand out and be unique, but she's taken it to a whole new level. She's like that one friend who always has to one-up everyone else. Oh, you think Earth is cool? Well, I'm the only planet that spins clockwise. Beat that. But let's be real here. Venus is just trying too hard. She's got these crazy sulfuric acid clouds that rain down on her surface and make it impossible for anything to survive. It's like she's trying to keep all the attention for herself by making sure no other life forms can exist. And her atmosphere, It's so thick and heavy that it would crush us like a grape. So, yeah, Venus may look pretty from afar with her bright yellowish glow, but don't fall for that. She's a total drama queen who just can't handle sharing the spotlight with anyone else. Anyway, enough about Venus. Let's focus on the real star of the show, Earth. We may not have all the flashy features that Venus has, but at least we're hospitable and welcoming to all forms of life. Plus, we've got pizza. So who needs sulfuric acid clouds anyway? You may think that since we live on this planet, we know it from A to Z, and there is no room for any misconception. Alrighty, then tell me, what shape is Earth? If you say it's round, sorry, but you're not right. So, our planet may look like a ball, but it isn't a perfect one. You see, because of the spinning action, the north and south poles get squished a bit and they're sort of flat. The Earth's wobbling, and other stuff are actually causing it to change shape over time, but it's still roundish. Let's talk about Mars, the red planet that has fascinated humans for centuries. Now, I know we all have this idea that Mars is this habitable planet that we can just pack our bags and move to if Earth becomes uninhabitable. Nope, that's not entirely true. One common misconception about Mars is that it has a breathable atmosphere. While Mars does have an atmosphere, it is much thinner than Earth's and consists mostly of carbon dioxide, making it unsuitable for human life without extensive life support systems. So if you're planning on taking a stroll on the surface of Mars, you better pack your oxygen tanks. But hey, that doesn't mean we should give up on our dreams of colonizing Mars. Who knows? Maybe in a few decades, we'll be able to call Mars our second home. Some people think Jupiter is a solid planet, but let me tell you, that's just a bunch of hot air. Literally. Jupiter is actually a gas giant made up mostly of hydrogen and helium. It's so massive that it doesn't even have a solid surface. I mean, I thought my bed was soft, but floating on a cloud of gas sounds pretty comfy too. Jupiter's atmosphere gradually transitions into its interior, which means it's like a never-ending party in there. Saturn's rings are one of the most fascinating features of the planet. So, a common misconception about Saturn is that its rings are solid. In reality, Saturn's rings are made up of countless small particles of ice and rock that orbit the planet. They stretch out over 174,000 miles from the planet's surface, but are only about 65 feet thick. The particles that make up the rings range in size from tiny specks of dust to large boulders. Scientists believe that the rings were formed from debris left over after the formation of Saturn and its moons. Over time, the particles were pulled in by Saturn's gravity and formed into the beautiful rings we see today. Saturn's rings also have some amazing features, such as gaps and divisions caused by the gravitational pull of nearby moons. There are also waves and spiral patterns that are created by the gravitational interactions between the particles in the rings. Despite their beauty, Saturn's rings are constantly changing. The particles collide with each other, creating new ones and breaking apart others. This means that the rings we see today may look very different in the future. So next time you look up at Saturn and its rings, remember that you're looking at a cosmic snow globe made up of billions of tiny particles floating around the planet. Now, one common misconception about Uranus is that it's a lazy dude who can't even rotate properly. People think it just rolls around on its side all day long, but let me tell you, that's not entirely true. Sure, Uranus does have a tilted axis of rotation, but it still manages to spin in the same direction as most other planets in our solar system. It's like that one friend who always shows up late to the party, but still manages to have a good time and fit in with the crowd. But let's be real, Uranus is still a bit of an oddball. It's the only planet in our solar system that rotates on its side to such a degree. But after all, variety is the spice of life, right? So cheers to Uranus, the planet that refuses to conform to anyone's expectations. Ugh, I wish I had the guts to be like this. Have you ever heard someone say that Neptune is just a blue version of Jupiter or Saturn? Well, let me tell you, that's like saying a banana is just a yellow version of a cucumber. It's not even close. Sure, Neptune and its gas giant buddies share some similarities, but Neptune stands out in the crowd with its beautiful blue hue. It's all thanks to the methane chilling in its atmosphere. By the way, did you know that it's the farthest planet from the Sun? It's so far out there that it takes almost 165 Earth years for it to complete one orbit around the Sun. Talk about taking your sweet time. And let's not forget about its 14 moons. That's right, Neptune has a whole entourage of moons following it around like groupies at a concert. Maybe they're hoping to catch a glimpse of Neptune's famous blue glow. So next time someone tries to tell you that Neptune is just a knockoff version of Jupiter or Saturn, you can confidently correct them and say, "Excuse me, but Neptune is its own unique gas giant with a fancy blue vibe." Did you know that Pluto isn't actually considered a planet anymore? That's right, in 2006, the International Astronomical Union decided to reclassify Pluto as a dwarf planet. So what exactly does that mean? Well, a dwarf planet is a celestial body that orbits the Sun and is big enough to be rounded by its own gravity. But it hasn't cleared its orbit of other debris. It's a common misconception that Pluto is still considered a planet, but the truth is that it's just not big enough to make the cut. Sorry, Pluto. Don't worry though, you may be small, but you're still loved by many. Plus, being a dwarf planet is pretty cool too. You get to hang out with other celestial misfits like Ceres and Haumea. So keep on